Imran.
Yes, what are your objectives? You have studied in Bangalore City.
Sir, you can start sharing the screen.
Yes, sir. Yes, ma'am. That will be perfect. Agriculture and
ಸರ್ ಆಡಿಯೋ ಕನೆಕ್ಟ್ ಆಗಿಲ್ಲ. ಈಗ ಆಯ್ತು ನೋಡಿ. ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ. ಇಲ್ಲ ಈಗ ಕರೆಕ್ಟ್ ಇದೆ, ಕೇಳ್ತಾ ಇದೆ.
ಕೇಳ್ತಾ ಇದೆಯಲ್ಲ?
ಹೌದು ಕೇಳ್ತಾ ಇದೆ. ಓಕೆ
ರೈಟ್ ನಿಮ್ದು ಆಗಿದೆ.
ಮೊಬೈಲ್ ಆಫ್ ಮಾಡಿ ಸರ್. ಓಕೆ ಮೈಕ್ ಸ್ವಾಮಿ ನಮಸ್ಕಾರ.
ನಮಸ್ಕಾರ ಸ್ವಾಮಿ.
ನಮಸ್ಕಾರ
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ.
ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರ.
ಎಲ್ರಿಗೂ
ಚೆನ್ನಾಗಿದ್ದೀರಾ?
ಚೆನ್ನಾಗಿ.
ತುಂಬಾ ಧನ್ಯವಾದಗಳು.
ಥ್ಯಾಂಕ್ ಯು.
ಪ್ರಾಬ್ಲಮ್ ಐ ಆಮ್ ಸ್ಪೀಕಿಂಗ್ ಕನ್ನಡ, he is replying in English.
Yes.
How to learn Kannada? Tell me.
Immediately if you use, that will come.
वेरी गुड. वो नहीं यूट्यूब से कुछ पॉइंट्स दे दो आप. यूट्यूब में है ना? हाँ वो आज नहीं कल, आज नहीं कब के खाते हैं मुझे कल तक लास्ट से हमको ह्यूमन वाइल्ड लाइफ छोड़ के बाकी सब कर देना. वो रिपोर्ट से मिल जाएगा. मैं उनको बोल दो. हाँ सबको रिपोर्ट मैंने कल माइकल को बोला था. हाँ वो तो रिपोर्ट था ना. मैंने तो सबको बोलो. सबको इनॉग्रेशन का सारे रिपोर्ट को बोलो मुझे एक्सेप्ट वाइल्ड लाइफ कंसेप्ट, क्योंकि वो उसी समय दे देगा मुझे. वो मैं भी कुछ पॉइंट्स बना लूंगा या वैसे. लेकिन सारी कल मतलब उससे लास्ट पैनल से पहले का सारा मुझे पीपीटी चाहिए. पीपीटी में विद फोटोज ऑफ सम डिग्निटरीज एंड ऑल. कुछ वहां से लेके कुछ वहां से लेके सब. इनॉग्रेशन जब चल रहा था मैं नोट ही कर रहा था. अच्छा पीपीटी बना लिया. पीपीटी ने मैंने नोट करके इसको ईमेल को भेजा. फिर रिपोर्ट इनको भेजेंगे ना. आप कंपाइल आपको करना पड़ेगा. कंपाइल ओके ट्राई कर. हां नहीं ट्राई नहीं करना ही है. कौन करेगा फिर? और कोई है ही नहीं. ये तो यहाँ बिजली है तो इसे हेयर टू कोऑर्डिनेट. अदरवाइज देन आई सेंट ऑन मेल टू यू एंड ऑल मृणालिनी सबको नाथकर्णी सरकारी रिप्लाई टू फरिश्ते. वहां से भी कुछ पॉइंट्स लेना. और उसके बाद मृणालिनी को मैंने बोला आपकी हेल्प करने के लिए. मॉडरेटर कॉन्स्टिट्यूशन का अच्छा ठीक है आप करेंगे. मैं बोलता सोडी कुछ में जिंदगी के बारे में कुछ सीखना तो सोडी साहब से सीखिए. वो सोडी साहब 4 बजे उठते हमेशा. और योगा मतलब रामदेव जी खेल. मैं सच बता रहा हूँ. सर नमस्ते.
नमस्कार सर. नमस्कार.
वेलकम.
नमस्कार सर. नमस्कार डॉक्टर.
नमस्कार जी. नमस्कार. और हाउ आर यू? फाइन सर.
I am fine sir.
We are fine.
Happy to see you.
Good.
Yes.
Please come. Please you are. अरे इसका मतलब ये है कि आज मतलब इनोरल नहीं तो फोटो नहीं खींचनी है. फोटो भी अभी नहीं. कितने लोग आए अभी? Oh. What happened? Oh, we can ask, na? So, when she comes. थोड़ा बाल जाने चाहिए, बाल करेगी.
It's okay, sir.
Yeah, we can.
All right.
आगे सब लोग एक पीछे से भी लेना, एक पीछे से. अच्छा, इमरान, मैं फिर सर ने पीपीटी भेजा. इसने विश्वास का पीपीटी आगे था. इसने विश्वास के भी आगे ना. This is the problem. They should send to. So, what is the good morning? Before I request moderator to take over and to request a chair to conduct to start the program, I would like to know how many of our speakers are already joined. Professor Sodi is there. Good morning, sir.
Good morning,
Professor Dr. Amit Kumar. Good morning. Dr. Amit Kumar, good morning. Madam Vedya, good morning.
Good morning, sir.
Good morning, sir.
Good morning. Good to see. So we have two invited speakers already here. So and then we say Mr. Tapas Ray is there. No. Then Prerna Sarin. Okay.
Please.
Syed Tosif Ahmed, Ramakrishna Narathiga, okay, Dr. S. Yogeshwari, Dr. Adil Manjur Nanda. So it's perfect. We have both the invited speakers. Now time is exactly 9:30. Imran, now begin the. Hand over the mic to Imran. Imran, now you may start conducting this interesting session, and the floor is yours, and you are chairperson of the session, Professor C.M. Lakshmana. I welcome you all on behalf of our organizing committee. Thank you so very much.
So good morning to all. I would like to invite all the participants to the technical session 3, that is climate change impacts and challenges. We feel privileged to have Professor C.M. Lakshmana from PRC, ISEC, as the chair of the session. There are total 7 speakers and 2 invited lecturers are there. Now I would like to request Professor C.M. Lakshmana to conduct the session.
Okay. Thank you, friends and national and international participants. I am really excited and really I am happy to see this 3-day international workshop which is organized by the CNNR. I must thank the leader of this workshop, Professor Sunil Natiyal and his team. It is due to under the COVID situation, this workshop has been organized very well. Before I start, I would like to thank them for this wonderful event which is organized by ISEC. Before this is my responsibility to conduct the the presentation. We have already seen. Sir, it is the coming audible. Hello?
Yes, sir. Yes, sir.
Yeah.
So we know already. I would like to take a few minutes to give an explanation. You are here waiting to give your presentations. You are an expert in the climate change. However, today, if you look at this India, I think Indians exposed to heat waves increased by 200% from 2010 to 2016. The heat waves also affect farm labor productivity, temperature are rising, drought, and wildfires are starting to occur more frequently. However, The negative impacts of global warming includes even it is reduced crop quantity and quality due to the reduced growth period, etc. However, the latest the global climate risk index has shown the extreme weather events and the socio-economic losses. Even if you look at the international level, the Japan and Philippines and Germany are the most affected places by climate change today. So in this context, the organization of this international workshop is relevant and very important to this juncture. Friends, the allotted time is very strict. We have to maintain. It is very restricted. As it is already listed, there are two invited lectures. Please take your time, 8 minutes, 8 to 9 minutes, and other speakers, please finish your presentation within 7 minutes. Rest of the time, at least 10 to 15 minutes, we will have a discussion and we could take some few questions. And this I request, please go through your presentations, briefing about our contents of the paper, methodology, findings, and the policy implications. With these few words, we will begin with the first invited lecture by Professor Indrajit Singh. Sir, your time is start. Please go to your presentation and finish it up within the due time. Thank you.
Very good morning. Very good morning, sir.
Good morning. Good morning.
Can you see the slide?
Yes,
PPT? PPT is there?
Right, sir.
PPT is there?
Yeah, it is there.
Yes, sir. Yes, sir. Please,
Okay.
Please go ahead.
put
Thank
it in
you.
slideshow, sir.
Huh?
In slideshow, sir.
Huh. So I'm thankful to the organizer, to the director of ISAC, to NIRD, as well as my brother, Professor Sunil Notial, and Professor CM Lakshman, sir. So I'm going to present on efforts for resilient cities in India, issues and challenges. The study is based on reports of Ministry of Housing and Urban Development, National Disaster Management, National Institute of Research Disaster, as well as international level organizations like United Nations, Rockwell Foundations, World Bank, and others. And basically, I am trying to focus on whether in India, the concept of resilient city is effective, whether it is sustainable. On that basis, on that background, I'm trying to find out. According to UNISDR, the disaster risk reduction, if we talk about activities, it comprises 10 essentials. So whether those 10 essentials for making cities resilient are available in some cities of India, that is one of the main issues, if we talk about. The 10 essentials, as we know, are engage, share understanding and coordinate, create financing and incentives, identify and understand perils, probabilities and impacts, make critical infrastructure disaster resilient, make education and healthcare infrastructure disaster resilient, apply risk-aware planning, land use and building codes, build public awareness and capacity, enhance and protect ecosystem services, create warning systems and rehearse preparedness. 10th essential is learn and build backwater. Only few Indian cities have taken resilience initiative, like particularly the Ahmedabad city in 2013 became the first city to implement heat wave early warning system and prepared plans in South Asia. Similarly, cities like Bangalore, Kolkata, Guwahati, etc. are also taking initiative mainly for water resilience, because water is a very crucial issue, as we all know. In 2017, the Rockefeller Foundation has chosen 4 cities in India, Surat, Chennai, Pune, and Jaipur, as part of its 100 Resilient Cities initiative to build resilience into cities across the world. The 100 Resilient Cities program lists urbanizations, lack of adequate planning, globalization, and climate change as the common problems these cities face. If you talk about the fourth city, the Surat has been experienced, as we know, rapid urbanization, but is also a climate change affected city, having experienced 23 floods in the last 100 years. Surat and 100 resilient cities urban resilience strategy mainly proposes concrete actions for improved mobility, increased access to affordable housing, improved water supply, and balanced economic growth. Whereas Chennai has gone through a number of cyclone and floods. Recently, we have seen Nivar cyclone 2 days before. So how it is trying to cope up with all these issues, that's why Rockefeller Foundation has chosen Chennai also. Pune, with its strong manufacturing base and growing IT and education sector, has seen its transportation sector with a lot of stress. It is also an earthquake-prone city. Pune's chief resilience officer has been paid for by the Rockefeller Foundation to work with the local government body to prepare for its future challenges. As far as for Jaipur, if we talk about, that is my home city, it is one of the oldest planned city in India. If you talk, it was the first city that was very much planned. And nowadays there is a rapid population growth and unplanned development. So due to which Rockefeller Foundation have chosen this Jaipur city also. The Pune city is eligible to receive following support from 100 city funding to the city. I have taken one city as Pune, as well as technical and capacity building services and support, access to platform for partners providing resources to enable implementation of resilience strategy and resilience related initiative, including finance, technology, infrastructure, land use, building design, communication, community engagement, and many more. Now, I'm going to conclude within 2-3 minutes. What are the issues for the resilient cities in India? Whether Sendai framework for disaster risk reduction is being adhered by Indian cities for resilience, whether the cities are ready to withstand climate related disasters, particularly in the face of rapid urbanization, whether Indian cities are making sincere efforts for resilience, whether central or state government or local government are supporting for the resilience of the cities by making plans, programs, or guidelines, issuing guidelines or instruction, whether cities have the ability to absorb, recover, and prepare for future shocks, particularly in context of economic, environmental, social, and institutions level. Whether parameters of resilience comprise of 6 interlinks R's, mainly robustness, redundancy, resourcefulness, reformability, recoverability, and rapidity are being followed by the cities. What policies, programs are being formulated for resilience in India? The major challenges for resilience lie in developing the necessary basic infrastructure for water, sanitation, drainage, improving roads, and supporting housing improvements. Recurring disasters, earthquake, floods, cyclone, droughts, accident, fire, etc. should make us rethink how we can make the city more resilient. If you talk about whether cities in India are able to look into 4 factors with the future shocks: economic wise, society wise, environment, as well as institution or governance. Whether in India, the city resilience frameworks are being followed, is being adhered. So there are many framework which has been developed by the international agency, particularly Rockefeller Foundation and others.
Other 2 minutes, sir, please.
No doubt, climate resilient city in India, some of them are trying to develop the capability to reduce and manage the negative impacts of climate change, because these cities have planned and factored these changes in their development goals and planning by utilizing climate information, mainly of the past and future, to identify climate stresses typical to their city or region, preparing and implementing strategy to reduce vulnerability of population and city system, adapting to change, preparing and responding to disaster, mitigating GHG emissions.
Please, another 2 minutes, sir.
Now my presentation is over. I already told to Professor Sunil Notial sir that I generally don't take much time like others. So that is my humble submission, and that overall conclusion ki India, we overall, even the citizen have to participate to achieve the objective of that means resilient cities. But I believe ki only few cities are taking initiative. It depends upon the sincerity of the central government, state government, local bodies, as well as that means we could say intensive participation of NGOs, research institutes like ISAC and some central universities, state university, as well as citizen. If they all contribute together, then we can achieve the objective of resilience. Thank you to the organizer for giving me time.
Thank you very much, sir, for completing your presentation within the stipulated time. Friends, now we will move on to the next presentation. Before that, I would like to ask, please, if you have any questions, at the end we will take, depend upon the time, please put your questions or queries in the chat box. The respective presenters will answer to your queries. But then it is depend upon the time, we will take the questions at the end. Now we will move on to the second presentation. That is Dr. Amit Kumar. The presentation title is Urban Hazard Risk Monitoring in the Changing Climate Condition in Indian Cities Using Geoinformatics. I am a geographer. I am very interesting to see this presentation. Please go ahead, madam.
Good morning. Hello.
Hello.
Good morning.
Yeah, I'm audible. Just I'm trying to share my screen. Just give me a minute, please.
Yeah. Okay.
Good morning, Professor Chatukulam, sir.
I'm just logging out, sir, just for a minute because I have to screen. I'm not able to do it.
Where is Chatukulam, sir? Chatukulam.
Very good morning, Professor Lakshmanaji.
Sir, namaskar. How are you?
Good morning. Fine.
Thank you.
Go ahead.
I am happy to see you.
Now only I could understand you are a geographer. I thought that you are a demographer.
Yes, sir. Basically, I am a geographer.
Oh, fine. Excellent. I like that.
To demography.
Oh, excellent.
So, what has happened, Imran? Please ask. Imran.
Yes, sir. I'm trying to log in because I need to give preference. Give me a second, please, sir.
Because very time is very strict, sir.
Yeah. Oh.
Yeah, Professor Lakshmana, you could request updates also to upload everything in there, and then they can just put in the share.
What happened? 10:45. Okay. It took almost 2 minutes. Anyway, it will happen. Okay, 10:45 now.
Hello.
Yeah, minimize this. We are seeing.
Please go ahead.
Yes. Now we can slideshow start. Yeah.
Time 9:47.
Oh, yeah. Thank you, sir.
8 minutes, please.
For giving me a chance for this.
Okay.
May I start?
Please start.
Yeah. Good morning, one and all present here in this international conference. And as Professor Shodhi has demonstrated the insights of the resilient city, I would like to draw your attention towards some of the aspects of the Indian cities and through the that is being done through the remote sensing perspective and GIS analysis. So my topic of deliberation is urban hazard risk monitoring in the changing climate condition in Indian cities. The urban areas have multiplied and expanded rapidly over the past 2 centuries, and it is occupying 3% of the Earth's landmass, which accommodates almost 54% of the total global population. It is expected that the proportion of global population will exceed 60% by 2030, which will be 95% of the net future increase in the global population in cities. The climate change impacts and the associated risks to the population in urban areas are very complex, dynamic, and dependent, and largely influenced by the large concentration of population. Now, all megacities are exposed to natural and man-made disaster ranging from geological to meteorological events. In the changing climate scenario, the uneven urban growth and land transformation had triggered the frequency of hazard events, leading to a high exposure of risk and vulnerability, especially in the urban areas. The risk multiplies in the cities due to the increasing frequency of natural disaster in recent decades and due to the changing climate condition and the high concentration of population in the limited urban topography. In this, I'm representing the population growth in the major cities. The cities having the million per population are represented in the point form, and we have tried to put the population over to 2 periods. That exhibits like this cities shares approximately 64% of the total urban population and 31% of the total population of India. This contributes significantly to the socio-economic development of the country and also lead to a higher risk due to the increasing pressure of the population in the scenario of increasing hazardous events. The urban population in the middle plus cities increased rapidly in the last 4 decades, where it has increased from 23.27% to 31.16% with respect to the total population. The map exhibits the spatial distribution of the city with a million plus population in India as per 2015 and highlights the zone having a high concentration of major cities in the north like NCR region, south like Kerala, Karnataka and Tamil Nadu, west Maharashtra and Gujarat, east primarily the Kolkata. Though the northeastern, central and the eastern part of the country have a low concentration of cities and are less urbanized, barring a very few exceptions. In Indian megacities such as Delhi, Hyderabad, Ahmedabad, Surat, Indore have settled and developed along the river banks, while other like Chennai, Mumbai, Kolkata, Visakhapatnam, Kochi and Bhubaneswar urbanized as a majorly trade center in the initial days along the coast because of the strategic site and situation, and are prone to the various hazards due to the diverse physiographic locations and meteorological variabilities. Now, here I am representing the temperature patterns in the major Indian cities. The long-term mean temperature, long-term minimum mean temperature, minimum maximum temperature, and long-term mean temperature based on the CRU dataset 1901 to 2015 are represented here. That exhibit a more or less same pattern of like cities in the southern India have a higher values and it keep on reducing while moving northward. And at least in the when we moved to the northern side and extreme north side, it was the least values. And in contrast, the cities in the IGBP have the moderate mean maximum temperature and at least in the northern and northeastern cities. While the long-term standard deviation, this is the D map here, in the temperature, a higher deviation of the North Indian cities followed by Central Indian cities and least in the South Indian cities. The longitudinal pattern of the temperature are primarily influenced by the physiographic region and proximity to the coast also. The influence of the significant land transformation and large population density is not visible here, primarily due to the adopted averaging technique like mean method we have adopted here. So we have done the this analysis of sane slope based on the long-term analysis, and the long-term temperature trend based on the sane slope exhibit a high rise in the minimum temperature in the eastern coastal cities northern cities during the 115 years. In a similar pattern, a high rise in the maximum temperature and a long-term mean temperature was observed in the southern and selected central Indian cities, whereas the North Indian cities observed comparatively less mean maximum and mean temperature during 1901 to 2015. The study exhibits an overall rise in the long-term mean temperature and mean maximum, as well as mean minimum temperature over the last 115 years. This is the last D figure map is representing the difference between the daytime and nighttime temperature, and a rise in the diurnal temperature in the South and East Indian cities were observed, where it decreases in the North and West Indian Northern and West Indian cities as we move to. Now, in this, the long-term standard deviation of precipitation map is presented based on the again CRU data set of 1911-2015, and we found a high deviation in the western coastal cities and northeastern cities, whereas the majority of cities have low deviations. That is here. The long-term precipitation trends based on the Sen slope in the rising precipitation exhibits a rising precipitation trend in the south and western, except in cities in the Kerala, which experience a large negative trend, that is approximately less than like a minus 50 millimeter in precipitation pattern during the last 115 years. Similarly, the cities in IGBP also observed a significant decline.
Dear Amit, please come to conclusion. You have another 2 minutes.
Sure, sir. And in this, this is the particular case study in which I'm representing the spatial dimension of land transformation and population density in the 7 major cities of Himalayas during the period 1991 to 2018. This Himalayan region is very fragile ecosystem with unique biodiversity, but the rapid urban growth and haphazard land use transformation was observed that imposed an ecological threat to the entire landscape. The multi-satellite based study exhibit a remarkable increase, approximately 14% in the impervious surface, and a significant decline in the ecological infrastructure in the Himalayan cities. This is the one of the key slide of my presentation, in which I'm representing cities having the major disaster with the frequency during 1980 to 2080 based on the EMDATE data set, in order to map the influence of meteorological and geological hazard on major cities with the million-plus population. The frequency and intensity of natural hazard have increased in the recent decades and has induced higher risk due to the higher concentration of people in the limited spheres of the urban region. In the 4 decades, the frequency of natural disaster has increased approximately threefold, from 1,300 events to 3,900 events. The multi-hazard assessment during the last 4 decades exhibit a flood has emerged as the most prominent natural hazard in the Indian subcontinent, and the urban center in the East Indo-Gangetic Brahmaputra plain, followed by western coast regions, were considerably affected by the high number of hazard incidents during the period. The other significant hazards are drought, cyclone, earthquake, landslide, tsunami, followed by the heat wave and cold waves. It poses a particular threat to the life, urban infrastructure, energy supplies, transport connectivity, and risk multiplies because of the poor adaptation and resilience due to poverty, poor like degraded infrastructure somewhere, which further increase the severity to the disaster impacts of the communities. Now, one of the slide I would like to show here, this is out of the box, but I think it has some connections. Example from the Amphan cyclone very recently happened in the mid of this year. With the presence of the long-term, largest contiguous Sundarban mangrove, the gravity of the tropical cyclone Amphan was reduced after the landfall. And although it caused a catastrophic impact in the Kolkata metropolitan region, which is just the red one here, due to the high concentration of population and build-up structures, while mangrove forests contribute to reducing the cyclonic wind speed and breaks the waves to storm surge during the landfall.
So please conclude, sir. Sorry, please conclude.
Yeah. The conclusion of this presentation are the urban population in India has increased rapidly in last 4 decades and are influenced by the geography as well as the socioeconomic political factors at local, global, regional scale. In the last 4 decades, the frequency of natural hazard recorded an increase almost threefold that poses particular threats to the life and infrastructure to a large extent. In the changing climate scenario, and the large transformation disaster events have become more frequent and intense, leading to high exposure of risk, especially in the urban centers. And it required both structural and non-structural sustainable resilient methods at individual, local, and global scales to be adopted in the hazard-prone regions to avoid fatalities. And lastly, like urban EBDRR strategies targeting multi-hazard are required to be adopted considering the varying condition of the megacities. Thank you.
Thank you very much, sir. Due to time constraints, we were not able to provide. It is a very interesting presentation.
Thank you, sir.
Friends, now we have successfully completed 2 invited lectures. Now we will move on to the general presentations. Mr. Imran, out of 7, how many presenters are there?
All are there.
All are there, huh?
Yes, sir.
Okay, now we will begin with the presentation. Among the general presentations, Mr. Tapas Ray.
Yes, sir.
Okay, his presentation is on the spatial and temporal assessment of cropland residue burning in Chhattisgarh, India, using MODS based active fire data. Please, your time is 7 minutes. Please try to complete it, Mr. Tapas.
Good morning, all of you, sir, and thank you, organizer committee, respected chairperson, sir.
Yeah.
Is my PPT visible, sir?
Visible. Please go ahead.
Okay. Thank you, sir. And now I am going to present my presentation topic is that the spatial and temporal assessment of cropland residue burning in Chhattisgarh, and with the India using the MODIS-based active fire data. And this is my objective. Out of this, first is how the fire distribution and spatial temporal pattern of agriculture residue burning between the 2005 and 2019 in Chhattisgarh state. Second is where is the residue fire hotspot area in Chhattisgarh. And last is the identification of monthly and seasonal pattern of agriculture residue burning in Chhattisgarh. And this is my study area. The study area was carried out in the Chhattisgarh state, and we know that the Chhattisgarh is one of the largest production of paddy in India. About 45% area covered by the agriculture land in area in Chhattisgarh state. And mainly Chhattisgarh has divided into 3 distinct zones via the Northern Hill, Bastar Plateau, and Chhattisgarh Plain. The Northern Hill and Bastar Plateau are covered by hilly and natural forest, where Chhattisgarh Plain is primary agricultural land of the Chhattisgarh. In this part, the maximum area covered.
Mr. Tapas, please keep this study area and all those things. Please come to objectives. Few things on methodology, findings, and policy implications. Because time is very restricted.
In this area, the area under different land use uncovered classes in Chhattisgarh, and this maximum area covered in the agricultural land about 45%. And this is the data I used for this analysis: MODIS active fire data and land use uncovered data. And this is the methodology. Initially, 15 classes vegetation type map divided from the MODIS land cover were converted to vector file from the raster format. To drive the first file distribution over the various type of land and land cover observation were combined with the 15 types and land use land cover map. The incident of MODIS active fire points layer was covered on the vector file of a different vegetation map, and attribute information on point and polygon were joining are the software. The cropland map were overlapped on the active fire location point for the vector file generated by the fire detection algorithm, and fire point filing within the cropland was extracted. Now I'm going to my result is that the total of 54,200 about fire points were recorded in the all land use uncovered classes in Chhattisgarh. And the figure here is showing that the total number of fire in 2000 was 1,764, and which increased to the 3,240 in 2019. The number of cropland fire in 2005 was 135, which increased to 1,335 in 2019, which an average annual rate of 6.6%. And figure number V is showing that the cropland fire accounted for 0.78% of the total fire in 2005, which increased to 7% in 2019. The majority of fire detected in the cropland, which accounted for the 31%, followed by the deciduous broadleaf forest. The cropland fire were not evenly distributed across the study area, and the maximum fire point recorded in that central region of the Chhattisgarh, which accounted about 89%, which is the part of the central plain zone, and minimum number of fire points were recorded in the southern region, which are accounted as 6.7%, and northern, and which are accounted as a 3.6% of the Chhattisgarh, which are the part the Bastar Plateau and Northern Plateau respectively.
Yeah, another 2 minutes.
Okay. And there is a hotspot analysis of the cropland found in the central region also. And the temporal distribution of cropland fires show uneven in Chhattisgarh state. And the cropland residue burning peak was observed between the month of December to March, with the highest number of fire in the month of December, about 30%, and followed by January, February, and March.
Please conclude, Mr. Amit. Please conclude.
And this is the fire point clustering map. Now I'm going to conclusion.
Okay.
My study area is that agriculture residue burning analysis during the period from 2005 to 2019 in the state of Chhattisgarh revealed that cropland fire point were increased from 0.7% to the 7.8%, with the annual rate is 6.6%. The overall 89% of the cropland fire were recorded in the region of Chhattisgarh plain, which is the main agricultural land of this state, and about 30% of fire recorded in the month of December. In summary, result from this study highlight the distribution of fires and fire hotspot analysis is useful for the policy making, for the monitoring and managing cropland residue burning activities in Chhattisgarh.
Thank you, Mr. Tapas.
Thank you.
Okay, thank you. Friends, now we will listen the presentation by Dr. Sweta Baidya. Her presentation is on resilient landscape planning through green growth. Please take, madam, please, you have 7 minutes. Please try to finish it up.
Yes, sir.
Okay. 7 minutes.
Yes. Is my slide visible?
Yeah, visible. Please go ahead.
Thank you, sir. Thank you all for giving me this opportunity to speak here today. Today, I'll be talking about the resilient landscape planning through green growth. So basically, as we all know, that development of cities are exploiting the environment and it is leading to the instability. The healthy natural environment and its services are really important for the economic growth and human well-being, especially in developing countries like India, where the percentage is 26%, and in industrial countries, it is normally 2%. So it is seen that 20 to 24% of the global greenhouse gas emissions come from agricultural, forestry, and other land use, whereas the tropical peat fires accounts for 25% of the total greenhouse gas emissions from deforestation. Therefore, the economic growth is unstable without the natural resources. I'm not able to change my slide.
Not moving.
It's moving.
No.
Click on the slideshow. Yeah. Click on, yeah.
Right.
Sorry. Yes. Sustainable management is all about restoring the functions of the forest, waterways, agrarian, ecology, coastal and marine system. Though for this purpose, we have a lot of private sector investments, but the investments are really less than what we actually need. So there are many definitions about urban landscapes. Basically, the idea is the urban landscape is the outcome of natural and social activities that human beings are doing from past till now, And it includes all kinds of green spaces like parks, green corridors, open green spaces, and other spaces. Okay, so when we talk about sustainable landscape, the idea is the green spaces are the urban areas where natural and semi-natural ecosystem are converted into urban spaces. Now we want to go back to the previous condition of that land use, and here what we do is sustainable landscape management will target towards sustaining the healthy and functioning forests, agrarian landscapes, waterways, coastal and marine ecosystem. This will also include the forested lands, soil management and wetlands. So the urban landscape management is the management of the open spaces and green spaces like residential green spaces, parks, playgrounds, etc. So there are few classifications of urban green spaces, like it could be public green space, it could be private green space, it could be protected green space, it could be rivers, streams, lakes, or private gardens or institutional lands. So the most important characteristics of this urban landscape is it has natural and social and cultural values. The urban landscape will work towards the sustainable future and present, and this will provide some unique benefits to people's life. So there are some direct benefits like environmental benefits. So those are like it will reduce the urban heat island temperature. It will help in restoring the nature. It will reduce the pollution, especially air and surface water. It will economically and aesthetically help in say energy savings or in increasing property value, or and the last thing is the social and psychological benefits. It will help in recreation and human health recovery and maintaining the cultural heritage. So there are many indirect benefits also, like it will promote sustainability, improve the quality of life, raise public and political awareness, and finally it would help in interdepartmental cooperation and develop long-term funding and management opportunities. So the basic purpose of green growth strategy is to safeguard the future of the green spaces, to improve the quality of urban areas, and to make urban areas more attractive, to attract more resources from outside, and to enhance the well-being of the local people. So to strategize this, we have three basic steps. First of all, we will identify that what are the exact things that we want to do for our place. For that, we will secure political and public and professional.
You have another 2 minutes, please. Come to conclusion.
Yes.
2 minutes. You have another 2 minutes.
Right. So basically, then we will identify the local problems, and as per the problems, we'll go to the actions. So as a step, we can think of developing the renewable energy projects or peat mapping or management of important ecosystems, etc. So in COVID-19 situation, we can think of doing some creating some job opportunities for sustainable agricultural production and other spaces. And for this, we normally do the already tried and tested models. We apply those models to come up with the best results. And we have few recommendations, like we invest in the uptake of sustainable agricultural practices, or develop large scale restoration projects, or invest in infrastructure that is low impact. So for this, we have to generate policy frameworks, and for policy frameworks, national schemes have to come up for especially the key smallholder commodities, so that will also help in climate resilience, carbon storage, and ensuring long-term productivity. So finally, I'll come to the landscape finance. So this is one of the important process how we do it for landscape management. So landscape finance is basically the sustainable land use investment with socially equitable and environmental returns along with financial returns. So we have to think how we can stop the ecosystem degradation, soil erosion, and loss of valuable lands through desertification, and we have to manage intelligently. So we have few models for that. How this is a basic model of landscape financing, and through this we finally achieve one sustainable landscape. And also there are many other models, and this is another model which actually helps in catalyzing new sources to finance for mitigating deforestation, and we actually reverse the land degradation to achieve the sustainable land.
Your
And
time is up, madam.
that was my submission for today. Thank you, sir.
Thank you very much. Okay, friends, now without wasting time, I request Dr. Pliza Cyril Abraham. The presentation title is on willingness to pay for solar off-grid lighting in rural India. Please, again and again, I am requesting the presenter, please brief your introduction and objectives, findings, and conclusion, please, within 7 minutes. We don't have much time. Dr. Pliza.
Hello, sir. Am I audible?
Yeah, your video.
Hello, sir. Am I audible?
Yeah, you are audible. Please go ahead.
Sir, am I audible?
Please continue your presentation.
Can you
please start your presentation. Complete it within 7
share
minutes.
content? Can you see?
Okay.
You can see your screen. Yeah.
So,
Okay.
yes.
Yeah.
Yes. So my topic is base pyramid. Yeah. Base of the pyramid, households willingness to pay for solar off-grid lighting in rural India. So before beginning the presentation, this paper is a working paper from the Millenary project of giving solar off-grid study lamps to school kids in the rural India, especially in the poorest district of India. So this is a result. This paper is a result of, it's one of the working papers from that project. And from 1 million, now they have increased the target to 7 million. That is nearly 70 lakh school students in various parts of India, they got benefited by this. So we wanted to see the impact of that. Now, kerosene, as we all know, it is the most versatile, reliable, and dominant fuel in the rural households. It has got several uses, not just as fuel and this thing. It's even used as an insecticide in Indian villages. About 31,000 crore, more than 31,000 crores per annum. So it is revealed that 43% of rural households, a quick and effective, cost-effective energy solution is to give off-grid solar lighting to these Indian villages where grid connectivity, electricity grid connectivity is not there. And that's the reason why million solar Urja lamp has been given. This program is implemented that way. Next, it is implemented in 4 states, Madhya Pradesh, Rajasthan, Maharashtra, and Odisha. In the selected districts, districts, 97 criteria was 50% of the population should be.
Please move your PPT. Please move. Hello, Dr. Pliza.
51%
Hello, Dr. Pliza.
the household should belong to socially weaker section. And solar lamp was given at rupees 120. So it was not, it was subsidized. Rupees 120, which is less than $2. Rural people's affordability. Now the objective is to find the key factors in the base of pyramid houses, solar light, and they're showing. Hello, sir, can you hear me? I am sharing the PPT. I don't know what is happening.
there is some disturbance. Dear Dr.
Hello?
Pisa, are you
Can you
are
hear me? Hello,
you
can
are
you hear
audible?
me?
Yeah, some disturbance. Okay.
Hello?
Yeah. But some disturbance.
Hello, can you hear me?
No, it is one way.
Yes, yes. I think you can stop the PPT and
Yeah.
talk
Hello,
without
can you,
PPT.
Through audio.
can you, can you,
Please stop the
can you hear
video
me?
and please.
I can hear you, sir. I can hear you.
Okay, finish it up. Please come to conclusion within
Sir,
2 minutes.
can you see my objective slide now?
No,
Sorry,
no.
sir. Can you see my objective slide?
Your PPT is not visible now. It is
Okay. The
disconnected.
objective is to identify. Okay.
No, you please go to
Objective is to
findings
identify
conclusion within 2 minutes. Your time is up.
the factors.
Hello? Oh, Dr. Pliza. No, totally disconnected, Kamath.
Okay.
Still there.
It
Still
is
there.
about identifying the factors influence. Hello.
You can close. You can close your share screen and talk only. The bandwidth is not sufficient, I think. Please close the share screen.
Sir, I can see and hear you, sir.
No, close your PPT and please brief your conclusion within 2 minutes. Your time is also up. Another 2 minutes. Please, we have. Okay.
Hello. Hello.
Okay, thank you, Dr. Pliza. Please share your PPT with the organizers so that they will get back to others. So that is useful. Please. Okay, thank you for your good presentation, even though there are some difficulties. Friends, now we will move on to the next presentation by Mr. Syed Tausif Ahmad. Is ready?
Yes, sir.
Okay. His presentation is spatial mapping based on automatic and semi-automatic techniques using Sentinel-2 data of Jhelum Basin, Northwestern Himalaya. Mr. Syed, please take 7 minutes. Please,
okay, sir. Thank you very much.
Brief your introduction, even objectives and findings and conclusion. Please.
Okay.
7 minutes.
Thank you very much. A very good morning to all of you. My name is Syed Tausif, Research Scholar and Project Junior Research Fellow from the Department of Geography and Regional Development, University of Kashmir. Today, I am here with my presentation on glacial mapping based on automatic and semi-automatic techniques using Sentinel-2 data of Jhelum Basin, Northwestern Himalayas. I'm quite sure that everybody here would be aware about glaciers and climate change as such. So I would skip the introductory part and come directly over to methodology. Before coming over to methodology, I'll share here the study area map, which has been prepared by using Aster Digital Elevation Model. Here the green dots represent various meteorological stations, and the yellow patches along the boundaries represent various glacial entities. The data sets which have been used for compilation of this inventory are European Space Agency's Sentinel-2 and ISRO's Resource@Disport data. Aster Digital Elevation Model has been used for calculation of various topographic parameters like elevation, slope, aspect, hypsometry, etc. Also, the outline is from previous glacial inventories like ICI MOD, Geological Survey of India, Space Application Center has been used to guide the distribution and location of various glaciers. Now moving to the methodology part, the glaciers were first delineated automatically using normalized difference, snow index, and band ratioing of near infrared and shortwave infrared bands. Using this method, a clean glacier ice mask was generated in a binary image for each dataset and subsequently converted into vector formats. However, several misclassified glacier areas such as shadows and isolated rocks were present on the vector format, which were then easily eliminated by post-processing to discern the glacier outlines accurately. As I said, the topographic information was calculated based on advanced space-bound thermal emission and reflection radiometer. So I'll skip the topographic information. Furthermore, in order to validate the topographic and glacier parameters, the 3 benchmark glaciers like Nahnar, Kolai, and Shishram have been selected. Based on these field expeditions to selected glaciers, the topographic parameters were calculated and validated. On the right side of the slide, here is the graph showing hypsometry of various glaciers of Jhelum Basin. Coming over to results, the inventory generated for the year 2018 and 19 in the Jhelum Basin consists of 310 glacial entities, which were larger than 0.01 square kilometers area. This is the recommended threshold given by ROP and Khalsa, with the total glaciated area of 106.5 square kilometers. Estimations of glacier volume based on volume area scaling proposed by Chen and Ohmura and Behar et al. Reveal the total ice reserves in the Jhelum Basin were to be 3.94 cubic kilometers. Similarly, the average depth for the glaciers of Jhelum Basin was found to be 20.8 meters. The glaciers which have been mapped are predominantly cirque and small valley glaciers and occur in most of the valleys lying above 3,400 meters above sea level. I have also attached a hyperlink here. Because of time constraints, I won't be able to share here. As far as frequency distribution of glaciers is concerned, the glaciers were further classified into different size classes. Around 85% of the glaciers feature an area lower than 0.5 square kilometers, covering about 40 square kilometers of whole glaciated area. On the other hand, glaciers larger than 0.5 square kilometers comprises of 44 in number and covers 66 square kilometers of whole glaciated area. As far as watershed-wise frequency distribution is concerned, the 3 catchments of Sindh, Ladr, and Visho are the widest and richest of the Jhelum sub-basins, both in terms of number and aerial coverage of glaciers. These cover about 86% of whole glaciated surface and featuring the highest number of glaciers, 72% of the Jhelum Basin glaciers. And this is the final map of the Sentinel inventory glaciers over Jhelum and its sub-basins. As I mentioned earlier, that these 2 basins, Ladr and Sindh, are the widest in terms of number and the aerial coverage. Here, finally, I'm sharing some of the photographs which me and my team have taken over some of the glaciers by carrying some glacial expeditions, glacial activities. Here we can see that me and my friend are installing a snow stake for estimating glaciological mass balance. Here again, we are recording a snout position of one of the glaciers, Nahnar Glacier. Thank you very much.
Thank you. Thank you, Mr. Saeed, for completing your presentation, even though on time. Anyway, thank you very much. It was very interesting. Friends, now we will move on to the next presentation by Mr. Ramakrishna Nalitiga. His presentation is on urban civic services delivery and climate change. Interesting. Please go ahead. Your time will start.
Yes, sir.
Mr. Ramakrishna.
Yes, sir. Yes, sir.
Okay, no problem.
Yeah. Yeah. Very good morning. Thanks for the opportunity given here. This is a brief presentation on the civic services delivery in the context of climate change challenges, a study of the 2 cities as a part of the ongoing research. The structure is like we are going to discuss very briefly about the cities and climate change and how climate change and infrastructure also are interlinked, particularly in the context of resilience, as it has been outlined in the morning. The civic infrastructure is very important for the cities to become more resilient in the context of climate change. And the current study approach we will discuss, and then the status and vulnerability of the civic infrastructure of the cities with reference to the core civic infrastructure services, 6 core civic infrastructure services we'll examine. And finally, I'll bring out the conclusions. And if you look at much of the research has been focusing on the cities as a contributors to the greenhouse gas emissions and therefore contributing to the climate change. And much of the focus has been laid down for a very long time on that cities as a causal factors of the emissions. But important aspect is that, like, the cities are also bearing the consequences of the climate change because they are the concentrations of the huge amount of population, a large amount of infrastructure, and a large amount of economic activity. Everything is concentrated in the cities. Therefore, they are much more vulnerable to the impacts that are arising from the climate change impacts, climate consequences. So if you look at the vulnerability dimensions, then we are not looking about the technical vulnerability, but we are just looking at how they are thematically related to the vulnerability. One important aspect which can affect the vulnerability of the cities is the heat islands effect because of the warming which is going to happen. And this heat island effect is basically because of the fact that, like, the built environment is going to absorb a lot of radiation, and in the absence of vegetation, the warming is going to be much more than what it is normally. Similarly, the another consequence is the extreme events occurrence, like that of the heat waves, floods, droughts, and heavy downpours, like we have been witnessing for a very long time, and also the coastal flooding, which are expected to come along with the climate change. So the vulnerability of the cities has to be seen as, like, how they are vulnerable for these kind of consequences of the climate change. And this vulnerability is shaped up by the cultural, demographic, and economic characteristics of the citizens, and also the local government's institutional capacity. That's where the civic infrastructure services will come into picture. The built environment characteristics are important, and the way the humans are contributing, interacting with the environment towards polluting, leading to more and more local pollution, is also an important aspect. And therefore, we are trying to just bring about some kind of focus on this vulnerability dimension, but we are not doing any kind of a quantitative approach, but we are using a case study approach. As I already said, the vulnerability of the cities to the climate change impacts is much more, and which has not been emphasized much. And it is particularly more so than the GHG emissions per se, where the focus has been laid down. And importantly, the civic infrastructure are important because these provide a lot of support to the economic and economic activity, as well as the contribute to the sustainable development goals of the whole community as a whole. And these infrastructure services have also got a lot of distributional benefits, where the poor are going to have a lot of benefits. And also, there, in the absence of them, the alternatives tend to be very, very costly. So therefore, the climate change certainly is going to exacerbate this vulnerability of this current infrastructure services, because of the various impacts that it is going to cause. And also, we need to look at how cities are prepared in this context of the climate change impact as far as the civic services delivery is concerned. So we are looking at the two cities, Hyderabad and Pune, and which are both inland cities with a similar spatial form. And we are doing a comparative analysis of the civic infrastructure services on how they are prepared and vulnerable to the climate change impacts. One important thing which we have to keep in mind is that, like, in the Pune, the local government body, the Pune Municipal Corporation, has all the core services which we are examining, whereas in the Hyderabad, the GHMC provides all of them, but except the water supply and sewerage, which is taken care by the human Hyderabad Metro Water Supply Sewerage Board, like the Bangalore has got. So there are some changes, there are some differences in the institutional structure. If we look at the first important service provided by the urban local governments, and which is important for the cities, is the water supply system. If we look at compare the city, Hyderabad and Pune, Hyderabad is sourcing mostly from the reservoir impoundments and lakes. And what is happening is that, like, most of as the time began to progress from the city lakes which were nearby, it began to depend upon the reservoir impoundments on the rivers which are far away from there, and which is tend to be very, very expensive, and also which is also energy consuming as well. And the climate change, as particularly with the heating and the rising population, is going to exacerbate this problem. And the cities' water supply systems are more vulnerable to climate change and warming than.
You have 2 minutes. Please conclude. You have 2 minutes. Please conclude.
2 minutes. Yeah.
Yes.
Similarly, water supply is below the norm in the city, whereas Pune is better placed as compared to that. Therefore, on the whole, Hyderabad is more vulnerable than Pune. If we look into the sewage coverage is less in Hyderabad as compared to the Pune. Therefore, and also both of them don't meet the norms, and Hyderabad is more vulnerable than the Pune. And even in terms of the treatment also, Hyderabad is more vulnerable because of the poor coverage of the treatment. If you look at the waste management, both the cities are well organized, but Hyderabad generates more amount of waste, both in terms of absolute as well as the per unit this waste generation. But their organization systems are better, and therefore they are less vulnerable to climate change impacts. But only thing is that like both of them
no need to explain more.
which will lead to the
please come to
fire hazards. Sorry, sir.
Explanation. Sorry.
Conclusions.
Conclusion. Just 1 minute.
Okay. Yeah. So on the whole, Hyderabad is more vulnerable to climate change impacts because of the dependence upon the distance resources when it comes to the water supply as compared to the Pune. And on the sewerage services, again, Pune is much better than Hyderabad when because of the better treatment capacity and coverage. And stormwater drains are both the cities are highly vulnerable to the flooding. Recently, both of them experienced that impact. And waste management is organized better in both the cities, but the waste treatment is where there are some problems which will lead to the hazards, which fire hazards can happen because of the rising temperatures. Road network is better in Hyderabad.
Thank you. Your time is up, but anyway, please share your PPT.
Yes, sir. I'm on the last.
Thank you very much for your good presentation. Now I may call upon Dr. S. Yogeshwari. She is going to give her presentation on climate change and water insecurity. Who bears the brunt? The case of Yalahalli village in Bangalore. Dr. S. Yogeshwari, you are present?
Yes, sir. I'm present. Thank you, sir.
Dr. Yogeshwari, yeah. 7 minutes.
I'm presenting this paper. I think I'm audible, right?
Audible.
Yeah. So I'm presenting this paper along with Akanksha. So she's sharing the screen, PPT. Yeah. So I would at the outset like to thank Isaac and NIDM to give us this opportunity to present this paper. The title of our paper is Climate Change and Water Insecurity, Who Bears the Brunt? A Case of Yelanahalli, Bengaluru. And this work is largely taken from Akanksha's dissertation work, which she has submitted for her honors program, for her economics honors degree. So let us now move to the introduction. So the most important thing is when we talk about water insecurity is that urbanization is one of the major aspects which is affecting. And when we look at Bengaluru as a city, it has grown exponentially in the past few decades, particularly from 1950 to 2007. If we could see, it has almost grown by 10-fold. And when we look at the climate change issue also, we could see that the data KSNDMC has used average data, daily rainfall data, and for the period 1960 to 2017, and they have subdivided it into two periods, 1960 to 1990 and 1991 to 2017, and they have found that there has been a rise in mean rainfall and variability in precipitation. Similarly, there is also an evidence of rise in annual temperature, particularly from 2002 to 18. Bangalore city has experienced a rise in average temperature, which has resulted into increased rainfall, but that has not translated into increase in greater water security. And we would discuss it a little later. So when we talk about water security, particularly in city like Bengaluru, lakes play a very important role because Bengaluru has been known for lakes. But when you see the situation, like the number of lakes has actually declined substantially. In 1800, it was 1,452, but now it has fallen to 194, and further 2020, it is 183. And these have historically played a very important role when it comes to water management and water security, taking care of water security issues. Next. So when we talk about lakes, the major issue is that as Bangalore is rapidly urbanizing, lake encroachment has also increased, and this has adversely affected the groundwater level. It has affected the percolation and groundwater availability, and that is very important because Bangalore is still dependent on 50% of Bangalore consumption. Water demand is still dependent on groundwater. And when we look at the availability of water, the access, there is a difference. We could see that a study which was done by BUM, they have found that 20% of the population have the access to 40% of the pipes water, and the rest 60% have the access to 60%. So we could see that there is an inequality and difference in access to water. This asks a very pertinent question, whether Bangalore is water secure or not when it comes to providing water facility to its expanding, city as well as the population. So I'm not going to the UN water definition because that's known, but the thing is, UN water definition emphasizes on the provision of quality and quantity water. It's not only about the quantity of water, but also the quality of water which has to be supplied, which has, should be access to the people, along with taking care of ecosystem. So this is what water security definition is, and we have to see where we stand. We have done an extensive literature review. I'm not going to go to in detail, but we have classified this literature into two segments. One largely takes care of the reasons why water insecurity is increasing with respect to Bangalore, in Bangalore city, and also the other side of the literature which we have looked at is how it differs, like water insecurity, how it is going to affect different sections, which section is going to get affected most.
Yogeshwari, sorry for the intervention. You have 2 minutes. Please conclude.
Okay. So these are the major questions, and now I'll just come to the objectives.
No, conclusion.
Yes. So now conclusion is going to be talked by, discussed by Akanksha. So I just, request Akanksha to quickly take 2 minutes to just discuss about the field and the
1 minute. Okay. 1 minute, madam, please. Already time up. There is not. Conclude. 1 or 2 lines.
Akanksha, you are not audible.
Not audible. Okay, you only conclude 1 or 2 lines, Dr. Yogeshwari.
Yes, sir.
1 or 2 lines, you please conclude.
So, Akanksha, are you there?
No
please
problem.
go to the findings, go to the conclusion.
No, it is not moving. PPT is not moving.
Okay.
Anyway, we have to go for last presentation. Time is up.
Yes, sir. Yes.
Tell me 1 or 2 lines, you please conclude.
Yes, sir. So our finding is that we have done this secondary data analysis, wherein we have got to know that lakes are not sustainable. We cannot rely on lakes as a source of water security because most of the lakes are contaminated, and our field study also have given us insight that there is a huge difference in the access to water, particularly the poor social economic group people. They have to really pay huge cost, and therefore their accessibility to clean water is really kind of been affected. And also when we talk about private water tankers, we have also looked at them. They are charging overpriced because of the higher extraction cost of water. So overall, we can say that water insecurity in case of Bengaluru has increased over the period, and it is a major challenge in the coming years. So this is the major conclusion.
Okay. Thank you very much. Anyway, you have lots of time to give your presentations, few more in ISAC, no problem. When time comes, we will provide an opportunity. Thank you very much.
Okay.
Now, friends, we will move on to the last presentation by Dr. Adil Manzoor Nanda. The presentation title is Prioritization of Sub-Watersheds Based on Morphometric and Land Use Parameters, a case study of Vishwa Watershed, Kashmir Valley in India. You are audible, Dr. Adil? Dr. Adil? What has happened? Imran?
Dr. Adil, are you there?
No, Dr. Adil is there. Dr. Adil is not audible.
No, he was there. I think he got disconnected. No,
Yes,
sir,
sir,
he is
now
not
we can
there.
conclude the session, sir, because
Where
now
is
we
he?
have another.
Oh, maybe he's not present.
No, he was there, but he's not there, sir.
It's okay. Okay, thank you for all the presenters. We have presented a wonderful papers, very interesting at this moment, at this juncture. So that thank you everyone. But before conclude this session, I will invite few questions because time is also very short. Please, participants, please few questions for invited lectures as well as also general presentations. We will take it off. If you have any further few questions, please put it on the chair box or write to the respective presenters. They will answer to them. Okay?
Professor Lakshmana, may I ask one question?
Please, sir, Professor.
See, there is a comment by the last presenter in the sense that Bangalore, there is high level of urbanization and therefore the lakes are captured and there is no need for invest more on lakes. But my point is that their urbanization is not directly the capture of the lakes. Lakes capture mainly because of the poor governance of the urban governance, poor governance of the state and particularly the corporation. And we need a separate agenda for lake governance, and this is a part of major governance, and we can just ignore the importance of lakes, and it is not directly related to urbanization. It is mainly because of the poor governance. Thank you.
Okay, thank you very much, sir. Anybody else? Anybody else, or otherwise I will ask
Yes,
Dr. Yogeshwari to reply.
Professor Lakshmana, actually I want to know some clarification regarding
Please, Dr. Balaji.
the third presentation.
Yeah.
The willingness to pay for solar off-grid lighting in rural India. So how the willingness to pay the researcher applied in the energy sector is one thing. The second thing, how they measure the benefits of the consumer.
Okay. Okay.
Short
Thank
answer.
you. Okay.
Thank you,
Fine.
sir. Thank you.
Anybody else? Okay, then we will. I ask Dr. Yogeshwari to respond to Professor Chathukulam query. Then also the third presenters to Dr. Bala Subramaniam. Please.
So thank you, sir. Your question was very relevant, and because of paucity of time, actually we could not talk about those details. There are like cooperatives nowadays which are coming up, wherein they form, they are trying to work to conserve or preserve the lakes, and in such places, lake management, lakes have been kind of taken care well. But otherwise, as you said, that largely it is because of poor governance, lakes have been neglected, lakes are more polluted, and lakes cannot actually in future may not contribute to the water security to the city as such. So your point is very valid, sir, and we have discussed about it, but because of paucity of time, we could not talk about that.
Thank you,
Dr.
sir. Yogeshwari, for your suitable reply to Professor Chathukulam. Now I think third presenter, Pliza, Dr. Pliza, you are here?
Can you hear me? Yes, sir.
Yes. Please answer to one query Dr. Balasubramanian raised. Brief.
I would like to apologize to everyone because of, so the question is about how did we measure the willingness to pay for solar off-grid lamps. So we used the econometric modeling, we used a Tobit model, and then post pre-intervention, that is before distributing the lamps, we have conducted one survey on their willingness to pay for solar off-grid items, and that most of them never use any of the solar products before, especially for lighting. And then post use, once we have distributed the lamps, after 8 months of their experience, we have collected information again, and then we use two econometric models, pre-intervention model and post-intervention model. And then the post-intervention model shows that post-intervention, that once you have technologies and experience good, once you have used the thing, once you have used the technology, you will get more familiar with it and you can give very resourceful feedbacks. So that is how post-use, the willingness to pay was high. That's the answer.
Thank you. Excellent for your reply. So now Professor Sunil Natel, what to do?
Sir, I take this opportunity to thank the chair of this session. Sir, you have very meticulously and organized this session. I thank you very much. You were able to conduct the session in a highly professional manner. And I also thank our 8 scholars, 8 presenters, who also made excellent delivery, and they were able to communicate in a very stipulated time frame how their findings are linked to this contemporary international workshop come training. Thank you one and all. Thank you very, very much for your contribution and excellent presentation. And once again, thanks to Professor Lakshmana and Dr. Imran Khan, chair and moderator of this session. Now we go to the third panel of this international workshop. Before I request Dr. Sweta Vedya, the moderator and the coordinator of this workshop also to take over. I am very happy and honored that chair of the session is our former chairman, Dr. A. Ravindra, former Chief Secretary of Government of Karnataka. Sir, we are looking forward to listen to you today, sir. And now I request Dr. Sweta Vedya to please take over this session and start the proceedings. Yeah.
Okay, sir. At the outset, thank you for giving me an opportunity for this great event. Professor Sunil Natel, thank you. Thank you. And have a good day, everyone.
Thank you, sir. So, good morning, everyone. On behalf of NIDM and ISCC Bangalore, I welcome all luminaries and participants for today's special panel discussion on sustainable urbanization and resilient cities. Today, experts will share their vision on sustainable urban livelihoods, decentralized governance, urban planning, land regulations, and sustainability, and basic services and inequalities. Today, we have Dr. IAS as our session chair. Dr. A. Ravindra served as the chairman of the Board of Governors, ISEC during August 2015 to December 2018. He is the former Chief Secretary of the Government of Karnataka in 2002 and the founder chairman of the Center for Sustainable Development, a non-profit organization. Dr. Ravindra holds a PhD in developmental studies with specialization in urban sector. He has published extensively on urban and public policy issues and received the Citizen Extraordinary Award. As panel members, we have luminaries like Dr. Shiraj Bazi. He is by training an ecologist, but he has extensively worked in natural resource management, climate change resilience, community institutions, and sustainable livelihoods. He has directed projects on water management, sustainable agriculture, eco-health, etc. And he has published and presented over 80 papers and received awards like Global 500 UNEP and Momentum for Change UNFCCC. Then we have Mrs. Katyayani Kamraja. She has been working as a freelance journalist for 33 years and has contributed over 350 articles on social and developmental issues. Since 2005, she has been also working as executive trustee of Citizens, a voluntary initiative for the city of Bangalore. She is the recipient of 17th People's Union for Civil Liberties, Journalism for Human Rights, Kadri Shamanna, Shahid Shankara Guha Niyogi, etc. So then we have Professor Kala S. Sridhar. She is from Center for Research in Urban Affairs, ISCC Bangalore, and she is among the top 10% of the authors globally on the Social Science Research Network. She was earlier Ford Public Affairs Fellow at Public Affairs Center before her positions at the National Institute of Public Finance and Policy, New Delhi, and IIM Lucknow as assistant and associate professor. She has been awarded the Fulbright Nehru Academic and Professional Excellence Fellowship for 2020-21. And last but never the least, we have Dr. Dunu Roy. For past 75 years, he is working in the field of chemical engineering, political ecology, and social perspectives. He worked for over 5 decades in rural and urban scenarios, land and water management, secure settlements, safe work, environmental planning, leadership training, pollution control, and he's poised on the delicate borderline between environment and development. So we all are impatiently waiting to listen to these eminent speakers. Therefore, without wasting much time, I would request Dr. A. Ravindra to kindly take the charge of the session. The floor is all yours, sir.
Yeah, and Dr. Sweta, before Sari starts, I would like to mention Dr. Manasi is also one of the panelists. I think this updated list is not with you, but she's my colleague, so it's okay. She is a renowned scholar in urban issues. Thank you so much, sir. Now we request you to kindly conduct the proceeding and chair the session.
Yeah. Can I take over?
Yes, sir. The floor.
Hello.
Sir, we request you to kindly take over.
Yeah, thank you. You can hear me?
I hear you, sir.
Yeah, thank you. So let me welcome all the panelists. I think we have a very distinguished panel to discuss the very important subject relating to sustainable urbanization and resilient cities. I think since the time is short, this is just about 1 hour, and there are 4 or 5 panelists. First of all, I would like to inform the panelists that they should restrict themselves to about 10 minutes each. It may be difficult, but I think I request you to observe the time limit. Now, so far as the subject is concerned, we are all aware of the urbanization process that has been going on in India. We are getting more urbanized. We already have a urban population of over 400 million. And in the 2030s, it is expected to reach 600 million and grow further. While urbanization is going on the one hand, we find that there is a mismatch between the infrastructure and services being delivered and the growth of the urban population. So there is always this criticism about government not being in a position to meet the required challenges posed by urbanization, which also in a way is going chaotic. So what are all the various issues pertaining to achieving sustainability in urbanization, and how do we go forward towards the concept of resilient cities? This is particularly relevant today because of COVID-19. In fact, as you know, COVID has been essentially an urban phenomenon. I think it started in the city of Wuhan in China and spread further, and we all know what are the consequences. So I think COVID has posed fresh challenges to urbanization and the urban policymakers and planners. I think with these few introductory remarks, I would now go on to request the panelists to make their presentations. First, may I request Dr. Shiraj Waji to make his presentation.
Thank you.
Yeah, please, can you put on
Thank you. Thank you, Dr. Ravindra. And thanks, Dr. Nautiyal and Professor Anil Gupta for giving me this opportunity to join you all in this very important and relevant workshop. Yesterday also I heard some sessions and it was very interesting. So let me come straight to, as Dr. Ravindra has said, that the time is short. So I'll move to my slides, and let me share the screen. How to do this? Yeah.
So I'll be giving a warning bell when you still have 2 minutes left, and I request you to close at that time.
How to do this? Yes, Zoom.
So press the share screen.
Yeah.
Press the share screen.
Yeah.
Any problem with the?
Can you see now?
Yeah, please.
Okay, great. So I'll focus mainly on the blue and green infrastructure and how these infrastructures, the blue and green infrastructure, because I mean, as I was listening to the earlier session also, we are talking largely on the gray infrastructure, which is synonym with the development of the cities. And in that kind of approach, some of the times actually this blue and green infrastructure that provides the ecosystem services to the cities are generally ignored, maybe because of the governance problems, maybe because of other reasons also. Somebody was presenting in the earlier session also about the water bodies in Bangalore. So on this, some of the points which I would like to highlight, the first is how urbanization is taking place, the very fast urbanization which is happening all over in the globe. And it is expected that almost 66% of the people will be living in the urban areas by 2050. So, I mean, that is something actually which is alarming. And there are reasons why the rural people are migrating to the urban centers. There may be economic reasons, the frustration from agriculture, the deceleration in the agricultural production, and so on. There are social reasons, there are ecological reasons, the disasters, and the climate change impact. So ultimately, it is impacting on the rural livelihood, and people are migrating to the urban centers. So this is the general and the global trend. But if we come to India, and mostly in the East Asia or South Asian region, we see that the urbanization, the way it is happening in this region, is largely it is, I mean, the people are migrating now not to the mega cities as much as in the secondary cities or the smaller cities or the tertiary cities. And the impact, like, I mean, what we observed in the last few decades, 1 or 2 decades, is that the states like Bihar or the states which are dependent more on agriculture-based economy and where urbanization is less, urbanization happening in those states more than the states which were already urbanized or who are dependent mostly on the secondary and the tertiary sector activities. Here, I would like to quote an example that although the number of the cities or the smaller towns which are increasing in India between the two census periods, 2001 to 2011, nationally it was 185%, but if you see at Bihar, where the urbanization is only 11%, the urbanization trend was like, I mean, it was almost 1100% growth in the urban centers. So what I would like to emphasize here is that the focus of urban is now more on the secondary cities than the tertiary cities, which are also devoid of infrastructure, the services which are required for the people and so on. So this is the second point which I wanted to make. Now, when we talk of urban, it is generally thought of the urban centers which are posh, which are civil lines area, which are industrial centers, or which are buildings and the infrastructure, the highways and the flyovers. But we will have also to think that whose reality counts if we think of urban centers. Is it always the posh localities, or it is more than 50% of the population in some of the secondary cities who are poor, who are marginalized, who are living on the fringes of the city? So this is an important component which will have to be considered when we are thinking of urban resilience and the resilient cities for future. So the third point which I wanted to make, that the focus of the urban development has to be also on the poor and the marginalized. And we have to develop inclusive cities, which includes the poor and marginalized communities also. Now, if we come to the whole green and blue infrastructure, the way it provides the resilience and the livelihood to the urban centers, there's a very strong connect between the livelihood and the resilience of the cities. Quoting one example of the ecosystem services which are provided by these green and blue infrastructure, water bodies, orchards, green spaces, agricultural areas, all these spaces actually, you can see that there are 4 major pillars of ecosystem services. We all know the provisioning services, the regulating services, the supporting services, and the cultural services. And the kind of services which it provides, like food and fodder and fuel, are obtained, if you think of the urban and the peri-urban areas, largely the food and fodder and the fuel is coming from these ecosystems. The recycling of waste, water recharge, soil erosion, checking the soil erosion, protection of the embankments, and these kind of activities are some of the regulating services which are being provided by by these ecosystems. And then there are a number of supporting services like inputs for farming, buffering and water holding capacity provided to the cities in form of water bodies. Somebody was talking in the earlier session on the Bangalore lakes. And I mean, all these water bodies actually that provides the water holding capacity to city. At the same time, it also gives the opportunity for the groundwater recharge. Heat absorption is something actually which also is being provided. So a number of supporting services which are provided to the cities by these ecosystems. So, I mean, if we compile all these, including the shocks and stress bearing capacity to the city, if we compile all these, we see that there is a very close link between the livelihood and the resilience. The ecosystem provides livelihood. The green and blue infrastructure provides the livelihood to the people, especially if we are talking of poor and marginalized. At the same time, it is providing the resilience to the cities. So this duo of livelihood and resilience, this interconnectedness and intercomplementarity between the livelihood and resilience comes from these ecosystem services. And that will have to be thought if we are planning and we are conceptualizing the resilient cities in future. Two more slides. One is that when we talk of urban centers, we generally think of the areas which are within the municipal boundaries. I would like to focus here that there is a very crucial space around the cities, which are known as peri-urban spaces, which are of course dynamic in nature. It is not static space, it keeps on changing. But anytime, on any given point of time, the peri-urban spaces are important spaces which provides the livelihood as well as the resilience to the cities. And in the policies and the concepts of resilient cities, one will have to consider that these peri-urban spaces also as a part of the urban area. So whereas the urban resilience is important in terms of resilience building within the municipal boundaries, but at the same time, the larger development area of any city, the peri-urban spaces, are also important, which provides the resilience to the city. And if we think of this connection between the urban and the peri-urban, we can think of the three major pillars which are quite closely connected. One is the food production. The peri-urban spaces provide a lot of food, horticulture, poultry, dairy, agriculture, and so on. So a number of practices which are done in these peri-urban spaces. And these peri-urban spaces or peri-urban agriculture, if it is managed with the ecosystem-based approach, then it is also quite ecological, I mean, ecologically friendly. It also provides the livelihood to the people who are living not only within the peri-urban spaces, but also to the people who are living in the urban spaces. And at the same time, if we protect the water bodies, if we protect the ecosystems in these peri-urban spaces, if we protect the agriculture, ecological agriculture, if we protect the orchards which are existing in the peri-urban spaces, it provides the urban resilience. So this interconnectedness or intercomplementarity between the food production, the livelihood of the people, especially the poor and the marginalized, and the urban resilience, this goes hand in hand. And this is a very important component to be considered. And the last slide, I would like to highlight that how these peri-urban spaces are neglected. This is based on 4 cities where we were working recently in Assam, Bengal, Bihar, and UP. And you can see that all the ecosystem services like water bodies, agriculture areas, horticulture, forest, open spaces, floodplains, bamboo plantation, it is gradually shrinking.
You have
not
2 minutes,
gradually,
Dr. Raji.
Yeah. So it is very fast shrinking. And that is something which is a matter of concern, which will have to be considered as a priority. So thank you so much for this time and opportunity. Any questions are most welcome. Thank you.
Thank you, Dr. Raji, for having completed it on time. And you also raised very relevant issues relating to livelihoods, migration, and the peri-urban space. I think we'll come back to this later. Now, may I request Srimati Katyayani Chamaraj to make her presentation. Katyayani? Have we lost touch with her? You have to unmute yourself, I think.
Am I audible now, sir?
Yes, yes.
Yeah, okay. First of all, let me thank Isaac and Dr. Sunil Nautiyal for giving me this opportunity. And since time is short, I'll try to make a few points. I think I have about 6 points to make. And so the topic given to me is to speak about decentralization in the urban sphere and the successes and failures regarding decentralization. So first of all, we have to recall that 74th Amendment wanted the urban cities to be local self-governments. And after 27 years, most of the goals of the 74th Amendment have remained unfulfilled because of lack of devolution of the functions, and the 3 Fs, the funds, functions, and functionaries, have not been devolved to the cities to be able to bring sustainability in the cities. And for example, transportation is not at all in the purview of the urban cities. So a lot of pollution comes from the focus on high-level, high-end infrastructure like flyovers and elevated corridors, and lack of incentive for public transport. And even water issues, they do not come under the urban local bodies. That is why we are saying total unsustainable use of water. And inclusivity is also not there, especially urban poor housing, which would lead to a lot of sustainability of the entire urban area. It is totally not in the hands of the urban cities. It is again in the hands of the slum development board or urban housing boards. And because of the lack of function being devolved, the cities are unable to work for sustainability. And also all the functions that they're supposed to be performing as per the 12th schedule, even the resources for doing that has not been devolved to the cities as per the state finance commissions. Coming to the local and the planning, the very planning for the cities, which was supposed to be done by the Metropolitan Planning Committee, for example, in Bangalore, has been dysfunctional. And the parastatals are still planning for the entire city. And there is no monitoring mechanism for ensuring that whatever is planned is being implemented also. That is how we see that there is total violation of the zoning and bylaw regulations, leading to flooding and pollution of the lakes and so on, which was being highlighted even in the last session. And even when big infrastructure projects are planned by the parastatal and not by the urban local body, for example, the peripheral ring road that is being planned or the elevated corridor that is being planned for Bangalore, even the DPR is not in the public domain. And it is leading to a concentration of investment in Bangalore, in Bangalore's road infrastructure. And the transparency about it, whether this peripheral ring road or the elevated corridor is needed at all, there is no cost benefit analysis also in the DPR. They may just say, should this road go through this layout or that layout, as a study of alternatives, but it does not look at alternative of incentivizing or supporting public transport in lieu of supporting infrastructure that incentivizes private vehicles. So the alternatives are not even studied as in proper cost benefit analysis. And with the huge investment for the elevated corridor, for example, which is being planned in Bengaluru, which will take about 40,000 crores, there is no evaluation at the state level whether this 40,000 crore should be invested in Bangalore or in the other cities or the less developed area of North Karnataka, which would, develop the entire state and lead to less migration coming to Bangalore, which makes it necessary to invest in all this road infrastructure. So the same 37,000 crore, if it had been used in the other cities and so on, it would have led to total development of Karnataka. Now, this kind of analysis is also not being done. For example, for entire North Karnataka in 1 year, they are giving about 2,000 crores, whereas 37,000 crore is considered affordable for Bengaluru. And what we need to look at now is the citizen participation role as per the 74th Amendment. The ward committees and the area sabhas are totally dysfunctional almost, and even the ward committees are set up only on High Court orders, and unless the court is chasing them, they do not even do what is required as per the law. So there is total neglect and lack of political will to empower citizens to do the local planning, area planning, and also to monitor the usage of funds. And without the citizen oversight, we know that whether it is solid waste management or building bylaw violations, it is full of corruption, and different mafias are in control, whether it's the contractor lobby in the solid waste management or the real estate lobby or whatever, who are actually controlling the entire development of Bangalore and leading to massive corruption and leading to unsustainable development. And also the regulatory body, which is supposed to be the Karnataka Pollution Control Board, has proven to be totally helpless in seeing that Bengaluru develops in a sustainable way. Whether it's the regulation and the monitoring of solid waste management or the building bylaw violations and the pollution of the lakes, the Pollution Control Board has completely failed. And I think I'll come to the last but one point, that there is no index for measuring sustainability in the city. Where is the database that we can get at the ward level for what is the level of sustainable development that needs to happen there? What is the level of pollution, and what is the level of housing available? So in order to bring sustainability at the ward level. And I'm also supposed to talk about the successes. So one of the recent successes that we saw is that when during the lockdown and the pandemic, there is a disaster management unit at the state level and at the district level, and there is not.
You have 2 minutes left.
Yes, sir.
You'll have to close in 2 minutes.
I will complete in 2 minutes. So there is no institutional mechanism at the ward level or at the city level for disaster management. And we from Civic had to go to the High Court to get an order to set up ward disaster management cells, because unless there is a reach at the grassroots level to handle the pandemic and to reach out to the needy people with the ration or to monitor the persons who have got COVID, it was very difficult from the district level to monitor all that. So it was only on the court's order that ward disaster management cells were set up. But the sad thing was that they did not have a standard operating procedure and no training at the ward level. So though there were a lot of volunteers willing to work there, there was not enough training that had gone into strengthening or empowering the ward disaster management cells. And also, since the area sabhas have not been constituted, there was no way of intensive work at the booth level, to engage volunteers, citizen volunteers, to monitor the entire COVID and lockdown thing. And I'll just end with the last sentence, sir. 2 days ago, there was a webinar conducted by the Center for Policy Research, where the National Disaster Management Authority member, one Mr. Kishore, was participating.
I think you will have to conclude, Katyayani.
Yes, sir. So we informed him that in Bengaluru, we have set up ward disaster management cell, and he has shown interest in taking up our initiative and maybe extending it to the entire country. So thank you very much, sir, and thanks to Isaac for giving me this opportunity.
Thank you, Katyayani. I think you have raised a relevant issue relating to decentralization, which is still not being fulfilled, and the other issues about making more investment in secondary cities, so that you really have sustainable urban development across. Not merely, we should not look at merely large city like Bangalore, but other cities also. Thank you. I now request Dr. Kala Sridhar to make her presentation.
Thank you very much, Dr. Ravindra. Everybody is able to hear me?
Yes.
Okay. First of all, I would like to congratulate Professor Sunil Nautiyal and Dr. Anil Gupta for organizing this international workshop of such a high impact. And I would like to, of course, thank him for this opportunity to be a panelist in this session. And I would like to thank Professor Madheshwaran, Director of ISEC, for his support in this panel. And I know Dr. Ravindra has a tough job to do managing the time, so I will try to maintain this time, sir, without taking away a lot of your job. So I will try to facilitate your job. So what I would like to just first do is, I'm sure that many participants in this workshop have talked about this already, but I want to just motivate this concept of climate change and resilient cities by just showing the magnitude of climate change losses in the top 5 G20 countries of the world. And you will find that the annual average deaths in India are not negligible. Deaths per million inhabitants in India, of course, due to climate change are much lower than in other countries like Russia and France. And the losses per unit of GDP are definitely not negligible. And this, of course, like what is directly attributable to climate change. And of course, with luminaries, like Dr. Ravindra and others here, I don't have to really talk about the trends in urbanization. Just to mention that India is only 31% urban, and however, urban areas are blamed for all the climate change and resilience related challenges in the country. But I would like to propose that in India, there are certain challenges in the form of urban planning. I will focus on floor area ratios, changes in land use and land cover, and carbon emissions. So now theoretically, I just want to demonstrate the impact of floor area limits. For those of you who don't know this, for every 1 unit of plot area, what is the extent of built area? That is what the FAR is supposed to show. If FAR is 2, then it means that for 100 units of plot area, 200 units of built area are actually made, right? So here, what happens is that in the city, this is a central business district, towards edge, in the city with no FAR restrictions, the the FAR is supposed to be the highest in the center and lowest towards the edge of the city, just to make use of better capital land ratio in the center of the city, because land is very expensive and access to the employment center is really valued. But when we impose an FAR limit like this, what happens is that you bid up the prices of land and housing everywhere in the city, and city area becomes unnecessarily large. That is the distortion that FAR creates. Central city FAR values around the world, you'll see Sao Paulo in Brazil is only 1. Mumbai, Chennai, Bangalore, they're all here in this range, whereas Singapore, Tokyo are all in this range. They try to be efficient. These cities are efficient. Now, what would have happened? They would not have sprawled like this. This is actually, I should thank my student. Now he's Dr. Shivakumar for this picture. And this is Bangalore in 1965. The red is built area. And over time, this is how Bangalore has grown. 2018, this is the built area. And you will see that if the FAR had been high, Bangalore would not have sprawled like this, and it would have been a much more compact city like it was in 1965. Now, I want to come to this concept of carbon emissions, and this is 2009, and you will see that Palo Alto, California was the highest carbon emitter in a city in the world, 2009, right? No Indian city figures in this list. Now, when we look at absolute carbon emissions though, India is the 4th after China, United States and the European Union. And if we look at India's contribution to carbon emissions also, it's the same order: China, US, European Union and India. So now what I want to mention in the context of also COVID is that the percentage of open spaces is negatively related to the incidence of COVID. So similarly, the carbon emissions measured in terms of PM2 is actually negatively related to the percentage of open spaces, as we found from a data set, as we would expect, right? So it's important for us to encourage open and green spaces, right? So these are the parks per 100,000 population in some selected cities of India. This is Bangalore, and this is Vizag, and this is Chennai. And now what I want to say is, in the context of the earlier analytical effect of the FAR on carbon emissions. So we expected that FAR would lead to a low FAR will lead to sprawling cities, right? So carbon emissions also would be high. And these are some correlation graphs between the residential FAR in cities and per capita emissions. There is no relationship here. And non-residential FARs and per capita emissions, there is a weakly negative relationship, which is what we would expect. Now, impact of energy consumption on carbon emissions is definitely higher. So the less we consume energy, the better. The more open and green spaces we have, the better for resilience. And the higher the FAR, the better. And FAR, I have found, leads to unnecessary suburbanization, right? Because cities sprawl whenever the FAR is low. So we do find, as we expect, that per capita emissions are associated with increased suburbanization, which is caused by very, very restrictive FARs, right? So this is my last slide. I would like to thank you all for the attention. And Professor Sunil Nautiyal wanted me to give some insights and policy suggestions. So based on this presentation, some insights are: 1, keep your FAR not too low, but not too high if your infrastructure doesn't permit it. 1. 2 is basically you have more open spaces, more green spaces, and in the context of COVID also, this will also be very helpful. And one disclaimer I want to make on the FAR: because of the COVID pandemic and because the world continues to expect many more pandemics in the coming years, FAR, that is why we have to be a little bit careful, because we cannot increase density unequivocally across the city, because density leads to increased COVID prevalence. So whatever suits our local conditions and infrastructure is what we should advocate. Thanks a lot for this opportunity, and I hope that I've taken the time that was allotted to me. Thanks.
Yeah. Thank you, Kala. I think you have exactly limited yourself to the time allotted, and at the same time highlighted the issues relating to, urban planning, especially the land use regulations, and of course the all important thing you keep emphasizing on FAR, how FAR limits or the FAR values affect now even climate change or suburbanization and so on. We'll come back to that. Now, may I request Dr. Danu Roy to make his presentation.
Thank you. Can you hear me? Is my voice?
Yes.
Thank you. So I have a very quick presentation. Try and finish in the time allotted. I am very grateful to ISEC for giving me this opportunity. I am going to try and illustrate a few things about what is the scope. And
can you speak a little louder or keep the mic near? I can't hear properly.
Okay, is that better?
No, a little more.
There's some problem probably with the mic at the moment. I'll try and improve it. Yes. Okay, is that better?
Little better, but I think still you'll have to raise your voice or keep the mic. Something is wrong with the mic.
No, the mic, there's some problem with the microphone. Okay, I'll try and speak as loud
go
as I
ahead,
can.
go ahead.
So I'm going to try and illustrate what is the scope for resilience and what are the problems, what are the barriers. I'm giving a small presentation from Delhi. This is the COVID graph of Delhi, and as you can see, we are now just passing the third wave. This presentation is a case study of the Saja Manch, which is a platform of 35 voluntary organizations in Delhi, and what they tried to do during that shaded period. So it's a little over half the total COVID period. The first thing was to do a mapping of what is it that people need, and people spread out, volunteers spread out across the city, and there was vulnerability mapping.
I think you'll have to make yourself more audible.
Okay, is that better?
Sir, if you are using headphone, you can remove your headphone and use the sound of your system.
I'm afraid the speaker in my system is missing. That is why I'm forced. I'm using somebody else's computer at the moment.
You can keep the mic nearby your mouth.
It's almost right inside my mouth. Let me speak as loudly as I can. Is that better? Can you hear me now? Or is there still some problem?
We can hear you, but the voice is really low. No problem, sir. Go ahead. Go ahead.
Let me continue.
Either increase the volume.
Yes, I have to increase it.
And bring the mic nearer your mouth.
I have increased the volume to the maximum.
Yeah, you can continue with vulnerability mapping.
Yes, so this was the vulnerability mapping that we tried to do, this organization. And they built up lists of the most vulnerable families in each locality. Subsequently, in about 40 spots across the city, these are the yellow ones, rations were distributed almost for 2 months. each family got rations. So about 4,000 of these vulnerable families got their rations. This led to an evolution of a particular strategy. And this strategy had to do with three main pillars. One was food supply, the other was how to prevent the spread of COVID, and the third was what kind of healthcare is possible. This was a small pamphlet that was distributed across these communities. An appeal for assistance went out from different groups. This is a small union in one of the industrial areas asking for urgent appeal for COVID relief. Accordingly, we did manage to collect some funds, and the Munch started these 6 community kitchens, essentially in order to provide cooked food, because the experience with rations had shown that many families of the most vulnerable families were unable to cook the food. They had no fuel. So cooked food was supplied, and either this cooked food was distributed to the homes of the most vulnerable, or they came in queues, and we tried to take as much precaution as possible to prevent the spread of COVID. In the process, many other things emerged. One was that supply of food also involved a lot of packing, and so there was waste. So people were encouraged to come with their own utensils and take the food. In addition, waste management groups were set up at each of the kitchens, and there was also an attempt to cater to children's specific needs. For prevention and care, the first thing was the development of masks. So women in many of these bastis were given short video training on how to make these masks, and they made the masks and distributed it in their communities. For sanitation, some kind of innovative water saving systems were put in practice, how to use water minimally, then sanitizers and glorification was done to prevent the spread of disease in many of these bastis. Healthcare, 2 things we tried to do. One was the distribution of oximeters so that blood levels could be checked, or oxygen levels could be checked at most of these places, and digital thermometers to check temperatures. Registers were maintained in each community of regular checkups. The only thing we could not do was set up community-based quarantine or isolation units, which would then ease the burden on hospitals and other private healthcare providers. Awareness documents were circulated. One was a manual on how to run a community kitchen. Another one was how to access rations, and many of these were distributed across in these communities. Information was very critical, so laptops were used for online applications, for ration cards, for pensions, for widows and so on. A small survey was done of what was the condition of workers in the city. And these are the kind of volunteers who participated. So all the volunteers were from the communities themselves, and it was within the communities that they were developing this strategy and its tactics. Eventually, this is the scope that came up. Rations, 4,000 families in 40 settlements, kitchens serving about 2 lakh meals. We tried to convert them into worker-operated messes, but it could not happen because workers did not have the money. The economy has still not revived. There was a tie-up with farmer cooperatives to provide grains. In healthcare, 10,000 masks were made and distributed, as were sanitizers, disinfectants. Health checks were done. There was no outbreak of any epidemic in these settlements. Awareness, much of the material that was developed, manuals, posters, and so on, led to a fair amount of understanding of COVID. And now some of these communities are moving towards an information resource center, which will encapsulate all these processes. The last point is the most interesting one. That is, we found of all the money that was collected, that it was averaging rupees 20 per person per day to deliver these basic services. What is the barrier? Governments. 150 messages, letters, emails, phone calls were made to 11 departments of Delhi government. Only 12 replies came, and each reply transferred it from that department to another department. There were 3 complaints made to the Public Grievance Commission. There is no reply. The site of the Public Grievance Commission has not been updated after 2018. 5 file inspection RTIs were filed, and only 2 have been replied, and they have also forwarded it to another department. So this short case study illustrates what is the scope if people's participation is encouraged in cities, and what are the barriers if it is not. I will stop there.
Thank you. You'll have to complete in another 2 minutes, please.
I have completed, sir. I have finished.
It's over?
Yes, it's over.
Yeah. So thank you, Mr. Dr. Dunu Rai. I think you have focused on the travails of a city like Delhi during the times of COVID and what they have been able to do. It's a very, very important input. May I come to the last speaker, Ms. Mansi? Are you there?
Yes, sir. Thank you, sir. Thank you, Ravindra, sir, and thank you, Professor Sunil, for the opportunity. I'll just be sharing my screen. So I'll be focusing on. Hello, am I audible, sir?
Yeah.
Hello.
Yeah. Yes, you can. We can hear you. Please go ahead.
Yes. So I'll be focusing largely on waste, sanitation, and water resources management. And given the pandemic and the various other epidemics which were there earlier, we can see that if we do not actually manage the stresses that are already there with the cities, we are going to face several shocks just similar to the pandemic. So here we have more than 54% of the people living in the cities. We have a lot of pressure with respect to providing infrastructure facilities, and most of the 70% of the cities are actually contributing to the carbon emissions. So we have a lot of challenges with respect to providing infrastructure and lot of hazards with respect to various aspects on urban heat islands, coastal flooding, temperature, drainage, etc. All this has an implications on the quality of life in cities. So we do have policies and regulations with respect to urban planning, but they have not been really adequately including the climate change perspective. So largely it has been response oriented rather than prevention. So it is very important that we need to aim at the disaster risk reduction, keeping these climate implications in perspective. So we have the Sustainable Development Goals, which focuses on climate action, and several of these other goals are very much. It could be clean water and sanitation goal number 6, or gender equality, or infrastructure for that matter. So as I already mentioned, how do we actually handle these stresses to see that it does not become shocks? The OECD definition says that resilient cities are cities that should have the ability to absorb, recover, and prepare for the future shocks. So they have several areas to drive resilience, and I'll be focusing on the infrastructure, keeping in view the waste and water management. So waste, we also know that it's become largely a consumeristic society and it's a throwaway society. As yesterday Nadkarni sir was mentioning, that it is not only trying to focus on the 3 R's where we try to reduce, recycle and reuse, but we also need to re-educate on how we actually live, or how we actually have our attitude change and have some ethics in how we actually behave. So with respect to segregation, collection, transportation, disposal, and treatment have been discussed extensively. We have not been able to really achieve efficiency in this. We have a lot of rules in place, like municipal solid waste management rules, and several initiatives are also there, but we've still not been able to come up with the garbage-free cities. So a lot of focus is on waste to be seen as a misplaced resource and focus on the circular economy. And Swachh Bharat Mission has been doing a lot, and at least it has brought to fore several detailed aspects and documents in this regard. Water, again, we have several concerns in terms of quantity and quality of water that we are not able to supply, and we are struggling to manage that, and the local officials are having a lot of problems with respect to sewage systems. Unaccounted for water in the Bangalore, for example, is up to 50%. Pollution in lakes, and that has already been discussed even in the previous presentations, and a lot of groundwater resources and contamination with respect to water. And the National Water Policy 2020 has been initiated with about 100 new members who are trying to look at how we can translate these goals into action. And sanitation challenges, again, we have a whole lot of challenges. Good sanitation is good economics. Several studies have emphasized that if you invest $1 with respect to sanitation, you will be saving up to $5.5. So it is definitely a return on investment, because a lot of losses happen with respect to mortality and morbidity and health impacts. And sanitation, definitely with respect to toilet access, is improving over time across the various years. However, we do have a lot of problems at the field level, because we are not able to maintain and sustain this sanitation infrastructure, whatever is there, and the space is a major constraint. It has effects on women, elderly, and children. And we lately, again, bringing it to a circular economy point of view, we have the National Policy on Fecal Sludge and Septage Management, which is trying to, again, make it circular and see that we use it as a resource. So we have a lot of our water bodies which are treated as waste dump yards and carriers of human excreta. So given these major stresses that we have seen that it has led to urban flooding, which has become a recent phenomena in most of the cities, and they have reached a saturation point. So we have several examples of the Mumbai floods, the Chennai and Bangalore floods, and where we are not able to handle it, and it has a lot of impact on the city infrastructure. So you have to focus a lot on the altered drainage characteristics, the land use in the urban areas, clogged drains, drainage systems which are unable to cope, and encroachment of wetlands and waste dumping in these water bodies. So if we have to look at the various conflicts that are coming up, when you see there is a conflict in the city planning, land versus water, where you see a lot of encroachment, as I already mentioned. Then again, with respect to letting the rivers flow and reclaiming it to construction commercial projects. And we had a study which we had done for Mumbai and Bangalore, and we see that Mumbai airport was actually built on chopping of the mangroves. And again, you have the urban poor versus the rich conflict, where what do you define as legal and illegal encroachments? You have the some Bandra Kurla complex is legal, whereas slums in Kurla are illegal. And mostly the urban poor are affected extremely during this process, and a lot of financial losses are there because of this. And there is no comprehensive citywide adaptation strategy in this context. And again, as I mentioned earlier, there are several. Yes, sir. Disaster preparedness. So it's largely focusing on response rather than prevention. And how do we actually rectify all these land use errors? And a lot of these departments who are working are having conflicting approaches, and they are not really working holistically. So that has been a challenge. So when we look at options, I think we need to focus a lot on improving governance, which is to be much more holistic, and try to include the climate resilience in this context. And a lot of scope is there to improving data, because several of our studies, when we have been doing, we have seen that there's extremely lack of data in the urban context. And we need to look at local such solutions and come up with local options. And capacity building and awareness creation needs a lot of innovation in how they're going to approach this issue. And a role of technology can definitely be explored further. And also setting standards and upscaling. When I was speaking about the circular economy, I think green buildings fits this context, because they are really looking at the holistic perspective, right from the design to the completion. All these various aspects are addressed. About 4,000 plus green buildings are there in India. And again, another important aspect is with respect to behavior change. The culture of hygiene is something which we need to address extensively. Swachh Bharat Mission is definitely trying to promote this a lot. And when we look at city level environmental activism, also is very popular in Bangalore. We have Hasiru Dala, Civic, who are all working extensively. We have more than 20 NGOs working on these aspects. And even with respect to lake rejuvenation, we have more than 50 organizations working on this. So this shows that there is a lot of civil society and environmental activism, which is also playing a major role in trying to help out. So I would like to conclude by saying that governance, behavioral change, and setting up institutions would play a major role in trying to improve these resilience in cities. Thank you, sir.
Thank you, Mansi. I think you have rightly pointed out all the problems relating to, in a way, resilient cities. The risks that we are now adopting more a responsive attitude than a preventive, action that is very much necessary.
Yes.
Are we going to allow any questions, Shweta? Because the time is up. Are there any questions before I make some concluding remarks? One or two we can take, that's all.
Participants, if you have any question, you can pose it now. Sir, in chat box, I cannot see anything.
Pardon?
Sir, in chat box, I cannot see any question. So if any participant wants to ask now, they can ask.
I think Professor Jose Chathukulam had a question for the very first panelist. I'm seeing this here.
Okay.
Yeah, I saw that question. Actually, I replied also in the chat box.
Right. I think he had one other comment for everyone. I think his question is probably for Katyayani, because he's talking about decentralization.
Is he here? Yes. He can ask the question otherwise.
I think.
Okay, go to the next. Anybody else wants to ask a question?
Should I read out Professor Chathukulam's question?
No, I have read it. I think it was directed at me. I'm Katyayani. So I think his point is well taken, that he's saying the 18 items in the 12th schedule can be added to by the state and the cities. And it is it need not be restricted to those 18 functions. That is a point well taken. So it is up to the state which functions they want to add and devolve to the city corporations. So if housing or if water and sanitation has been left out, then they can definitely bring those functions under the municipal governance and need not be done through parastatals and the state government.
Okay, any other question?
No, sir, that is all. Only 2 questions.
Right, okay, in that case, I'll let me make the few concluding remarks. I think we have had a very good, deliberations on different aspects relating to urbanization and the problems. Let me, in an overall sense, say this, that I think the problems relate mainly to, number one, urban planning problems, which include, of course, land use regulations, FAR, and things like that. Number two, relating to services like, water supply, sanitation, and transportation, and so on. Number three, relating to governance, which includes issues relating to decentralization and all that. And of course, since we have brought in climate change and resilient cities, that is also an important part of urbanization or urban development as a whole. Now, let me say that I think probably what we need is a kind of rethinking on the entire process of urbanization and urban planning. If you look at various issues raised, for instance, the question of peri-urban development, suburbanization, low FARs, leading to horizontal development. And I think I would juxtapose this to a major issue that we are facing now, post-COVID, and that is the economic recovery. We need to now, in the first place, look at how cities recover, their own issue matters relating to employment and the economic growth, the revenues for the governments, both state government and local government. Otherwise, if our investment in all these infrastructure itself will suffer. I think even this year it has already suffered. So, so economic development, urban economy assumes a lot of importance. So my own view is that I think for long we have tried to look at urban development, rural development, or two separate, isolated fields or processes. I think we now need to take an integrated view because, a number of them spoke about secondary cities. I think even the population growth is taking place in secondary cities and some investments are going there. Not just secondary cities, I would say even small towns and the rural areas which have potential for growth. So we need to provide or create employment opportunities in and smaller places. Only then, the migration to large cities will get reduced. So long as employment opportunities, educational opportunities are concentrated in cities like Bangalore, Delhi, Mumbai, and all that, or maybe some secondary cities, it is very difficult to control this, migration to large cities, and that will only precipitate more problems. So the entire development model, I would say, needs a rethinking or a relook. There's no time to elaborate on this. That is one. And the second is that I think, again, arising out of COVID, public health has assumed a lot of importance. Otherwise, now cities, and the most important problem we've been facing is relating to health. Especially when there is a pandemic or even a smaller epidemic, I think that health issues take priority. And our public health infrastructure is pretty bad. Public health capabilities are bad in the local government. If you look at the, all the municipalities and all, we speak about secondary cities. Even in large cities like Bangalore, what is the public health capacity? Even BBMP, let us say now they are tackling the whole thing. What BBMP is doing at present, I find, they have set up a war room and they're just monitoring the, the COVID number of cases and what is happening, arranging for hospitals, beds, this and that. It's not, see, the health issues the public health on one side, and also the other health issues, comorbidities, which are coming out of them. So many people suffer. They catch, there may be infection, so far as COVID is concerned. And at the same time, those who have other kind of morbidities, they are subject to much greater risk. So we need to look at health issues with greater sense of priority, maybe pump in more money, more investment on the health issues. Similarly, relating to both health and housing, I would say is extremely important, especially for the weaker sections, vulnerable sections that we have talked about. That's one reason why there has been such large-scale migration of our migrant workers going back is basic necessities, food and basic health and things like that. There I think we have really blundered, all cities, in dealing with the problem of migrant workers. So migrant workers, migrant economy itself, I would say, is an extremely important aspect that we need to look at. And of course, the issue of climate resilience, developing resilient cities, and controlling carbon emissions, they're interrelated, as was pointed out, to urban planning issues and all that. But carbon issues, speaking about, Kala was mentioning in the chart that I noticed that the emissions are more in Chennai than in Delhi. I'm not sure whether it is right. It just can't be, because the pollution is much higher, much higher in Delhi and the northern cities, not so much in the southern cities. Maybe, you can have a look at it and we can talk about it later if need be. Yeah, and then there are, of course, the issues relating to waste management, which Mansi mentioned, pollution. And ultimately, I think this behavioral change is something that we need to talk about. It's not merely a matter of, water and sanitation, but behavioral change in a broader sense. And that brings me to the last point. I would like to conclude with that. When we talk about sustainable urbanization, sustainable development and all, the key issue is sustainable consumption and production. Consumption and production patterns are the key. See, today it came out in the figures that, for instance, cities consume 70% of the energy, most of water supply, and even all other materials and resources. Resource consumption is so heavy in cities. Unless we have policies and strategies to control consumption, not merely bringing down energy consumption and all, even in terms of the food that we eat, cities, I think, contribute a lot to junk food and also waste indirectly. So these are all the issues that need to be dealt with. And as pointed out, for instance, we need to grow probably, our vegetables, fruits, etc. in the peri-urban areas. Agriculture, peri-urban agriculture, horticulture, etc. These are issues that need to be brought out. And as it's pointed out in the beginning about blue and green infrastructure, making provision for more open spaces, more green spaces, and protection of water bodies. So these are all interrelated. And therefore, I would say that I think the whole policy relating to urbanization, urban development needs rethinking, and we need to put them together and then look at the real priorities. 1, 2, 3. In view of the paucity of resources, in any case, it is there. What is going to get us nearer the goal of sustainability? What are the items? 1, 2, 3 points. And I'll no time to elaborate on these issues, but these are issues which need to be discussed further. And maybe ISEC can take the initiative in trying to organize a separate workshop, or maybe webinar, or at a later stage, after a month or two. These issues need to be discussed if we really want to move towards sustainable urbanization. So thank you very much for all the panelists. I think excellent contributions. And thanks, Dr. Sunil Nautiyal and the team for giving us all the opportunity to participate in this workshop. Thank you.
Dr. Sweta?
Yes.
Yeah.
Please thank the chair and
Yes.
sir, thank you, sir. Thank you very much, sir, for chairing the session and conducting the proceedings of this interesting session, which is really very timely, and you have given very thought-provoking ideas for us to take further our research in this endeavor. And sir, as you have suggested us, as you have summarized the talks of all eminent scholars, and you have given your own views to undertake some of the components for the further research and future research at ISEC. We, CNR, in collaboration with the Center for Research in Urban Affairs, will conduct and will contribute something new in this endeavor, which you have suggested us to do, sir. Thank you so very much, sir, once again, and thank you all the panelists for your valuable contribution. Thank you so much.
Thank you.
Thank you, Dr. Sweta, for moderating this session in a highly efficient manner. Thank you so much.
Thank you, sir, for this opportunity.
Thank you, and we close this interesting panel now, and we move to another session, that is technical session number 4. We invite Professor M. Venkatesh to kindly chair the session and conduct the proceedings of this technical session. And here in this technical session number 4, traditional ecological knowledge, food security and conservation. Professor Venkatesha, I request you to please take over, and yeah, and then we will have to start another panel from 1 o'clock. So I request you to kindly moderate the session so that we can have very productive outcomes in a very stipulated time frame. Thank you so very much.
So, okay, good afternoon. Can you hear me?
Hear you, sir.
Okay. So, in this technical session 4, on ecological knowledge, traditional ecological knowledge, we have 2 invited lectures and 7 presentations. We already lost about 25 minutes in this session. So that's why I request presenters for invited lectures, speakers can take about 8 minutes. 2 invited speakers are there, and then 7 general presentation, can be given about 6 to 7 minutes. So we will start the program this session. First, I invite Professor C.
Rajashekaran, sir.
Rajashekaran for this session. Please, you can take over the presentation and make a presentation for about 8 minutes.
Yes, sir, sure, sir. Thanks for your kind information. I'm happy to present my lecture here without any further delay, sir.
Okay.
I think my screen is it visible, sir?
Yes, yes.
Yes,
now
sir.
visible.
Good afternoon to one of the honorable chair, as well organizers. I would like to thank the given opportunity and proceeding towards my presentation, that is valorization of fishermen traditional ethnobotanical knowledge and floristic diversity of Southeast Indian coastal region. The Southeast Indian coastal region, it's almost sharing 15% of our Indian coastal length. One of the second largest coastal lane in Indian subcontinent. Here, the fisherman community, it's really a different type of community.
Normally, we used to talk about tribals or something, but here the fisherman is mixed population. Even tribes, non-tribes, and other different communities who are settled down long ago have a very good tradition and traditional ecological and ethnobotanical knowledge. Almost in India, 1:10 ratio. Every 10 fellows of one Indian, you will be finding one fisherman. That is the ratio. It's almost in this region you are finding about 1.05 million fishermen in our Southeast Indian coastal line. This Southeast Indian coastal line, which is covering around our Tamil Nadu and Pondicherry states. And here, the area of coverage is between the Pulicat to Kanyakumari, around 1,138 kilometers, lying in between your longitude and latitude of 80.3 to 13.42 into the 77.17 and 8.23. And here almost we are covered almost you can say 13 districts of Tamil Nadu and 2 districts of Pondicherry. This region covers lying lagoons, marshes, beaches, and detailed deltas rich in mangrove forest. The climate of this region is vulnerable, and as you are finding out that a lot of variations. These things are affecting, changes are there, and what we are finding that floristic details of our experimental sites, or otherwise the coastal sites, 46 sites are covered, and what are all the your angiosperms and seaweeds, especially algae, or this one available or enlisted or otherwise documented. And then as we started interacting with them, we could find about their vibration, this one vibrant knowledge on this thing. Then it made me motivated me to study about their traditional ecological knowledge of fisherman community, because as you are finding out that physiochemical property of this the coastal lane, especially in winters and winters with the temperature as well as pH and salinity is found to be optimum, so that the diversity of this region will be enriched with very high floristic documentation and information, as this the coastal regions of Tamil Nadu and Pondicherry almost lying with drought our area. Either you will be finding the floods, or otherwise the cyclones, or otherwise the drought. As you are finding that threats, it's because of our the anthropogenic activities. As you are finding out that resorts and the tourist and pilgrimages are this one are located on this particular Southeast Indian coastal region, having the various the ecosystem is hampered with various means, that is sand dunes almost which is diminishing, and human settled are approaching, and then the damming and constructing activities as well as industrial activities are shooting up, as well as you are finding out resorts, and most of these resorts are established on sand dunes. And then the second thing is instead of saying second thing, first and foremost, the livelihood of our fisherman community is fishing activity. They always believe in blue revolution, and there is they means even though they are having very good the ethnobotanical knowledges, but we have to find provide an option and opportunity to believe bringing in use and utilization of green revolution of our this thing, which as we found out the angiosperm distribution between various regions, indicating that families and species and annuals and perennials, in winters we find highest number of document, that is about 120 species are recorded. And in case of algae also, the Palk Bay and this Gulf of Mannar is the hub for most of our seaweeds or algae. And this algae, almost as we are finding out that the highest number is recorded in only winters, 23
So,
numbers.
Professor, you have 2 minutes.
Yes, certainly, sir. And then as you are finding out the major and the traditional usage of even though it is not documented, but they are practicing it. As our student went there, when they found some fever and other things, immediately they have treated with the available plants and all. Very next day, our student is very perfect to proceed their field studies, which invites me to study this thing. They are having very good, traditional ethnobotanical knowledge as well as usage, but it is not documented. So I try to document this thing and provide this information to this, forum. And some of the highlights of the algae and other sea grasses and all also. Then your salt marshes also. The factors affecting diversity is due to our anthropogenic activities, whereas what we need for our this thing, what is it, conservation of tech and bioresources of south coastal region is we have to document the fisherman community, that is traditional ecological knowledge, and sharing that knowledge about the bioresources. Encourage the publication related to the documentation and conservation and the policy issues, which will be useful for other researchers, or study the researchers, or encourage the researchers. Then the conserve the extinct valuable bioresources by maintaining germplasm and preserve them the genes for long-term future uses. Most of our fishermen, they believe in only about that fauna, but they are not this thing, what to say, realizing the vital importance of our flora. That is the thing we have to emphasize it. Then we have to give cost-effective technology in sustainable manner with value additions. For this, the training programs, workshops, and educating local inhabitants to cultivate larger scale must be conducted by state and central government agencies to maintain our or conserve our biological resources, and also create alternative employment opportunities for the younger generation of fishing community. Because most of our younger younger generation, due to the various policy and as well as territorial issues and all, these younger generations are leaving their even fishing activities and leaving from their native places to urban areas. As the result, your traditional ecology, ethnobotanical knowledge is vanishing out. So we have to organize some interacting session with for the fishing farmers, with researchers, traders, and industrialists and policymakers to create awareness among the bioeconomy and bioeconomy on their bioresources, which will really this one, what to say, main sustains our floral the applications on their livelihood. I think this study has been advised by our team members, and any questions relevant to this, I'm happy to answer you. I think I completed as per our time allotment. Thank you for the given opportunity. Once again, thanking you very much.
So thank you, Professor Rajshekaran. Now there is no time. That's why I invite second speaker, Dr. Rajkamal Goswami. Please, Dr. Rajkamal Goswami, you take over the stage. You make a presentation. Please, you restrict to 8 minutes.
Thank you, Professor Rao. Thank you all the organizers for giving me this great opportunity. I'll start right away. I'm Rajkamal from A3. I'm a postdoc researcher. And to start with, I'll just try to show the relationship between the biodiversity, climate, and adaptation. So first, let's focus on some of the drivers which affect the climate change impacts that we see through the globe. And what is seen here is land use change is one of the largest drivers of the impacts that are created by climate change. Then we come to the next point, which is the important point, very important part of this technical session, which is the climate adaptation. So what are the different processes through which we can improve the adaptation and mitigation of climate change, or our response to climate change? So what you can see here, the green like interventions are something which creates positive responses for adaptation. And what is clearly seen here is that climate change has negative impacts on ecosystems, but some of these negative impacts can be reversed by looking at the mitigation measures, which include reforestation, forest creation, restoration of different landscapes, and protection of the natural systems by, say, fire control or species translocation and all. So basically what we know so far is that if we very simplify this relationship, so if there is a tendency where biodiversity richness is maintained or improved, there is also a tendency that the climate adaptation and mitigation improves or increases, and through which we can negate some of the negative impacts of climate change. With this view in mind, a national adaptation program of action by United Nations Climate Change was adopted by around 51 countries in 2017. Sadly, India is not part of it, but what you can see here clearly is that a lot of the interventions that are adopted by the 51 countries focuses on issues like improving the crops, the crop diversity, improving the livestock diversity, maintaining good nutritional value chains, and improving the forestry section. So with that view in mind, the hypothesis that we adopted for this particular research was to look at how bioresources and sustainable livelihoods in Northeast India can improve the adaptation of climate change. And because of the previous research background, the hypothesis that we have is that if there is a greater richness and diversity of bioresources, we can assume that there will be better mitigation and adaptation, say, capabilities towards climate change. So this study was carried out throughout Northeast India under the auspices of the DBT program, which ATRI is leading through around 2019, spread across 13 institutions in Northeast India. And as part of this particular presentation, what we are trying to show is we want to map the climate adaptation potential of these various states in Northeast India through diversity of biological resources. And to identify the biological richness used by the local communities, we conducted survey across two levels. We did household surveys and market surveys. If there is time, I'll explain why we need to do both household and market surveys. But right now, I just want to show the areas where all the surveys have been carried out so far. So you see throughout the Northeast India, except the states of Arunachal and Meghalaya, which is where the surveys will be conducted in the next phase, we have covered most parts of Northeast. And in this particular presentation, I'm going to show data from not two states, but across 3 states, the Sikkim state, the hilly part of West Bengal, and the plains part of Assam. So the hilly part of West Bengal also includes the Duar part, which is equivalent to the plain area surveyed in Assam. And so this map was showing the distribution of the households in the villages where the household survey has been carried out. And this map shows the towns and the villages where market surveys for bioresources were carried out. So what we see clearly was that Sikkim leads the species richness of bioresources. So if you can see in Sikkim, 150 species were used by across 79 households surveyed across 7 villages. Whereas in West Bengal, we found about 51 bioresources used by around 2 2 villages and 21 households. In Assam, we used by people, but the number of surveys was high. The species per village number is low. So in terms of both turnover of species and the index of species used by people, Sikkim shows very high source richness. And also similarly, we found that Sikkim leads the other states of Assam and West Bengal in terms of the species that is sold through the market. So a total of 82 species or 0.58 species of bioresources were sold by the market vendors there. And so previously I wanted to explain why it is important to include both market and households when we want
you have 2 minutes.
Yes, I'll try to conclude within 2 minutes. So if you can see, this shows the different types of categories of bioresources that is encountered in markets, the blue bars, and the households, the pink bars. And if you can see, in markets and households, there are hardly any overlap. So where edible handicraft medicines were sold in high quantities in market among household people, the bioresources which are used were belonging to the fodder, fuel wood, broom grass, and construction categories. So it is very important to include both the surveys. And what we also see is that as the number of vendors increase, the richness of bioresources also increase. This has also great implications for the climate adaptation and mitigation that we are going to discuss in this slide. So what so far the data that is available to us, what we clearly see is that the hill regions have higher species richness and market turnover in relation to the plain regions in terms of bioresource richness, which indicates that hill regions probably will have better climate adaptability and mitigation in relation to the other areas of the Northeast. So when we devise strategies and management regimes, we need to focus on the plain areas more than the hill areas. When we just focus on bioresources, why bioresources are important, these 2 points are really, really important. It provides excellent and cheap, high quality nutrition, and therefore may improve health in the context of COVID-19 and the previous session that the speakers highlighted. Health is emerging as a very important issue, and bioresources can, give enough nutrition to improve the health quality of people. It is also a rich source of income for the poorer and marginal sections. So for example, rural women. 90% of all the vendors that we saw dealing in bioresources were rural women. And the bioresource-based knowledge, because bioresource richness is directly correlated with the knowledge that people have of the landscapes, it can be used as an excellent tool to conserve existing bioresource and devise novel climate adaptation strategies, both of which are really, really important when we look into how to devise climate mitigation and adaptation strategies. Thank you very much, sir, for this opportunity. And I would like to acknowledge my entire team of 29 teams which are working for this particular project. And I also acknowledge the Department of Biotechnology for funding this study. Thank you very much.
So thank you, Dr. Goswami. Thank you very much. And now we have a general presentation. We have about 7 general presentation. So since time is very short, I request general presentation, speakers to restrict only 6 minutes. Now I invite Ms. Neha Biswas. Sneha Biswas?
Yes, sir.
Yes, I think you can start your presentation. We will give you only 6 minutes because there is a shortage of time because 7 members are there. Please, you start your presentation.
Okay, sir. I was informed that due to shortage of time, I should cut down my presentation. So I'll go without my PPT. I'll shortly present my findings from the field. So our topic is the usage of traditional ecological knowledge as adaptation strategy in the livelihoods of people of Indian Sundarbans. So traditional ecological knowledge can be defined as the knowledge base or practices which emerge from direct interactions with the environment, and world literature on TEK is used in the sectors of resource management, climate adaptations, etc. So in India particularly, it's been used for resource management purposes, and coming to Indian context, many authors have researched on the usage of TEK in various livelihood aspects, but none of them looked at all the livelihoods together. So the objective of our present study was to understand the usage of TEK among various livelihoods in Indian Sundarbans. So our study is a qualitative assessment based on case studies from selected villages. I'll directly come to the main findings of our study. First, in the agricultural sectors, there has observed a shift from the usage of traditional methods and tools to modernization. And in case of fertilizer usage, there is seeing both the usage of organic and chemical fertilizers. For example, organic fertilizers, for example, people use cow dung or rotten rice straws as fertilizers. Some of the major problems identified by the farmers were change in weather and drying up of plants, and also increased impact by the insects and the diseases caused by it. Some of the adaptation strategies identified were building up of a high area around their land, which is called aal, which is also used for vegetable cultivations. And as absence of irrigation facilities, farmers build their own ponds and collect the rainwaters, which they use as irrigation water in the later time. Coming to fishing occupation, fishing, honey collection, these occupations are still dependent upon traditional tools and techniques, as fishermen and honey collectors have to go into the deeper forest. They depend upon the lunar calendar and moon phases. They start their journey as the fishermen start their journey as the gone starts, which they say the 10th day from the new moon or full moon. And that time they depend upon the tidal waves generated in the river also, which helps them in rowing their boats and also get them better fish catch. And honey collection is considered as most dangerous of their profession, because it involves going into deeper into the forest, and they solely depend upon their knowledge of direction and navigation gathered through years of experiences. So people who depend upon forest are also guided by their belief on local deity, that is Bono Bibi. She is considered the deity of the forest, and she is considered to be the protector of the forest as well as the people. So people are moved by the thought that the goddess will protect them unless they become too much greedy of the products. Concluding my findings, I'll say that it's been seen in Sundarbans that agriculture is shifting away from traditional to the mechanized version, but irrigation problem remains as a major problem in the area. Given the biophysical vulnerability towards cyclones, floods, etc., specific DRR policies should be implemented in the area. As per now, there is no specific policies for the area, and if those who depend upon forest, their reverence towards nature and a sense of equity is shaped by their folk tales. And but the usage of TK is also as a result of the continuity of the political regime, because for example, fishermen are still not allowed to use mechanized boats. They have to row their boats, row small boats, but in case of tourism, bigger boats are allowed. So we need to question while inquiring about TK, we need to consider the political setup and power relation and historical change also, as it shapes the usage of TK. And thank you.
Okay.
With that, I'll conclude.
So thank you, Sneha, for completing within a stipulated time. Now I request second speaker, Dr. Digambar Chand. So Dr. Digambar Chand is there. So hello, Dr. Digambar Chand.
Hello.
Yes, yeah. Now you can start your presentation. You will be given only 6 minutes, please.
Thank you, sir. Thankful to you, sir. Okay. Good morning, sir. And today, just I am presenting my paper. Yes, sir. Okay. Okay, sir.
Climate change on food.
Paper is Severity of Climate Change on Food and Nutritional Security, a saga of Odisha. So we know that Odisha is a state in the east coast of India, where within 100 years, 98 natural calamities Odisha has already witnessed. Next, here we can find that the state has experienced 18 years of flood, 11 years of drought, and 7 years of cyclone, including super cyclone of 1999. Heavy rainfall during monsoon causes floods in the rivers, flow of water from neighboring states like Jharkhand and Chhattisgarh, which also affect to Odisha. Now,
you can put it in presentation mode, sir.
The objectives, sir, the empirical study of severity of climate change in Odisha, to study the impact of climate change on agriculture and allied activities, to study the impact of climate change on nutritional aspect of Odisha, to study the government intervention on nutrition specific and nutrition sensitive scheme. Next, the database and methodology. Here we have taken the data from RBI Bulletin and the Special Relief Commissioner, Government of Odisha, and the methodology we have taken about the trend analysis with percentage of variation, R square, pie chart, bar diagram, etc. And next part here, after that, now I am going to show you the severity of climate change, how the climate change affects Odisha in different years. Here, see here, this one. In this situation, we can find in 2010, the highest 80 districts have been covered by cyclone. Then it is 80%. Next year, 76% of Odisha have already faced about cyclone, and this is the chart here. So already I have given you the chart of different here in Odisha. Here, how the drought affected to Odisha. Here we have taken the 1993 to 2020. This is the chart of drought. So here in 1998, 86.7% of Odisha faced drought, and 2002, 96.7%, and it is just same as 2000 also. Within 2 years also, the drought Odisha also faced. But during that time, what was the trend analysis of the rainfall in Odisha? It is, we can see here, the trend analysis, R square is equal to 0.951. So it is increasing in this way. So trend analysis of yield of pulses means here, as we concentrate on nutrition, So pulses are the main aspect in our study. So the yield production is here. R square is 0.913, means the pulses is rising, but availability of pulses to the poor people is not sufficient. So in that situation also, next we will go to egg production, because egg, meat and fish are the secondary sources of food to the people, and generally the people keep hen in their houses. So in this situation from 2004 to 2019, our trend analysis is also going on rising, and the curve is like shows like this. And next is our fish production. Fish production is also increasing, and the availability of fish, the prices of fish are also going on increasing, and now the ponds are dried almost in all area, and the people cannot collect fish from the pond. So in that way, it is not also easily available to them, those who have more price. And during the pandemic period particularly, the people who are very poor, they cannot get the secondary sources of food properly. So meat production is also, people also keep the goatry, and there is piggery, goatry, etc. are there. So meat production is also increasing trend, because though everything is increasing trend, still there is nutritional deficiency of Odisha. And here we can compare between the Odisha and India. In this situation, the stunting, wasting, underweight, anemia in children, and anemia in women. Here, these are the data we have shown. Here, India, 38.4%, but in Odisha, it is 34.1% in stunting case. Then wasting also the same thing. We can find the more rate in India level, though Odisha is within India, still we can find the comparative study between India and Odisha. We can find the nutritional deficiency in Odisha also. So in this situation, the
Doctor, you can conclude.
Next, the government intervention here, the midday meal, a budget for nutrition specific intervention. So these are the situation here by Mamata program. Then budgetary nutritional sensitive here. Here the government intervention to how the farmers are getting benefit out of the farmers covered in Rabi crop. These are the data already we have shown. Next is Kharif crop. Hello. Am I audible? Okay. Then the policy recommendation. So though in India, the western Odisha part is suffering from flash flood. The new barrages should be constructed on the riverbed to control flash flood in hinterland of Odisha and promote lift irrigation to avoid drought. Agriculture zone should be developed various nutrient. Though the different crops are cultivated here, and commercially we are cultivating now paddy in this situation. In Western Odisha particularly, as Hirakud Dam is here, so the people are cultivating paddy as a commercial crop, so they lack nutrients in this situation. Particularly, I may give an example of Bargarh district of Attabira block. Attabira block is the rice bowl of Odisha, but still the nutrition level is there high. Next is here, the community garden will be effective in school and village level. Earlier there was community garden, mostly the fruits, etc. and other things also, but now it is not there. Use of technology, mass media for awareness about information, prior information. The people evacuation is the only way to save from casualty and loss of Odisha. And we can compare within the 2 years particularly.
Please you conclude.
Okay, sir.
Please conclude.
Okay. In 99, the super cyclone occurred. In the time, heavy casualties was there, but now in Amphan 2020, very less, because people evacuation is possible in this time, and the awareness among the people rise due to mass spread of mass communication. Thank you, sir. Okay. Time, I could not show much more. So, next part, sir.
No, thanks. Okay. So thank you, Dr. Digambar. Thank you very much for your presentation. Now I invite the third speaker, Mr. V. Swaran. So Mr. V. Swaran.
Yes, sir.
Yes, you can start, and please you take only 6 minutes. Otherwise, there is a acute shortage of time. So you can start your presentation.
So good afternoon, everyone. So I will be talking about indigenous agri-food systems of the Wayanad district in Kerala. It goes to the disclaimer that this study has been carried out almost 6 years back in 2015. So the datasets are a bit old now. So first I have to define what is indigenous knowledge before getting into the agri-food system. So indigenous knowledge, I go with this definition that it is the local knowledge held by indigenous people as well as the local knowledge unique to a given culture or a society. So it's not just limited to the Adivasi communities, but it's contextualized to a particular locality. And also in connection with that, with the climate crisis, I define it as a bigger problem that operates at multiple spatial and temporal levels. So because of this, we cannot make assumptions or come to conclusions of solving climate crisis by studying at a one particular level, either a global or local. The another thing, so the resilience of indigenous knowing and vulnerability indigenous knowledge. So these are two particular terms. So with indigenous knowing, it's the act of understanding, perceiving the local environment, which is important in bringing resilience. Whereas the vulnerability is the already existing repository of knowledge. So that is under vulnerability now due to various forces, as you will see. So this is the location of Wayanad district. It's almost 40% under forest cover and it has the highest population of Adivasi communities. And here the speciality is that 96% of the population lives in rural area and a significant about 42% depends on the agriculture, either as cultivators or as agriculture workers. So this is the context. It's one of the 4 climate change hotspots identified in the state action plan of climate change, and also the Gargil's committee, Western Ghats Ecological Expert Panel, has identified all 3 talukas in this districts as ecological sensitive zone 1, which requires utmost care and protection. And interestingly, the crop mix of this district is such that 64% of the cropping is constituted by plantation crops as well as spices, as you can see here. And just to bring a perspective, geographical perspective, this is how it's located. So this is the rest of the Kerala. It's situated at an elevated plateau. So the geographical location is unlike anywhere. So the objective of this study is to understand the existing knowledge, which I claim to be vulnerable now, of 3 communities: Paniya, Kuruma, and Kattunaik and Adivasi communities. These 3 communities were chosen because their historical background, they comes from distinct backgrounds. Paniya were historically bonded laborers. Kurumas were farmers, and Kattunaikan were dependent upon forest, and they used to dwell either in forest or forest ranges. And the second objective was to understand their perceptions on climate variability and to compare that with the measured data. So the methodology I have used the contextual inquiry. So contextual inquiry is looking deep into a particular context. So in this case, I have interacted with the farmers and other Adivasi communities areas in their place of work, following them, their practices and all. So sampling was purposive because we have to know some niche existing in these communities. And data saturation was how we decided the sample size. And for the rainfall data, I have taken primarily considered the satellite data, TRMM data, which couldn't use for some reasons. And I had to rely on IMD data for 1 decade to understand the climate variability. So the key results is that the 3 communities, their indigenous knowledge system is distinct in the sense that the Paniya community, one community, their primary application of the knowledge is on food and medicine, whereas the Kuruma, it's farming and medicine, whereas on Kattunaikan, it's on food. And on food, it means wild food. So these days, when it comes to food, we don't think about the wild food, the uncultivated food. So this is one important thing. So the wild food, it's rich as it consists of leafy vegetables, tubers, and even sources of meats. They depend, and at times of monsoon, they consume different varieties of crabs, snails, and even small birds used to be consumed in a bygone era. So and then medicine. So another important fact is that these wild food are inherently medicinal in property. So you can't discern between one is food and one is medicine. So that's how they are. And on special occasions, they used to make use of these medicinal plants to make potions, and which is a traditional kept secret of the Kuruma community. When it comes to farming, the Kuruma communities and as custodians of traditional land traces, which are very well studied. So some of them have some climate resilient properties like the Velian, which are flood tolerant, and then Edukan Kaladian, drought tolerant, and Mullankayma has some thorny spikes in the stalk, which can be used to thwart the birds. So these are the cultural heritage of the community, and despite of the financial losses, they continue their practice just because of that, just to continue their tradition. So on the perceptions of rainfall variability, the majority has said there is a rainfall, scanty rainfall after sowing, and there was a heavy rainfall during harvesting. Both are detrimental to the agricultural process. So concomitant with that, the trend analysis revealed that there is a decrease in May rainfall, considerable decrease in May rainfall. So this rainfall, this is where the sowing usually happens around May, June. And also this is important for the plantation crops in the district, for the coffee blooming and all. Also simultaneously, there is a decrease in the December rainfall during the harvesting time.
Swaran, please conclude.
Yes. So these are the takeaway and suggestions. So there is a wild food, we often don't consider it as a food. So it has to be considered along with the PDS and markets. And there is a multidimensionality to it, which is as food as well as medicine. And as of now, the Adivasi communities, they feel a compulsion to continue with this practice because of its conservation. And interestingly, one suggestion is that there is a contingency plan made by the ICAR for agriculture, which doesn't mention that so-and-so seed varieties can be used. If these land races can be considered in that, that will be much useful. Also, the spatial rainfall variability is like very varied across the district, which often masks in the district level average. So similarly, the ethnometeorological knowledge we can just bring together. Instead of integrating two sets of knowledge, traditional and the scientific, we can conjunctively use both of them to understand the local ecology, meteorology, and furthering the resilience. So that's it. Thank you.
So thank you.
Thank you, sir.
Thank you, Mr. Swaran. Now I invite Dr. Deepa. So Dr. Deepa, you please make your presentation and restrict to 6 minutes.
Yes,
please,
sir.
Dr. Deepa.
Yeah, sir.
Yes. So you can go ahead.
Yes, sir. Can you see my PowerPoint?
No, slides not visible. You can share your screen.
Yeah.
In presentation mode. So you share the screen.
Yes, sir.
So you open the screen in the screen, then you can share.
Okay, sir. Yeah.
You open the PPT in the desktop and then you
Yes,
share
sir.
the screen. Okay.
It's not coming. I'm trying to share the screen, but it's not coming.
It's a problem.
Yeah.
Now, I think if it is not possible, we will give you next chance. Now you will go to some other speaker. Shall I do that?
Yes, sir. Yes, sir. Yeah.
Okay. So now there is some a problem in screen sharing by Dr. Deepa. Now that's why I invite Miss Rajashri Patil to make her presentation. Miss Patil. Patil is there? Miss Rajashri Patil.
Am I audible, sir?
Yeah, now you can start. Please take only 6 minutes.
Okay, sir.
Okay. So thank you, please.
Good morning, everyone. Myself, Rajeshri Patil. Presently, I am PhD Research Scholar in University Law College, Bangalore. Today, I am going to present paper on traditional knowledge as a tool for protecting biodiversity.
Okay.
Globalization on traditional knowledge has been the shift of local and traditional knowledge into global knowledge. Claiming monopoly right without acknowledging holders of traditional knowledge is a serious threat. Am I audible, sir?
Yes, you can go ahead.
In ancient days, ideas were exchanged without expectation anything in return. But now everything has been monopolized by exploitation of biological resources, which leads to misappropriation of biodiversity. Protection and safeguarding of traditional knowledge has been the essence of discourse. Traditional knowledge is an important element to manufacture new products by enacting sui generis system and by protecting the holders of traditional knowledge. TRIPS agreement, it has to relook some provisions and make suitable amendments. Medical plants plays a vital role in healthcare systems of the world. The Indian structures of medicine like Ayurveda, Unani Siddha and homeopathic system predominantly use plant-based raw materials for most of their formulation and preparations. The WHO estimated that 80% of the population of developing countries relies on traditional medicines, mostly plant drugs for their primary healthcare needs. For example, neem, turmeric. How the patent has been granted, it was granted for neem and turmeric case, then later stage, it has been revoked. So these are the few examples for biopiracy. Moving to further, the challenges, the key challenges for traditional knowledge. Here, the intellectual property rights, it is posing serious threat for protecting traditional knowledge by way of monopoly right, wherein the benefit sharing has not been given to the traditional knowledge holder. Then secondly, the reward and recognition has not been recognized of the traditional knowledge holder. There is no proper documentation. So these are the key challenges wherein they are not in a position to protect the traditional knowledge. Developing an international IP regime to protect traditional knowledge is challenging. In many instances, traditional knowledge, including sacred and secret knowledge, does not fit neatly into the established intellectual property system. National and regional laws that protect traditional knowledge have only a limited impact. So therefore, entering bilateral or plurilateral agreements are very much feasible by fixing minimum standard. Moving to the traditional knowledge digital library. There are attempts in various countries to form digital libraries on traditional knowledge. These libraries would have a database on prevailing traditional knowledge available in the public domain. As we know that one of the criteria for granting patent is novelty, which means new. If there is a patent claim for an invention, it is easier to track the existing knowledge and reject or accept the application for patent based on the available information in the database of the libraries. Definitely, this will avoid the biopiracy cases. The traditional ecological knowledge prior art database has issued an offer to traditional knowledge holder to submit their knowledge to the database if they want them to be placed in the public domain. In 2005, the Traditional Knowledge Digital Library expert group estimated that about 2,000 wrong patents concerning Indian systems of medicines were being granted every year at international level, mainly due to the fact that India's traditional medicinal knowledge, which exists in local languages such as Sanskrit, Hindi, Arabic, Urdu, Tamil, etc., is neither accessible nor comprehensible for patent examiner at the International Patent Office. Therefore, Traditional Knowledge Digital Library is proving to be an effective deterrent against biopiracy and is being recognized as a global leader in the area of traditional knowledge protection. Moving to the international efforts for protecting traditional knowledge. As per the WTO TRIPS agreement, according to Article 27(3)(b), wherein it states that IPR can be protected for plant varieties at the national level either through patents or an effective sui generis system or both. So here, by looking to this TRIPS agreement, we can say that it is totally failed to protect traditional knowledge. Already we can see that by way of sui generis system, Philippines, Thailand, Costa Rica, they have enacted the traditional knowledge legislation. Therefore, they are protecting the traditional knowledge. But we do not have specific legislation. Therefore, the TRIPS agreement, it has to relook the provisions of TRIPS agreement, and it has to make modification. I mean to say that amendment to the provisions of TRIPS agreement, so that it is easy to protect traditional knowledge. Moving to the international agreement, that is Convention on Biological Diversity, wherein the main purpose of CBD is firstly the sustainable development, secondly conservation of biological resources, thirdly benefit sharing clause. According to Article 8J of CBD, which states that equitable sharing the benefits that arises out of the use of traditional knowledge is the main thing. So here the traditional knowledge has been protected under CBD. So it clearly states that it has to be protected, recognition should be given, benefit sharing should be given for the traditional knowledge holders. For example, in Kani tribal case, the Arogya Pacha plant, which was using by the tribal communities, then later on the researchers, they developed the drug called Jivani. Then in this instant case, this Kani tribal case is an instant case, landmark judgment, I can say that, wherein the recognition has been given to the Kani tribal people, benefit sharing has been given to the Kani tribal people.
Okay,
then,
time.
Yes, moving on to the Biodiversity Act 2002. As per Biodiversity Act 2002, we have under section 36, subsection 5, wherein it states that registration of traditional knowledge and development of sui generis system. It can be by way of sui generis system, we can protect traditional knowledge and registration can be made. Then moving on to the findings, the protection and safeguarding of traditional knowledge has been the essence of this paper. Traditional knowledge is an important lead to the developed countries for their new development and manufacture of new products. So the sui generis system is considered to be the only course left. It has to be conceived both at the national and international level. TK is a tool for protecting biodiversity. So we can say that traditional knowledge and biodiversity are the two faces of the same coin. Therefore, it is a need of the hour. Protecting traditional knowledge and biodiversity, it has become an important concern. Though we have Biodiversity Act 2002, still the biodiversity cases are increasing. If we focus on BT brinjal case, if we focus on BT cotton case, Greenpeace case, where the cases are increasing, it means that there are so many loopholes which are existing in Biodiversity Act 2002. So therefore, besides legislation and regulations of the government, it is always better to involve the people in participatory mode. Thank you. With this, now I thank the organizers for conducting wonderful workshop and providing me an opportunity to make my presentation. Thank you one and all.
So thank you, Rajeshri Patil. Now I invite Dr. Deepa. Dr. Deepa, are you ready?
Yes, sir.
Okay, now you can start and please restrict. You take only 5 minutes, 5 to 6.
Yes, sir. Can you see the?
Yes. You can go ahead. You can use presentation mode.
Yes, sir.
Down. Right side, presentation mode will be there. This side. Left, just there only. The presentation mode, or you can start. No problem.
Yes, sir. Yeah. Before coming to the slide, actually, I'm going to talk about the climate change and community-based practices, study of traditional knowledge of the tribal communities in Kerala. Before coming to the presentation, I just, last two speakers already talk about the field, which I'm going to cover, that is Wayanad, and also the policy problems. Before that, I'm going to show some pictures I have taken from Wayanad district. And before that, I come to the some basic character traditional medicinal knowledge is that it is oral in nature, and also it is holistic in nature, and it is transmitting from generation to generation. So the main policy, as the last speaker talked about, the modern intellectual property rights, which is not adequate to protect the kind of community-based knowledge. And also the Geographical Indication Act is also introduced in 2000. That is also not sufficient because it is actually covering a particular area, and also that the plant variety, the protection of plant variety, that is actually talking about some kind of characteristics like it should be unique, it should be novel. That is also not going to cover up by the traditional medicinal knowledge. And national IPR policy is also introduced in 2016. That also not covering the innovation part of the traditional medicine knowledge. And the Forest Act, which is introduced in 2006 to restore the rights of the traditional communities. But the implementation is not yet fulfilled, and many parts it is actually the failure. So coming to the importance of the traditional medicine knowledge, that is actually talking about that this the role of indigenous communities to fight against deforestation, land degradation, and climate change has been neglected or denied, and not yet given much attention among the policymakers. However, they have directly contributed to biological and cultural diversity, poverty reduction, conflict resolution, food security, and ecosystem health. So the Sustainable Development Goals also actually giving importance for the protection of the indigenous life. And the recent report published by the UN also talking about that the non-communicable diseases which is arising because we are actually going away from the nature. So we have to connect with the nature, human life, and also like that the animal life also. So like we have to introduce kind of a one health system or planetary health system of knowledge. So I'm going to share some of the photographs which I've taken. That is, I just want to show that how these indigenous communities still doing the practices, how they are linking their life to the nature still. So this is the way they store the medicine they collected from the forest. Actually, they divide the people that some people go to the forest, some will prepare the medicine, some will do the practices. This kind of division is also there. So this is one method. This is the another method, and also like they prepare the knowledge. Like this is the traditional way they cut the medicinal leaf. This is the grinding part. They make the medicine like that. So these are all very traditional way. This is they using the wood to make the medicine, and this is the place they are preparing the medicine. And the furnace they are using is this. The furnace they are using, the utensils they are using. This they are still they are very engaged in the very traditional way. This is the medicine they prepared and labeled for what all the diseases they are using it. And this is a steam bath they are using, that is also made by the wood. This is one the traditional healer. He's actually elaborating that what these medicinal plants for what diseases it is using. Because they have very knowledge about the environment, and this is also like he's describing these medicinal plants for what all the diseases they are using. This is the another healer. Actually, that is something keeping that on the table, that black in color. That is a seed. They still collecting from the forest, and they use it for the as part of the food. And this is also like they prepare the medicines, and that is the photo is not visible. It is he's treating a patient. He has sprain on leg, and this is a patient that is I have taken that this is a kind of like some half an hour like duration. This much people are there, and this is the way they are treating. Like he is diagnosing the diseases. And also one more thing is that like I just want to show that like how traditionally they are keeping they are storing the groundwater. This is the traditional way they are keeping it in the like inside a forest using the shed of the bamboo and all. So I just wanted to show suggest that we still do not have, as
Please
earlier.
conclude.
Yeah.
Conclude,
This is the suggestion only that as earlier speaker told, that we do not have a proper mechanism to protect the traditional knowledge. We still fail that in the access and benefit sharing mechanism. And also the younger generation are not interested due to this problem. So like we have to encourage the younger generation to be part of the these practices. And also we have to adapt and strengthen the biodiversity, people
So please
biodiversity
conclude
register.
your talk.
Yeah, this is a conclusion that the policy suggestions. Thank you.
So thank you.
Yeah.
So thank you, Dr. Deepa. Now I invite Dr. Preeta Acharya. Mr. Preeta Acharya. So Preeta Acharya is there. So now presentation by Preeta Acharya. Mr. Preeta Acharya is not there. Okay, now we will move to the last speaker, Miss Bhagyashree Shahu. Miss Bhagyashree Shahu.
Am I audible, sir?
Yes, sir. Now who is talking?
Am I audible?
Bhagyashree.
Yes, sir.
Okay, you can go ahead. So Bhagyashree Shahu, you can make a presentation for 5 minutes.
Okay, sir.
Bhagyashree, I think you have switched on another device. I would suggest you switch off the audio of that device.
Okay, sir. Just a second, sir.
You share the screen.
Is it visible?
Yeah, visible. You can make in presentation mode. You can switch to presentation mode.
Is it okay, sir?
Okay, you can go ahead.
Okay, sir. Thank you, sir. Namaste, respected chairperson, sir. And
Please, you
hello?
restrict only for 5 minutes.
Okay, sir.
Go for important aspects.
Yes, sir. Now I'm going to present environmental issue and analysis of food security and nutritional security under climate change of particular vulnerable tribal group PBDGs, Banda Malkangir district of Odisha. Now, lack of timing, I'm just wrap on. This is I have structure of presentation for PBDGs and so I'm directly coming coming to my aims and objectives. So, am I audible, sir?
Yes, you can go ahead.
My first objective is at the outset, Rich will be explore the general environment issue of different dimensions and to understand the concept of climate change of Banda PBTGS context. Second one is to find out of the different natural resources of livelihood to maintain food security and nutrition security of Banda PBTGS, to suggest the suitable strategies for the conservation of natural resources, protection of ecosystem and policy condition of PBTGS. After that, I'm coming directly area and people. If I talk about Banda PBTGS, so Banda homeland spread in the 130-kilometer area situated in pretty topographical museum exhibited landscape scenario, and it's situated in 300 meters above the sea level. In all over world, if I introduce Banda PBTGS, first we would know the Banda women because the unique look and costumes are very attractive first introduction attention. Banda women used to have the southern head wear scanty self-women skirt, Nordic prepared out carrying a fiber arden themselves with the color stones and beads. After that,
You go to important results and conclusions.
Yes, sir. I'm coming from the Banda food habit. After that, I would like to introduce Banda food habits and pattern, because Bandas both vegetarian and non-vegetarians. In regular basic, Bandas are regularly take ragi soup, which is called in their language gruel, and salap. This is the one type of alcohol which is made in sago plum trees juice. Rikjang, one type of small seed of rice. Kejang, one type of normal boiled rice. Green, different type of green leaves, bamboo roots. The dry fish is called in Bonda language bitia. But this is the one type of favorite food of Bonda PBTGs. But now they don't get sufficient dry fish uh, to take to consume. Because of the water resources, more of streams are now dry. So during my field work, I observed now they don't get sufficient cattle grazing field. Bandas actually PBTGs are totally hubs depend on the total whole life in the forest and agriculture. But under the climate change now, they don't get enough forest product for their survival because of the natural resources degradation. So basically, Banda is known as the hunter, but now they don't get sufficient animals for the regular hunt. If Banda food habits, if I'm talking about Banda food habits in non-vegetarian purpose, they would like to eat pitas mosca snake meat, kembugase, siramse, sulopase in the deer meat, latubuse the swamp deer meat, but the gulse the rabbit meat. But this type of meat now they don't get available more of the time because of timing, because of the forest degradation. Next is Bonda second seasonal foods. Bondas are loved to eat already non-timber forest produce based on the whole livelihood. So they want to seasonal foods, the gui huti, the berry mushrooms, to eat the bamboo mushrooms, uli to eat the mango mushrooms, emur to eat the salad tree mushrooms, the variety of mushrooms they consume, and many more. But in current situation, they don't get collect enough non-timber forest produce to fulfillment their nutritional and food requirement. It is indicated the unexpected rainfall, increasing the temperature, changes in the natural ecosystem, which is not supposed to grow in this kind of non-timber forest product. Also, it's the soil degradation happens due to the.
Please conclude.
Okay, sir. Due to the reservation or shifting cultivation or Padu cultivation. Now, my suggestion and conclusions, I'm directly coming to this. First, I want to say that documentation of food pattern and systemize of market integration, restoration of water bodies and other natural resources in PBTG's area, increasing soil moisturization condition in organic way, increasing the outreach of policy of programs of scheduled tribes, and creating awareness through mass training, seasonability and processing, giving an important balancing based line research input and traditional ecological system. That's it, sir. Thank you.
Okay, thank you.
Thank you, NIDL,
So,
for giving me this opportunity. Thank you.
we have finished this session, technical session 4. I thank all presenters. 2 invited lectures and 6 general presentations are made in this session. And since there is no time, already time is over, shortage, I will conclude this session. I thank all presenters, and also I will close the session. I thank Sunil Natyal for giving me this opportunity. So Dr. Sunil Natyal.
Thank you so very much, sir, for conducting this session in a very meticulous manner. Yes. And we enjoyed the presentations. Those time was short, but all the presenters, yes, all the scholars were able to communicate their finding to us, and they have very meticulously, scientifically linked, yes, their finding to this theme of the conference, to the theme of the conference. Thank you so very much. Please send all your presentations to us. Also, if you have any question, please put on the chat box. We will send to the respective presenter or scholars, and they will definitely respond to your queries. Now, thank you. I on behalf of NIDM New Delhi and on behalf of ISEC, I would like to thank our chairperson session, Professor M.G. Venkatesha. Thank you so very much, sir.
So thank you, Sunil, Dr. Sunil.
Now we move to the much awaited session, panel discussion number 4, traditional ecological knowledge and socio-ecological sustainability in contemporary debate. This session is a much awaited session. A doyen of the field are giving their expert views to all of us in this very important topic. Before I request the moderator of the session, Professor C. Rajashekaran, to take over, I just make one point that chairperson of the session is our respected, our dear Professor K. N. Ganeshaya ji. We are truly privileged and honored that Professor Ganeshaya sir has accepted our request to chair this session. Sir, session chair and our distinguished scholars, our distinguished professors, Professor K.S. Rao, my own teacher, Ms. Meenakshi Negi, Commissioner Ayush, Professor R.K. Mekhuri, my own teacher, Dr. R.S. Rawal, Director of G.B. Pant Institute, and Professor M.D. Suhas Chandran. We welcome you all to this session, and we are sorry that we are conducting this session in lunch time, but I am sure that you will forgive us. Thank you so very much. And Dr. Rajashekaran, please take over.
Professor Rajashekaran, please unmute and speak.
Thank you, Professor Sunil Nautiyal. It's my immense pleasure to introduce about our chairperson and our leading panelists of our panel number 4, traditional ecological knowledge and socio-economic ecological sustainable contemporary debate. Professor Ganeshaya, K.N. Ganeshaya is a well-renowned agricultural academician come scientist, is a fellow of various academies of our Indian subcontinent, FNA, FASE, FNAAS. Likewise, almost all the academies, his the contribution is regarded and awarded as a fellow also. And he took retirement from GKVK, that is University of Agricultural Sciences. He is a well-known scholar having a very good contribution on biological diversity, especially mapping and mapping of flora across our Indian subcontinent, having various databases on this thing. His contribution in literary work is also equally important. He has many this one books includes novels also he has published. He has in his credentials almost 157 papers are published, 11 edited books and 38 book chapters, and 19 literary books are also published. He has a recipient of various prestigious awards like British Petroleum Award, then this one Raitoro Hashimoto Afed Award, Gold Prize, and then Radio Hope Award, media from Iran, and other many awards are there. I am proud to introduce our chairman to our audience. Welcome you, sir. And our leading panelist, Professor K.S. Rao. He is my own teacher also. It's my privilege to introduce him. He started his career with the Central Silk Board and then with the G.B. Pant Institute of Himalayan Environment and Development.
Rajashekaran, shorten it. Don't read on.
Then with now he is with our prestigious Delhi University. Professor Rao is having a very good contribution in the field of natural resource management, sustainable development of Himalaya, and biodiversity assessment across our Indian Himalayan region. He is a recipient of various awards like Vasisth Vigyan Praskar from MNEF, and then UGC National Swami Pravananda Saraswati Award, likewise many awards. Yes, various other contributions in the field of science and technology. And I welcome you, sir. And then Miss Meenakshi Negi. She is presently working as a commissioner in Ayush Department of Health and Family Welfare, Government of Karnataka. She is, working with this department and promoting various ethnobotanical knowledge resources to the to the society, as well as protecting the wildlife. This thing acts and protecting wildlife areas and all. She is also currently doing her PhD with ISEC towards medicinal plants and its livelihood. Then again, one more. I'm welcoming Ms. Meenakshi Negi also for this panel session, and I'm introducing our own teacher, Professor R.K. Macri. Again, sir started his career from GP Pant Institute of Himalayan Environment Development, and he is with Hemantinagar Bhagwan Garhwal University. He is having a n number of publications, 400 and odd number of publications. He has handled many projects and also running many projects, and he is a recipient of Eminent Scientist Award, Millennium Eminent Scientist Award from MNEF, then Paryavaran Puraskar Award from Government of Uttarakhand, and so on. It's my immense pleasure to welcome you also, sir. And then Dr. Ranbir Singh Rawal, again from our GP Pant Institute of Himalayan Environment and Development. Professor Dr. R.S. Rawal is a present director also. He also indirectly teaches also in various aspects when I was at GP Pant Institute of Himalayan Environment Development. He is having almost 35 years of experience in this field, and having a his specialization is on the floristic ecologist, especially his work is known in the field studies and field relevant conservation aspects of Indian Himalayan region. His contribution is major contribution is that he is having a publication in science also. Many papers, books, and all he published. This is his credential. Then I welcome you, sir, in this gathering. Dr. M.D. Subhash Chandran. He is a consultant scientist in Center for Ecological Sciences, IISc Bangalore. He did his doctorate in vegetation changes in Western Ghats, and his research including forest ecology. His contribution, especially with NFTM and other this thing, is a remarkable one. He is a recipient of Best Teacher in Science Award by Karnataka State, as well as he is a recipient of Karnataka Rajya Seva Award and Environmental Environment and Agricultural area. All these eminent personalities I am welcoming to this particular this panel session. I am handovering this session to our chair, Professor K.N. Ganesaya. Thank you, sir.
Thank you, Professor Rajshekaran. It's wonderful seeing you all here. Dr. K.S. Rao, good afternoon. Dr. Subhash, good afternoon. Madam Negi, good afternoon. I also wish Rawal and Maikuri. It's wonderful to see all of you. We only have been in touch with the work that you all have been doing through papers and all. I have read the papers. I know K.S. Rao very well for a long time and Subhash Chandra, but I've been keeping track of the work by Rawal and Maikuri. I know Mrs. Negi also because of my association with the Department of Forestry and Forestry of the Karnataka government. I would not like to now take too much of time because we now see that there is already very little time available for the panel members. So what I would do is just place in front of you three issues. One is the fact that this whole debate, I don't know why it is called debate, because we don't have two sides for the thing. We only have a discussion, I guess.
Yeah.
So in discussion theme, we have two elements. One is the traditional ecological knowledge, and second is socio-ecological sustainability. How is the traditional ecological knowledge perhaps can help us in sustaining the social and ecological stability of or the productivity of the ecosystems. Now, I would like to place 3 points in the context of these two issues. One, do we have traditional knowledge that we can claim to be really knowledge that can be applied for ecology and conservation? The reason why I'm raising this issue is that we have been talking almost for 2 decades about traditional knowledge, but there are hardly any efforts to now evaluate whether this knowledge is in fact applicable, if it in fact has been proven to be really good to be now taken as a body of knowledge that can be objectively tested. More often we see that there is only anecdotal statements on the traditional knowledge. But the question is, have you proven these anecdotal knowledge systems as applicable to the field? How good is this traditional knowledge? In other words, how objective is the traditional knowledge we are talking about? Has there been any test of this? And if there is a test of this, can it be proven to be useful, especially in safeguarding the ecological and sustainable ecosystems, sustainability of ecosystems? And if we can prove that it can be used, can we apply it directly? Do we have any examples of that kind? Perhaps it's enough time that we speak about the goodness of traditional knowledge. We should now speak about the usefulness of it and the cases of applying it to the field as such. And if we can apply it, can we now develop a model of how to now document, how to test, and how to now apply it in the field? These are the issues that I think we should perhaps discuss. And I'm sure we are starting off with a very knowledgeable scientist, Dr. K.S. Rao, whom I've admired a lot when I was associated with him during the Himalayan ecosystem project that Department of Science and Technology had launched. I would not like to take too much of time because I would leave it to you to now spend more time and discuss more time on that. Dr. Rao, I will leave the stage to you. Please go ahead.
Okay, good afternoon, sir. And it is pleasure to interact with you all the time. And good afternoon to all the members. The topic I was asked to look at is the traditional knowledge systems and the restoration. So I was really surprised. Do restoration as a topic do have any traditional knowledge? This is what has been bugging me. Though I have been writing several papers on the restoration ecology, I never had looked it in terms of what is the traditional ecological knowledge that is present in the restoration part. I always considered it as they originated from the harvesting the resources from the forest. So the foresters has introduced it as the economic activity rather than any traditional. So I started looking at when the topic was allocated to me. So we could see that the traditional knowledge, where we have been seeing that people has been arguing that it is a knowledge that has been long established. So do we agree that the restoration as an activity has been a long established? And it is not so. So then why we are talking about traditional ecological knowledge in the restoration? Then what ecological knowledge has been put into the restoration project? That's what we could be looking at. Then I looked at what the traditional knowledge is. Then we have thought perhaps the knowledge that has been transmitted from one generation to the generation. So do we have any knowledge that has been transmitted from one generation to the other generation in terms of making restoration as a successful activity? And that is useful in terms of restoring the ecosystems into the actual function. Even that is not so true in any of the case studies that we have come across. If that is so, why this traditional ecological knowledge and restoration has been discussed in several of the publications? Then I have seen that basically, if you look in terms of the restoration, it is basically a conventional knowledge rather than traditional knowledge. And this conventional knowledge is only because it has been practiced by a group of people who has been looking at the provisioning services only, exclusively. And thus, people has been talking because it has been adopted partially by traditional society, and then it has become a traditional ecological knowledge. And rather than actually the societies have some knowledge that has been transmitted from generation to generation. So if that is so, why the traditional societies has adopted to this? Then from the anthropological perspective, when we look at, humans are always like animals trying to move away when the resources are constrained rather than trying to regenerate resources there. So it is a nomadic trait of the humans that never allowed them to stay at one place where the resources has become constrained. So never had been in the human society, restoration as a principle has been occurred into the traditions to them. This is the first thing I have realized. Then why we are talking about restoration as an activity? So when the societies has been constantly moving away from the places where the resources has been becoming scarce, then people has realized after settling with the agriculture that they need to make some adjustments. This is where the first time we have realized the natural regeneration could be assisted by the human societies. So this is where assisted regeneration has become a part of the knowledge in the traditional society. So they could make alterations within the natural regeneration process, which provide them some of the resources that are required. So what traditional knowledge that I could understand here is the people has identified those specific ecosystem components which are providing the required services to the society there, and then has been trying to assist to maximize that service. So this is where the ecological knowledge has been transmitted from one generation to the other generations. And people has been looking in terms of not restoring in terms of the structural. Then when we looked in terms of the converting that knowledge into the literature, I have seen a lot of students like me has been actually mistaken this knowledge into the structural element. I have associated that knowledge into the individual species and started looking in terms of that species is more important rather than that function. And thus, all the literature in the restoration ecology I have seen predominantly focusing on bringing back the species rather than bringing back the function that is required. And this is where the traditional societies and the modern concept of restoration has differed in the earlier discourse. Later on, it has been looked upon, the traditional societies has been looking in terms of either actively planting the service providers or providing the activities that could reduce the pressure on such elements which is providing these services. So these are the two pathways through which the traditional societies has been making adjustment, and entire knowledge in terms of ecosystem restoration could be looked in terms of when to provide active inputs to enhance the densities of a specific organism which could provide them the services, or could reduce the pressures that are reducing the densities or the functional attributes of a species. And thus, I could say that predominantly the traditional ecological knowledge in the restoration could be considered as adaptive management by the traditional societies to get the functional stability that is required for the societies to draw the ecosystem services that are required. I will stop here, and if required, I will answer additional questions.
Thank you, Dr. Rao. It's wonderful to hear such a open and admission that we hardly have any traditional knowledge that can be now spoken about as tested and applicable to the field. Very nice. That's exactly what my initial comments were. And perhaps we need to now be very objective in this sense so that we don't go on building a literature that has no strength in it.
Yes.
Perhaps we need to now evaluate each of these cases that we think there is traditional knowledge abundant enough for us to now apply. Thank you very much. We'll perhaps take the discussion on each of these issues and also all together towards the end. Hopefully, if we can now save some time. So I would now request Mrs. Meenakshi Negi to take over the stage. And Madam, can you now kindly bend your screen slightly down so that we can see your face? Oh, that's great. Yeah. Yes, that's fine. Yeah, please go ahead, Madam. Welcome.
So I think I'll remove this. Thank you very much, Dr. Ganeshaya. And this is indeed a very erudite group, and I think I'm in the wrong group rather. So because Dr. Nautiyal, you can put up my presentation. I've shared it with you.
Madam, we are sharing the screen.
Yeah.
In few seconds, madam.
Yeah. So actually, I don't really have I wasn't given a specific topic like you people were given. I just had the overall theme of this panel discussion: traditional ecological knowledge and sustainable and socio-ecological in contemporary debate, right? Traditional ecological knowledge and socio-ecological sustainability in contemporary debate. So at the outset, I would like to thank everybody, especially Dr. Nautiyal and everyone else, to give me an opportunity to be here today. The next slide, please. So as we know that the most vulnerable to climate change are indigenous people. There is enough literature out there to say that this is a true statement. There are in India, if you see from the Himalayas down to the southernmost tip of the country, you have Bhutias, Lepchas, Gonds, Todas living in remote locations who don't have access to. So, okay, sorry. My topic would be traditional ecological knowledge and health. I am Ayush Commissioner, so I should talk about health, right? So most vulnerable are the indigenous people because they don't have access to many modern day amenities. And one of the most least access that they have is to modern healthcare. And access to healthcare has been recognized, even if you look at the SDGs or even the earlier Millennium Development Goals, access to healthcare has been recognized as one of the main strategies to free people from extreme deprivation. That is the statement of the MDGs. And in India, if you see, there's a shortfall of about 64% doctors in all our community centers. That means at the local level where people actually go and get treated. I'm not talking of tertiary care centers. This is at the grassroots level. So with that kind of shortage, and as you all know, on many health indicators, we are barely above sub-Saharan Africa. Plus, now look at the problem we have in India. Ours is a society in transition. We have islands of affluence in a sea of poverty. That's how I'd like to put it. And so we have the diseases of the affluent as well as the diseases of the poor. So we have lifestyle related disorders, which are a byproduct of our modern lifestyles. And we continue to have the burden of communicable diseases, be it malaria, typhoid, dengue, whatever it is. So what do we need in order to tackle this kind of dual burden of disease? We cannot have a single system of healthcare. Next slide, please. So we need a pluralistic approach. So what is that pluralistic approach? What should we, how is TEK, where does TEK come into the picture? So we have a hoary history of traditional medicine, more than 3,000 years old. Now what is required is, as Dr. Ganesha said in his opening statements, what is really required is a model where we can have a marriage between science and traditional knowledge. It need not, seem to be at opposing poles. Scientists say one thing and traditional knowledge holders say one thing. That shouldn't happen. There are umpteen examples of how various molecules have been derived from TK, whether it's Taxol from the Bhutias, whether it is artemisinin in China, where you very well know, I think it was Dr. Yu Tu who got the Nobel Prize for artemisinin. Reserpine, which is our own Sarpagandha, from our own Sarpagandha, reserpine has been has been isolated. Now, of course, you may say that this is all TK. Where is TEK in this, right? This is all traditional knowledge. What about ecological traditional knowledge? Now we'll see that there are several authors who have written on how communities interact with the environment and then that interaction of the community and the environment directs the biodiversity landscape of that area. Several people have written. Next, please. So if you look at the alkaloids which have been identified from various plants, if you take the example of Sarpagandha, it was isolated in 1952, right? And it was used in treatment of insanity and in schizophrenia and all these things. However, it was found to have several side effects. But in Ayurveda, it is still used. The difference is that there the alkaloid in its pure sense was being used in isolated form was used by modern scientists. Ayurveda, it is the whole root which is being used, and it continues to be used. The modern scientists discarded the use because it had several side effects, whereas in Ayurveda, very good continues to be used. So what is it that we are missing? What are the scientists missing, and what is it that the traditional are unable to explain? That paradigm, that entire, as you said, the model has to be there, where the traditional ecological knowledge as to where the herb is grown, how it is grown, what time it has to be harvested, when it has to be harvested. So that knowledge exists, but it is not getting mainstreamed into our modern scientific discourse. So that is one point which you can, that is the Indian plant, we grow it, we use it, but we are having this difficulty in integrating it into modern medicine. Similarly, the artemisinin. Artemisinin, Dr. Yu Tu from China, she got her Nobel Prize in 2015, but she had started working on it in the early 60s. And since then it happened. Luckily, she was a traditional Chinese medicine specialist. So what she did was, they also there was that artemisinin was having some side effects. It was not really having the effect it should have had. She went back into the text, went back into folklore. She went back, spoke to people, and realized that there are some things which they were doing wrong. Example, they were the method of extraction of the alkaloid was really wrong. Traditional Chinese, actually, the extraction is not by heating. Even in Ayurveda, most of the extraction is by heating. But in this particular case, the folklore had it that it has to be by heating, but by cold process. That was the difference. And after she realized that, after extensive literature learning and trial and error, she found that this is the method. So the point I'm trying to make is that right in the beginning, if the early 60s this marriage had happened, she would not have had to wait for a Nobel till 2060. Plus, the world would have got a much better, more efficacious anti-malarial drug much earlier. So this is where knowledge. I think I'll stop. Although I have many other slides, time is not. I don't have the time. I think there are many other speakers. So just to answer that question, as to there is one point that I will make, that in many traditional communities we have the system of you pluck this particular flower on the full moon night of Ashada, right? That is traditional ecological knowledge. We tend to say that, this is rubbish. This can't possibly be true. If the plant is efficacious, it probably will be efficacious all year round. But that traditional ecological knowledge we fail to appreciate. So what happens when you identify that plant, isolate something? There are umpteen examples. Curcumin. Curcumin, these days, we are in danger of losing the generic term haldi to the term curcumin. Everybody recognizes haldi by curcumin. That is not true. Haldi has so many, turmeric has so many other alkaloids, which now the modern scientists are realizing. Traditional knowledge is that it should be used as a whole herb, not as purified extracts. So these are several examples where traditional knowledge, and particularly traditional ecological knowledge, of the fact that where it is grown, how it is grown, what has to be harvested, the time of harvest, the mode of extraction, all this is nothing but part of the ecological knowledge. But as Dr. Ganesha said right in the beginning, we need to develop models where these two can be married. And I'm glad to share with this community that we have lots of modern scientists who are looking at these traditional practices and traditional way of growing the herbs and then using them. So I won't really go into the rest of the slides, Dr. Nautiyal. I know that everybody is constrained for time. Maybe during discussion, if anybody has questions, we can take them. Providing me this opportunity.
Thank you, Ms. Meenakshi Negi. It was wonderful. I think she made a very pertinent point that while there is no dearth of examples of the traditional knowledge on the medicines, But the traditional ecological knowledge that will be useful for sustainable harvesting and use of medicinal plants is perhaps there not tested. That is a very precise point she made. And we all know that there has been number of these, elements in the Ayurvedic system or traditional health system that you have to grow the plants in some soil and some period. You have to harvest specific parts of the plants during a specific period of the time. These are the elements that perhaps one needs to pick up and test in case those elements of ecological issues are indeed correct or objectively right in way of evaluating the traditional knowledge. Thank you very much, madam. That's a wonderful point you made. I will now invite Maikuri to take over the stage. Dr. Maikuri, nice to see you here. I've been following your work a lot through Current Science and a lot of other publications. Welcome.
Thank you, sir. So, respected chair of the session, I'm very thankful to the organizers for giving me opportunity to participate in this international workshop. The title of my presentation, that is Traditional Ecological Knowledge and Agro-Biodiversity in Resilience Building in Indian Himalayan Region. Next, yeah. So many features of traditional ecological knowledge, which in fact subset of traditional knowledge system, are well accepted by the scientists in the field of agriculture, architecture, climate change adaptation, disaster risk reduction, traditional healthcare system, forecasting of weather, forestry, irrigation, soil and water conservation. Next slide, please. Yeah. Can you skip this slide? Hello, next. Yeah. The type of traditional knowledge in agroecosystem and traditional knowledge about resilience properties, farming practices, wild crop relatives, plant breeding, seed selection, and climate forecasting. So when we talk about the resilience properties, the traditional farmers often live in marginal land where climate change impact and selection pressures are greater. This enables them to identify resilient crops, species, and varieties for adaptation in different agroclimatic zone of the region, as well as in the different agricultural sector of the region. Now, farming practices, as we know that in the Indian Himalayan region, if we talk right from the J&K to Northeast Arunachal Pradesh, we have diverse agriculture sector system where the farmers, they grow variety of crops or traditional crops, and that ranges from 40 or 50 or sometimes it goes up to 100 species, including the wild relatives of the crops. Then wild crop relatives, as we see in the Indian Himalayan region, we have about 349 wild crop relatives in the Indian Himalayan region. And when we talk about the plant breeding, the traditional farmers, particularly women, they are considered as a custodian of the traditional seed bank. And the women conserving local land dishes and selecting seeds of preferred and adaptive traits over generation. Then climate forecasting, that traditional knowledge can help forecast local weather and provide accessible information to farmers at local level. Next one, please. Yeah. Then we have a lot of best example of the traditional ecological knowledge, and that help in building resilience in the farming system. So when we see the Apatani rice cum fish cultivation, that is an unique example and the best practice in the Arunachal Pradesh in Zero Hapoli. The very high economic and energy efficiencies of the Apatani rice cum fish system is due to optimal use of space by growing appropriate rice varieties, and that was supplemented with the lesser known crops, that is the Irusine Coracana, or that is underutilized, that is cultivated on elevated bands between the rice plot. And this system of agriculture is considered one of the highly ecologically and economically efficient agriculture system in the Southeast Asian country. Then we have traditional system of Baranaja, that is very important agriculture system being practiced by the traditional farmers of the central Himalaya in Uttarakhand. where they grow about more than 12 crops together, which include cereals, millets, pseudo-cereals, pulses, condiments, and few vegetables. And in the past, when the regional subsistence economy was self-sustaining, the practice of Baranaja that catered to the diverse nutraceutical needs of the household, that provide insurance against absolute crop failures due to pest attacks or other natural hazards, higher productivity per unit area under marginal land holding, and also to capitalize upon the environmental heterogeneity. But over a period of time, what we have seen that this system of cultivation that is gradually declining from the region because of the variety of region, and the policy is also behind this government policy. Next one, please. Now, if we see the benefit of the Baranaja system, I will not read all these points, but the crops which are grown in that system, they are the organic food, and most of these crops are the climate resilient as we consider now, and majority of these crops, they possess the medicinal properties. Next one. And adaptation with traditional knowledge and innovation. The farmers of this region, we have done a small study across an elevation gradient between 300 to 3,000 meter in the central Himalaya, where the farmers, they have gone for adapting with traditional knowledge and innovation to meet the climate change impact. They have gone for integration of turmeric, colocasia, and ginger under traditional agroforestry system. Where they do not find the water in irrigated system, they have converted the agricultural land into the rain-fed agriculture. Then they replace the buckwheat by kidney bean in the high altitude areas, and even in the high altitude areas, the farmers, they have switched towards the off-season vegetable cultivation and medicinal plant cultivation under protected condition. Next one. And this is the farmer perception, how they select the crop varieties depending upon the water resources or the rainfall. When there is no rainfall, where there is less rainfall, and there is normal weather, then they go accordingly planting these traditional rice varieties under rain-fed condition in the central Himalayan region. Next one. And these are the crops grown in the mountains. They are now, the scientists, they are talking about an option for climate resilient crops. Next. And these crops are the Panicum millesium, Echinoclea fromentosa, Erusine coracana, Setaria italica, Sorghum vulgare, Sesame indicum, Glycine species, Macrotyloma, and so many other crops, they are there. Next one. Now, when we see the system, and recently the COVID-19, the traditional communities across the Indian Himalayan region that play a unique role in sustainably managing a significant share of the biodiversity in diverse agro-ecosystem, and also safeguarding nature is fundamental part of their culture and tradition. And this demonstrates that how the traditional knowledge of the local communities about agro-biodiversity based food system, because they have the traditional varieties and they are having rich in the nutraceutical potential, rich in nutrition, and they have the medicinal properties. And these agrobiodiversity based food system can be useful to support integrated solution to increase immunity to fight against any kind of disease in future like COVID-19 pandemic. Now, the food and nutritional security of the Himalayan communities depends heavily on climate sensitive sector that includes agriculture, livestock, forestry, and their linkages and interdependencies with each other. And the impact of climate change has the potential to break down the socio-ecological and socio-economic development as well as the livelihood system linked to all these sectors in the Himalayan region. And therefore, strengthening institutional cooperation, coordination, collaboration, and capacity building to address the climate change issues and impact in various sectors is the need of hour. Thank you.
Thank you, Dr. Maikuri. I am sure we all agree that there are a number of traditional practices that are well known to be followed in agriculture. But I think to now recognize that the practices may not be now need to be listed as traditional ecological knowledge. Maybe we need to be very careful about now dissecting out the ecological knowledge elements and test them out. I'll give one example, for instance. In the dry areas of Karnataka, especially in the southern part, there was a practice of, sprinkling curds and jaggery on the bunds of the crops, especially when this dolichos comes to fruiting and flowering and fruiting. Now, there was this belief that this sprinkling or the spraying of the curds and gore or the sugar, is actually to now attract the ants, so that these ants go and eat on the pests that would attack the plants. This is a traditional ecological belief. Now, is this really an applicable knowledge? There was a scientist in our university who tested it. He maintained some controls and he sprayed some areas with this jaggery and curds, and he did find that it does attract ants, and they actually reduce the infestation by around 25 to 30%. This kind of tested knowledge is what we need to now extract out of so many arena or gamut of knowledge elements that we can now list on. So I think we also need to separate out the traditional practices of cultivation from the traditional ecological knowledge that can be actually employed in agriculture. For instance, you made a point that Apatani rice system, where rice is grown with the fish, is a fantastic system. But is there a test of it? Are there any alternatives of this? Perhaps these are the elements that as scientists we need to perhaps now put to test and see if indeed there are alternatives, and this in fact is the best practice. They could be the best practices, but in terms of knowledge system, we need to dissect out these things. Thank you very much for that.
Thank you, sir.
Yeah, we will now move on to the next speaker. Dr. Raval, Director of the Himalayan Institute. Raval, I have also been following your work for a long time. Welcome and nice to see you here. Please take over the...
Thank you very much, sir. And I appreciate that you are following us and you know something what we are doing. And at the outset, let me thank the organizers for inviting me for this very important discussion. And I also greet all the fellow panelists, Dr. Rao, Dr. Negi, Dr. Mekuri, and Dr. Subhash Chandra. It has been a very interesting session till now, and I don't know whether I will make a justice with the debate which is there in this panel. I have been given the topic participatory conservation and livelihood development. This is the topic which was given to me and agreed by me to speak in this session. And participatory conservation, in my opinion, it is a buzzword. And in last 3-4 decades, there has been so many interactions, debates, deliberations that participatory conservation should be promoted across the world, and also the other part, the livelihood development, it is very much there. But within the gamut of today's subject, which revolves around traditional ecological knowledge, socio-economic sustainability, I was wondering as to how I will fit in these two words or these two aspects in the debate. Then I thought I will discuss 2 or 3 such examples wherein both these two things are integrated, or both conservation and livelihoods are associated rather. The debate which the earlier panelists have brought in, it is with respect to traditional knowledge, practices, and confusion is still there as to how we will move with these words. But let me take these two examples and try to little bit make a justice that traditional knowledge, even and practice, both these things may go together also, and we will have to see deeply in the value of both. Say, for example, let me take example of the agriculture, wherein Dr. McCreary was focusing on the traditional agriculture. Traditional agriculture in the Himalayan region, I will again go to Himalaya because I belong to that region and I have worked in that region and I have understanding of that region only. So I will take the example of Himalayan agriculture, traditional agriculture. Traditional agriculture, everybody of us agree that it has contributed for the conservation of genetic diversity. And if you see very deeply in the fields of these traditional farmers, these genetic diversity or this genetic diversity is conserved through their knowledge base. You would find if you will go to the paddy fields of traditional farmers, you would find they cultivate a specific land race in a specific field. They have defined that field or understood the value of that field or that small piece of land for that particular variety. You would find that the distribution of paddy along the altitudinal range, it is different. Genetic races or this genetic diversity, you would not find uniformity in the diversity. So that way, over the years, maybe through their practices only, they have gained that knowledge or understanding where a particular variety or genetic resource will grow or survive. So that way, I believe that understanding of the traditional communities in the region has contributed towards the conservation of this genetic diversity. And unfortunately, we have never appreciated this understanding or this knowledge of the people. As a result, we are losing this genetic diversity without knowing that what we have lost. So that way, we need to have that appreciation if we wish to conserve or retain that genetic diversity in the region. And I believe in the context of global interest, because conservation of genetic diversity is not the interest of that farmer, it is the interest of the world. In that context, we need to appreciate that understanding or that knowledge base of the farmer, and then perhaps we will have to go for the incentive-based mechanism. Otherwise, that farmer is not interested to maintain that genetic diversity in the field because he is losing against while he is putting efforts to maintain that genetic diversity in his or her cropland. He is losing on the other hand, while there are so many fast high-yielding varieties available. So the question is why, even if he or she has that understanding or knowledge, why he or she should go with that knowledge or protects that genetic resource through his or her knowledge or practice. So that way, the other part which was associated with my deliberation is the putting conservation with the livelihood development. I believe this understanding or whatever knowledge base and practices are available with the traditional society, traditional communities, if we appreciate this and we put some incentive-based mechanism or in situ conservation of these resources, perhaps we can make a justice with the livelihood of that farmer or the farming community who are putting efforts for conservation of this genetic resource. So this is one example of Himalayan agriculture wherein I think the knowledge is existing or ecological knowledge is available and which is tested through the practices. And unfortunately, we can't take it forward because it is not remunerative in the sense of production, or it is not that much commercial. So that way, it is not being further improved or further practiced. But the point here is whether we need to retain that knowledge, and through that knowledge, we want to conserve that genetic diversity or not. So this is one point where I think we need to think over. And the other example I again draw from the region, it is with respect to the forest conservation. You all know that the Uttarakhand in this western part of Himalaya, there is a strong tradition of community forests. It is more than 100-year old tradition or practice, whatever you say. But we can't say that it is just a practice. If you see deeply in the distribution of these Ban Panchayats or community forests, you would find they have been identified by communities, not just for their needs. Sometimes they have been identified for protection of diversity of the forest resources also. Meaning that in some cases, these Ban Panchayats have been identified just to meet their fodder or fuel needs. But in many cases, these forest panchayats have been identified or managed to keep diversity of forest resources surrounding their hamlets. So without knowing that what was the reason for putting efforts for management of these resources, we can't say that it is just a practice that they have carried it for centuries or for decades. And that is basically to meet their sustenance requirements. Rather, I would say we need to analyze that particular practice or that particular understanding of the communities for protection or for management of these resources, and the context, ecological context, which may not be their interest that time, but the ecological context of that particular management system. Now, if I put that in the other side, wherein I was supposed to speak.
Dr. Raval, I think we may have to close now because we are running out of time. Yeah.
Okay, then I think this is what I wanted to convey. And both the systems have contributed for the livelihood development of the people or communities in the region. And also, there is a very significant, I would say, contribution of these systems for the conservation of the biological resources or biodiversity in the region. And we need to appreciate that the value of these systems has come through the knowledge base or understanding of people who have maintained this diversity. Thank you very much.
Thank you, Dr. Raval. Thank you. I think Dr. Raval made a very important point, and I'll come to that maybe towards the end of this talk when I link it up with what Dr. Rao told. I now have the pleasure of inviting my good old friend, Dr. Subhash Chandran, who is also known as the ecological historian of Western Ghats. Dr. Subhash, nice to see you here after a long time. I mean, it's nice to see that all of us have swam through the COVID, and I'm very happy to see you in the same health condition. Welcome and take over the stage, please. You have to unmute your mic. Dr. Subhash, you have to unmute your mic. Dr. Subhash is in the window which is labeled as Gayatri Nayak. Subhash, unmute your mic. No, we can't hear you. We can't hear you, Dr. Subhash. No, not yet. You have anyone to help you out there? You have now muted again. You have to unmute and use your computer audio system.
Yeah.
Yes. Now you go ahead. Yeah.
Yeah. Hello.
Yes, we can hear you now. Go ahead.
Hello. Hello. I will try another. Yeah, just a minute. Just a minute, sir. Yeah, 9996. Okay, right. Yeah.
Capital 0P.
Yeah, 0 PY B small d capital C. Small d capital PYB small d capital C. Yeah. So. Not coming. Sir, one can see. 1 minute is going on. Just a minute. Yeah. Can talk. Hello.
Yeah.
Is it okay now? Just. Is it fine, sir?
Yeah, we can hear you now. You are on 2 screens though. But we can hear you now.
Okay. Okay. Very sorry for the technical problem faced. We sit in a far off small town, and so in the first place, I wish to say that I have requested for a small change in the topic. The topic that was given to me was biodiversity regulations and ABS, access and benefit sharing. I thought that my talk will be infructuous on that particular topic in the current scenario in India, especially without clarification on the farm bills and which are becoming farm ordinances. So therefore, I changed the topic to India's farm bills and impact on biodiversity, likely impact on biodiversity. India's farm bill and impact on biodiversity. Because it has much to do with ABS. So, hello?
Yeah, you have 5 minutes. Go ahead.
India is one of the major centers of crop diversity, one of the 8 centers of Vavilov Center of Crop Genetic Diversity. So we have lots of cereals, legumes, vegetables, fruits, sugar, oil, coconut, cotton, spices, all that. So it's a global set of cultivated biodiversity. And if you take a rice, for example, we had probably more than 1 lakh varieties or farmers, varieties of rices. Out of them, since the launch of the Green Revolution, there has been a acknowledged decline, and the decline is variously placed as to 10 to 15,000 varieties, or even less, some say 7,000 in rice. And similar thing has happened in various other crops. And in the light of that emerges the Biodiversity Act 2000. And so the Act acknowledges India as a rich center of biodiversity. And so our country has sovereign rights on bioresources, and moreover, in party to the conservation, the Rio, Rio Conference on the conservation of biodiversity. And so now the Biodiversity Act 2002 came to protect all these immense amount of biodiversity, including farm diversity, which is bulk of it maybe persisting, but maybe unknown or maybe documented already. So government has taken the major responsibility of documenting biodiversity all over the nation. It is a very mammoth exercise, and I am part of it. I am coordinating the whole Uttar Kannada district with 10 taluks in the all biodiversity reports we are being made. At this time comes the farm bills. Now, the Act says biodiversity and additional knowledge cannot be obtained for commercial utilization without taking due permission and sharing of benefits with the local communities. So now the elaborate formats are there. There are 25 formats in the biodiversity register, in the People's Biodiversity Register, and many of them are so elaborate, and much of them, many are pertaining to the farm diversity, including the domesticated animal diversity. Now, so lakhs of People's Biodiversity registers are already being prepared. Now, how the farm bills are likely to impact conservation of biodiversity, and then only our application of the access and benefit sharing comes first. So National Agricultural Policy of India in 2000 itself aimed at certain level of private sector participation in agriculture. As a result, emerged what we call the contract farming. So, and even the bank like NABARD promotes contract farming, and with contract farming, many players emerged into the scene of agro products and including medicinal plants production, like that. Now, to notably few like Hindustan Liver, KRBL, then Pepsi Company, horticulture management groups, and various companies have emerged this sector. And in the contract, this service provider provides seeds, technology, farm input, and purchase the product at a pre-agreed price. So, if you
Subhash, I
examine,
think you may have to move ahead and
yeah.
Significant
If you
statement.
examine,
Yeah.
sorry, I missed some time. If you examine, we find that the Ayurvedic companies are doing much better service in the contract farming because they are conserving the traditional biodiversity of India, especially of medicinal plants like Dabur, Himalaya, Patanjali, Swami Labs. They have got agreement with farmers, or they have their own cultivation areas, so that more wild diversity is conserved in the country. Now, if we look at the farm bills have three players. One is the main sponsor, and second is the aggregator, maybe a farmers group, and third is the farmer. Now, in the farm bill, there are two notable bills: Farmers Produce and Trade and Commerce, and second is Farmers Empowerment Protection and Agreement on Price Assurance. So both the bills benefit farmers in economic terms. So they are more guaranteed that by natural calamities or other things, they are not, or by market crash, they are not going to lose everything. There are sponsors who give them some guarantee, and the sponsors provide seed, feed, agrochemicals, technology, all that. Now,
Dr. Subhash, I think it's a very, very big topic. I'm afraid we may not have too much time to discuss those details here. I'm sorry,
Yeah, I will take 3 minutes.
Okay.
And so there is a huge erosion, genetic erosion of crops with the contract farming. For example, we find that Pepsi company is mainly concentrating on potato growing in thousands of acres, and that too the seed is provided by them. Similarly, the rice contract, the sponsoring companies are mainly concentrating, bulk of concentration is on Basmati and few other varieties. Where are our 1,000 varieties which we are painfully documenting, and the small farmers are likely to enter into big relation with these sponsors and give away their traditional crops to grow the commercial crops in all fields, whether chilies or coconut or Garcinia, anything. So therefore, the Biodiversity Act is totally silent on this. The Ministry of Environment and Forests also has not intervened in modifying the farm bills so as to incorporate biodiversity conservation. I make lastly one suggestion that the sponsor companies which enter into the arena of tie-up with farmers and guaranteeing the farm production, there will be a flush of these new players because of opening of state borders and going beyond the PMC Act and all that. The big market is emerging, so there will be much more big players who will be fully commercializing agriculture and horticulture, and in the process, what we are going to lose in terms of agrobiodiversity, and the biodiversity boards or the National Biodiversity Authority, they are just witnessing and will be mute witness to catastrophic impact coming in few years on Indian agrobiology. Thank you, sir.
Thank you, Dr. Subhash. Sorry to now have you up, and I also understand that you had a technical problem. But I would suggest that you may want to now make a case for what you have been talking about by writing an article to Current Science. We will see the possibility of considering it. Perhaps there's a need for bringing the Biodiversity Act bill and the Farm Bill vis-a-vis face to face. and see the consequences to each other, maybe you should now think of writing an article. I would be happy to now proceed.
I am doing that.
Thank you very much.
You
So
always start.
that brings us
Thank
to
you so
the end of all the panelists' points of view on this topic of traditional ecological knowledge and socio-ecological sustainability. I thank, first of all the speakers, wonderfully done. And all of you have made very significant points. I would like to now summarize just in 3 sentences, all of them. K.S. Rao began agreeing with me that we need to be now careful about accepting what we mean by traditional knowledge. He also agreed with me that there is a lot spoken about traditional knowledge or traditional ecological knowledge, but not strictly documentable as objectively tested traditional ecological knowledge. This is also further extended by Madam Negi, who also agreed with us that yes, there is a lot of health knowledge, traditional health knowledge, but the ecological knowledge to harvest the health system need to be tested. And she made 2 significant examples to press this point. In other words, it appears that the outcome of this discussion seems to be that we still are not at a point where we can have a good model of documenting the traditional ecological knowledge, testing it and applying it to the field for ecological and sustainable management of the forests and biodiversity and ecosystems. This seems a very disappointing thing because though we have been speaking a lot about TDK, traditional knowledge, traditional ecological knowledge seems to be just emerging now, and there is a need for objective or scientific approach to harvest, dissect out, and use this traditional ecological knowledge. I'm sure all of you would agree with that. And then we had another interesting point made by Maikuri, that the practices that we follow and the traditional ecological knowledge that we adopt or we perhaps can harvest need to be separated. We should not mix traditional practices with ecological knowledge because agriculture itself is traditional. We have been following agriculture. So we can't say that agriculture is traditional knowledge or farmers knew about agriculture. The entire humankind knew about agriculture. But what is the ecological knowledge that we can harvest out of these practices that we are following? That needs to be perhaps taken further discussion. And then there was another point made by Raval, who suggested that the genetic resources, which happens to be traditional material resource, need to be separated out from traditional material resources have been conserved by the farmers and by the humankind, which need to be appreciated. But does that serve as ecological knowledge? Hopefully not. And so if you are now concentrating and focusing on the present theme of traditional ecological knowledge, it appears we are at a very infant stage, whether it is agriculture, whether it is biodiversity, whether ecosystems or health system or any field that we are now thinking of, it appears there is a lot to be done for traditional ecological knowledge. So with this, I think we will close this session. Thank you very much for your participation. It appears that we have come to understand that we are just started to understand these areas of traditional ecological knowledge in the health. Thank you very much. Thank you all. And Dr. Nautiyal, thank you for giving us this opportunity, and you can take over the stage. Dr. Nautiyal and Rajshekhar.
Thank you so very much, sir. Before I request Rajshekhar to close the session, on behalf of the Institute for Social and Economic Change, on behalf of the National Institute of Disaster Management, Ministry of Home Affairs, Government of India, we extend our sincere thanks to our respected chair of the session, Professor K.N. Ganesiya ji, distinguished panelist, Professor K.S. Rao sir, Ms. Meenakshi Negi, Commissioner Ayush, Professor R.K. Mekhuri, Dr. R.S. Raval, and Professor M.D. Subhash Chandran. Sir, I would like to mention one point here, that we have gained so much from this sessions today. You have given so many thoughts. All of you have given so many thoughts, so much knowledge to us, and also straightforward have given the ideas to us where to conduct the research, where are the gaps. You see, such kind of interesting knowledge, thought-provoking ideas you have given to us We are deeply thankful to you all. Sir, I'm really sorry that we are not so kind to you. You have given so much to us, but we are not so kind to you that we are not reciprocating anything to you. Even we could not offer a cup of tea to you. Rather, we took your time for lunch from your lunch, and we did not allow to have your lunch on time today. We really thank, and please don't consider that we are unkind to you. But that what we can respect from our teacher. We can expect and request our teachers to provide us in any kind of situation which has emerged today, because we could accommodate this session only during this time. Thank you so very much. And now I request Professor Rajsekharan to please.
Just a half a minute. I just want to express my thanks to the organizers and also express my respects to Professor Nadakarni, who was felicitated during this conference. Perhaps he might be listening to me, but I would appreciate if the organizers could communicate my respects to Professor Nadakarni.
Thank you so very much. Professor Nadkarni is attending this session. Yesterday, he asked me that what time this session is going to be started, where Professor Ganasaya is chairing session. Professor Rao and team, they are presenting their expert views. And he was waiting for you all. He joined the session exactly at 12:30. So he is there with us. He listened to you already, and I also communicate your greetings and your congratulations to him. Thank you so very much. And Professor Rajsekharan, now you please take over and thank our respected chair and panelists.
Yes, sir. Thank you, Professor Mutral, Honorable Chair Ganesaya, then our speakers, speakers of the panelists of this session. Everyone has given, it's a brainstorming session for us to have the updated information about our traditional ecological knowledge and the socio-economical sustainability and contemporary issues. It's really need of the hour to focus on this in our future research. That is what required. All our speakers are justified with their input in this particular session. This will be really useful for our young researchers to proceed on this area to strengthen and develop our traditional ecological knowledge systems. With this word, I would like to conclude this session and thankful to our chair as well as our panelists for providing an invaluable input on this particular session. Thank you very much.
Thank you so much. Namaste. Thank you so much. Now sir, I'm really sorry again. Today you too much trouble to my sir, Professor K.S. Rao, my teacher. Sir, now we are requesting you to chair the session, and I don't know how to begin with this. You didn't have your lunch, and we are requesting you to directly go.
No problem. I'm ready already. No issue.
Okay.
Go ahead.
Sir, now I request you to kindly chair the session. This session is organized for our invited speakers, and the theme of the session is agriculture and water. Sir, we have the scholars from Manchester Metropolitan University, Dr. Liang Su Han. Sir, you know her very well, and she knows you also very well. And Dr. Pradyot Ranjan Jaina from NIIT Surathkal, Dr. Barun Depal, Dr. Sandeep Kaur, Professor Girisan from Rajiv Gandhi National Institute of Youth Development, Professor Susai Raj from Sacred Heart College, Tirupattur, and Dr. Sunil Mysore. Sir, I request you to kindly take over and let me introduce the chair to the speakers of this session. Professor K.S. Rao is.
They already heard about me. Don't elaborate.
Okay, thank you, sir. Thank you so very much. Sir, Professor Nainan is also attending the session, and he was there with you during your panel discussion also.
Yeah.
And
Thank
Professor
you very much,
Nainan
sir.
has lots of respect for you, sir.
Thank you very much, sir.
I request you to kindly conduct the proceeding.
Okay, if Professor Han is here, let us start with it. I will reserve my comments to the end because this is an interesting session where the agriculture and water, which is a important connotation where the societies are dependent upon. Both water is also important for the society and agriculture is providing the required resources. I invite Professor Han.
Thank you. So I'm trying to sharing my slides. I'm not very sure. Just a second.
Yeah, they are visible.
Okay, thank you. So thanks very much for chairing the Professor Rao chairing this session, and also thanks very much for Professor Sanil inviting me to this session. It's really my pleasure. So my name is Liang Xiuhan. I'm from Manchester Metropolitan University. I'm a computing scientist. So basically today I might just talk mainly about how mainly talk about our big data research and then with the application study in the precision agriculture from this perspective. So where we are now, so basically we're located in Manchester and in between London and Edinburgh. It's very handy and convenient. So welcome to here if you have got a chance. And we're Manchester Metropolitan University, so we have very old history, and then we currently have 38,000 students. So this is just for completeness to introduce. So I'm not going to go to the detail about this. So our research, we have a center called Advanced Computational Science. We have data science, big data, machine learning, text mining, machine intelligence. And also we have a smart infrastructure, human-centered computing. So fully a computing scientist, really. We also have a very big data center. The university invested £1 million for developing the novel technologies in big data. And so for our group, which I'm leading, we focus on both fundamental and applied research in big data processing and analytics. Means that with the application domain in health, food, agriculture, energy, smart cities to address societal challenges. So our task mainly is to develop novel big data analytics, machine learning method, AI approach, and also not just developing purely machine learning algorithm, but also to develop intelligent software architecture that can facilitate such big data analytics or machine learning algorithm can run efficiently on the cloud and using on the HPC, high performance computing. So, so here are some work we have done already in the area, for example, precision agriculture, health, energy, smart cities. So we have built the big data infrastructure. So currently, so the mainly goal, we try to build architect big data infrastructure to try to address the societal challenges, to make a society sustainable. We have built already the capacity and the capability to process and analyze different types of large data set, from structured or unstructured data set, such as images, time series, IoT sensors, geospatial temporal data. We have built some data products already. For example, precision agriculture. There are some product already. So basically, smart cities. So why we do this big data research? So I'm just giving you a little bit of background why we do, why this is important.
No, Professor Han, you have to come to your main topic because we have only 10 minutes for each speaker.
Yeah. Okay, so I'm very quick.
You go to the precision agriculture directly.
Yes. Yeah. Okay. Here is a big data. So we say that the big data. Yeah, we look at the big data. So that's why we consider Why? So when we talk about a big data, we consider the technical challenges. So how we actually reduce the big data volume into the small volume. So this is a very our concern, and how we actually create the efficient algorithm to provide the insight or actionable insight to address the challenges. So here is a challenge: how to filter and reduce the amount of data. So our solution will be development of the data analytics, machine learning, AI, and how to process large data efficiently. And then we develop the data processing architectures. So we have applied this big data research into the precision agriculture. Mainly, we have already built the crop disease diagnosis and monitoring tools product. Basically, we develop automatic crop disease diagnosis from various data sources. For example, satellite images, drone images, mobile phone, and IoT sensors. We based on the cloud and mobile computing. So the underlying technologies is big data analytics, image processing, and cloud computing. All these being kindly funded by international and national. Yeah. So why we do this? On one hand, we have a background, we specialize big data, but on the other hand, we want to build the big data to really for societal challenges. This is what we as a use case, our use case. So crop disease, everyone knows that crop disease are a major threat to food security. It is resulting in the negative impact on societies, economies, and the environment. And so early accurate identification of crop disease is crucial to address these challenges, allowing targeted interventions. Currently, the practices in diagnosis and monitoring crop disease are mainly based on farmers' experiences and their individual knowledge. This is time consuming and also subject to bias and error prone, because people, the human farmers go to the field, they just use their naked eye and to look at the whether there is disease. And so this is really not sustainable, especially in the context of climate change. So currently, because the advanced ICT technologies, especially, for example, IoT, smart sensors, you can put into the smart sensors in the field, and also big data. We can collect a huge amount of data. So it is possible to address such challenges through the automating all this process, and so that to create a precision agriculture solution for time critical the decisions. And so we have been collaborating with both internationally and national collaborators, including the industry and academia. We have built a big data platform for crop disease diagnosis monitoring. And here we just want to show the some system architecture. Basically, we have we collect the field data. For example, the field data using IoT sensors, microclimate data, soil humidity, and also we use the satellite data set to extract the soil moisture information, and we also use drone images to fly across field to get the field scale, the crop disease symptoms characteristic. We also use a mobile phone, and we also created on-device mobile phone to actually collect the images from the field. So basically, this is architecture you can see from multiple data sources. We develop data integration mechanism And we also developing the image feature extraction, and develop what we call the scalable deep learning and machine learning algorithm. And then we classify the disease into the whether it is healthy or not healthy, and then we provide disease map. So this big data platform is generic data platform, which is not only for the current project, but also for other projects as well. But certainly we need to adapt, say for example, because data, the analytics algorithm is different. So we develop data integration scheme, data analytics, scalable machine learning, deep learning, and we have also different user interface to the facilitate farmers to use. So here it's just the example. We show how we use the deep learning to analyze hyperspectral images. As you can see, we use deep learning to analyze the hyperspectral images to identify wheat disease. And here is our the tools. For example, GUI, mobile phone. You can see we integrate satellite images to locate where which field there are. For example, field A, B, C, D. Based on satellite images, we can locate where the field is. You can see the field, and then based on this field, and we can identify the wheat disease, whether it is healthy or not healthy, as you can see my diagram here. So yeah, and then based on the field, the images and the drawn images, field scales, and also satellite. And then, as you can see here, we analyzed real-time bacteria. So for example, bacteria blight. Here we show the disease. Those red dot is what we have done. Use deep learning to do the disease mapping. So here, right. So I think, I think here is our selected publication for this what we have done, the technologies we have developed. I think if you have any questions, I'm welcome. You can query any question. I think my time is okay. Yeah. Hello.
Professor Han, thank you very much. We'll take the questions at the end if there is time left. At present, let me thank you for your presentation.
Yeah, thank you.
Okay. May I invite Dr. Pradyot Ranjan Jaina to take the floor. He will be speaking on the climate resilient agriculture.
Good afternoon, everybody. Good afternoon, Professor Rao and others. I would like to thank Professor Nautiyal for giving me this opportunity to be here and speak some of my research. And also thanks to others, those who are here. So let me try to share it. So. Just a second, please.
Yeah, you are visible. Go ahead.
Okay, so now it is visible.
Yeah.
Right, my name is, my name is Pradyot Ranjan Jaina. I'm Associate Professor at National Institute of Technology, NIT, Karnataka. And I'm going to speak an empirical study that we have done recently. So this study has been done in Odisha, some of the districts of Odisha. So what we did is what we wanted to do is to show that, given the context of climate change and weather, extreme weathers happening more frequently, so how farmers are coping with it, what are their plans? It's such a big and broad topic, but I took a very narrow view of it. So we did a survey, actually, household survey in one inland district, that is a non-coastal district and a very high temperature district of Odisha called Balangir. Some of you might be knowing Balangir. And then another coastal district called Kendrapada, which is very much flood prone. So one is the Balangir is drought prone and Kendrapada is flood prone. So we wanted to take, because these are the main extreme events happening with prolonged periods these days and very frequently. So this is a survey basically, and some of the survey results that I'm going to present. I would like to keep it in 10 minutes as was instructed. And what I did in this is that we tried to find out what are the key variables that actually influence the farming households, their decision making, to go for certain practices which has been termed as climate adaptive or climate resilient. So I will come to it. Just to give a background kind of, we all know that the population will be increasing to 9.1 billion by 2050, which is 34% higher than what is today. So business as usual will not be sufficient in terms of food security, because we need, by some estimates, 60% more production by what we have today. And that means that the agriculture production has to go up significantly, right? And the challenges that we have is that mean temperature has been rising. The time series, if we see the time series mean temperature of any region, it's been increasing. And especially for the hotter regions, that's a concern. Rainfall pattern has been changing. Okay, so these are not just these are kind of perceptions from the stakeholders, from the farmers. Okay, so it's from their own perception, their own feeling, their own experience. Okay, so and especially in Odisha, in the coastal part, the floods are happening more frequently. Almost every the cyclone and the resulting kind of flash flood, etc., happening almost every year. Okay, so these effects of climate change have impacts on agriculture and other sectors like forestry and fisheries. So it's not that just agriculture is being affected by climate change, it is also contributing to the greenhouse gases. As we know that agriculture and allied services, allied activities emit the important GHG gases, okay, methane, nitrous oxide, and so on and so forth. So these are the basic challenges, as we all know and agree, and it has probably been talked before me in last 2 days. So given the challenges, the climate smart agriculture, the term which is coined by FAO in 2011, which is basically a bunch of good practices, okay, which basically deals with how to keep the land, the air, and the biodiversity more cleaner and basically in a good condition. So whether these practices be a solution, so we can call it as a silver lining. That means it gives some hope. So how FAO has defined it, that climate smart agriculture has 3 elements. The first one is increasing agricultural productivity sustainably. And second is, adapting and building resilience to climate change. So these are the, adapting some of the practices that can adapt, the farmers can do to adapt to the effects of climate change. And third one is to reduce greenhouse gas emissions. Now, there are, as I said, there are a bunch of practices. There are many, starting from minimum tillage, micro irrigation, rescue drilling, drought and flood tolerant seeds. So there are so many such technologies. Some of them are concerned with seed. Some of them are concerned with, how you nurture and take care of the soil, etc. So all these practices, they do not a single practice does all the 3 objectives, but collectively they can probably achieve all the 3. But it's also important to know which practice is feasible in which region, in which area, because every
Dr.
you
Jaina,
know, if
please
you take
come
up
to your
India,
case study.
yeah.
Please.
So that's keeping that in mind. We did this study, and this is our conceptual framework. This has been done, you know, going through a lot of literature. So these are the possible drivers that affect the decision of farmers in their decision to follow a practice or not. We have considered 4 practices in this study. Okay, those are risk scheduling planting, doing micro irrigation like drip irrigation and sprinkling irrigation, and then drought resistant seeds and crop rotation. So these are the 4 practices that we have considered here. And like I said, 2 districts have been taken, Balangir and Kendrapada. And then we have followed a purposive and a mix of purposive and random sampling to arrive there. So what we got here is that rescheduling planting, which is basically, you know, adjusting the season, adjusting the planting in order to, you know, take advantage of the rain and other things. If it is happening early, then doing it early, and short matured varieties. So those kind of things, crop rotation, and then resistant seeds and micro irrigation. So we saw that most of the farmers that we surveyed know about planting, rescheduling planting and crop rotation. So they have been doing it. More than 60% to 80% of the farmers are doing these 2 practices. Whereas the other 2, that is micro irrigation and drought resistant seeds, a very less percentage of farmers are following it, to the extent of 20% only. What we did here is we did 2 groups, because that is the basic of impact evaluation study. Group of adapters and non-adapters. So this is not a RCT or anything. This is observational. So looking at the responses from the farmers, we divided them into the adapters and non-adapters groups. And what we saw, we distributed, we tried to look at their 3 distributions, that is age, education, and land size. So whether these 3 are kind of have any say on their adoption pattern. So what we saw is that age is not that much of a matter, but for micro irrigation, we saw that relatively younger farmers have adopted it. So the adopters have less mean age than the non-adopters. But for the other 3 practices, we didn't see much difference in terms of age. But coming to education, we saw that this is the number of years of education for the household head. So for the education, the adopters' household heads are higher education on an average for all the practices. So you can see that the mean is higher. These are based on 250 surveyed households. Therefore, the sample size is a little bit on the lower side, although it's not too low, but still, if we increase it, probably we get this difference is a little bigger. And the land size also shows that you can see that those who have done crop rotation, these blue ones, they are the adopters, and the red ones are non-adopters. So the adopters have higher land size. Okay, you can see for all the 4 adoption practices that we have considered, the adopters have a relatively higher land size. Okay,
Dr. Jaina, you have to conclude.
And then,
now.
Yes, this is my last slide, actually, last 2 slides. So we did a probit model, basically. We showed those mean differences, but putting them in a regression, we try to do that. And you can see that what we got here, there are 4 factors that came out highly significant in the regression model. Those are government extension support. It's a binary variable showing whether they have received any kind of extension service. So that is in the last 3 months they have got any visit from the agriculture department officials or not. So that's extension support. And then the subsidies, machinery subsidies. This is a part of Krishi Sinchan Yojana done by government of India. Okay, which provides right now 50% of subsidies for the the irrigation machines, crop advisory, and cooperative credit. So, there is more on the background what these particular schemes are and how it is operated. I'm not going into it, but these 4 factors have come out as highly statistically significant. So, which makes us, conclude that probably constant engagement in terms of extension support, hand-holding, and timely support, monetary support like credit, can probably help in wider acceptability and adoption of some of these practices. Okay, and the other thing that we found out while talking to the farmers is that each, this is also talking to the district level agriculture officers, that in each district the situation is different, the context, the geographical context is different. So therefore, a micro planning at the block level is probably a better idea than having a single planning at the state level and then imposing that on all the districts. So micro planning is more effective. That's what we felt. So
Dr.
with this,
Jena,
I
thank you very
conclude
much.
my presentation.
We don't have much time to discuss on this. It is a very interesting case study, but we'll see if there is time left. At the end, we will try to see if there is a possibility of some discussion on this. May I request Dr.
Thank you so much.
Barundev Pal. He is expected to speak on upscaling climate smart agriculture technologies in India to 2050, a modeling approach.
Thank you, sir. And thank you, Professor Sunil, for inviting me to this wonderful event. So let me share my presentation. So I hope you can see my presentation slides. Sir, can you see my slides?
We are seeing. Thank you, Dr. Barun. We see your slide.
It's not started yet.
So if it is visible to everyone, I may proceed now. So thank you once again to Professor Chair.
Yeah, go on speaking because the presentation is not yet.
Okay. So the topic which I am going to present is called Upscaling Climate Smart Agriculture Technologies in India, a modeling approach. I am Barundev Pal, currently working at International Food Policy Research Institute, and my research is largely focused on the climate change, agriculture, and food security. So before proceed further, I will not take much time, but to just summarize the concept of climate smart agriculture, because my previous speaker has already spoken about it. So basically, the climate smart agriculture, we see it from the perspective of improving adaptive capacity, building resilience, and reducing greenhouse gas emission. And it has several components, be it water smart, maybe water efficient, energy efficient, maybe it's nitrogen efficient, or it can be a crop smart, looking at the diversification of high resilient crop. Then it can be weather smart to have a downscale level of weather forecasting, and then finally it is a carbon smart, which leads to reduction in GHG emission. So with this conceptual background, the 3 big questions, or I would say the basic questions which always bother us as well as to the policymaker. The first question is, what are the economic impact and cost of climate change to the global and Indian agriculture? Number 2, whether this climate smart agriculture can reduce that risk of changing climate and its consequences on agriculture economy. And the third is how effective CSA practices can be scaled up to the national level in India. Maybe all the CSA practices are not effective for a particular country or for a particular agroecological zone, but the practices which are effective, how we can scale up those practices to have more sustainable development for agriculture sector. Now, to answer this question, it's not the job of only an economist like me to answer all these questions. We need help from the scientists. So therefore, at my institution, International Food Policy Research Institute, since 1990s, we have a designated team to work on this issue, and the model which we developed is called International Model on model for analyzing agricultural commodity and trade. It's in a short form, it's called IMPACT. It's a global model taking into consideration 159 countries and 149 water basins. This particular model incorporates 4 different models. That's how we are integrating scientists as well as economists together to answer those basic questions related to climate change and its consequences on agriculture. The first and foremost is climate models. All these 4 climate models we have taken into account in this model, and the results which we analyze the average of all this model. And the RCP which we consider here is 8.5. Although for Indian studies, also even government of India is focusing more on 6.5 or 4.5. But what our say here is that let us take that extreme scenario. If we survive in the extreme, then there is a chance that we can survive in the lower extreme scenario. Then we have another set of module called water module that integrates 3 set of model. One is hydrology, another water system, another is stress. Hydrology model will give you how much water is available there and how much water is actually supply. Then the second one is takes into account socioeconomic drivers to see what will be your future demand supply scenario for the model, like the industrial process, domestic water use, and how much water is left for agriculture to use. Although agriculture is the highest consumer of the water, but the continuous development process will put pressure on water use by the agriculture sector. And the final one is stress. Will say that will allocate the available water for agriculture across different crops. Basically, that gives us the irrigation water allocation across different crops. Then we use that crop water data into the crop model that is, is under the platform of DSAT model. So with that input, we project for the crop yield under different climate scenario. And finally, whatever technology you do, whatever climate scenario you observe, you have to come to the market to sell it off and to get the money or to get the income to the farm. So therefore, as an economist, our work comes here to deal with the market and see whether the farmers gets the benefit as well as the consumer gets its benefit by consuming the crop as well as by selling of the crop. And in sum, the social welfare is maximized. So the structure which I explained can be seen through a schematic structure like this. We have few drivers which are causing to the limiting of valuable resources like water, energy, and others, in fact land, and that is causing to the crop production or crop supply scenario changes. And then finally, there is another socioeconomic driver which is leading to the demand changes in the household sector. So I'm not going to tell about much detail about the engineering behind this modeling. So let me take directly to the results which we get from the model. So in this particular slide, I'm comparing 2 sets of results. One is what will be the impact of crop yield for the selected crop at the world average level as well as the India level. And these results are average of all these 5 climate models. So if you see in case of India, the rice yield is by 2050, if there is no climate change and the climate change impact happened, there will be huge loss. So if you look at the yield index, it reaches around 1.10 if there is a climate change impact. But if there is no climate change, it would have been around 1.25. So that means it's around 17-18% fall in productivity that yield which we could achieve in 2050 if there is no climate change. But due to climate change impact, without any adaptation measures, there will be severe loss into the rice yield. And this yield is much bigger than what we see in the average yield loss in the world level. In other words, the yield loss in rice is very high than the yield loss we observe in case of wheat. But maize and sugarcane observe severe decline in the crop yield in the future if we don't take any adaptation measures. Now, since there will be a fall in overall supply, but population is rising and food demand will rise, so there is a chance, or it is sure that the world price will also increase. So for all almost all the crops we see there is a rise in trend of the prices. Now, what will happen if that happens, that there is a fall in supply and rise in prices? So immediately there will be fall in per capita demand. That if you take as an indicator of your food security, if we see per capita kilocalorie consumption per day for every Indian will fall by around 2.7% by 2050 if we do not take any intervention in terms of either be it climate smart agriculture or be it any other intervention, which is at par with the world because India itself is the second largest populous country and consume a bigger share of the food. Now, projected impact on the trade. I'm not going to tell you each and every cells, but in sum, this table says that there will be around 20 million metric ton more import that we projected in 2030, and that will increase to 43 million in 2050. So that means what I am explaining here is that in the first row, all food crops in 2010, which was our base year of the analysis, there is a net importer, although from 31 million tons, and it will increase to 160 by 2030 if there is no climate change. But if there is a climate change, that will further like 160 to 185. That means additional 25 more import we need for the food crops. Where cereal we are net exporter, but due to climate change, it will convert into a net importer, and we will start importing rice because of the huge fall in the rice yield, and will remain net importer of fruits and vegetables. And in 2050, the situation will be much bigger than what we observe in 2030. Now, if we look at the benefit to the producer as well as the consumer, the total welfare gain that we measure here is in terms of economic surplus. Because if as an economic student, if you understand a demand and supply scenario, so area under the demand curve is your consumer surplus and area under the supply curve is your producer surplus. So if we look at that, total welfare loss will be 1.5 trillion rupees. Sorry, 1 trillion rupees. Whereas there will be a gain to the producer. There's a 78 billion rupees, there will be gain. But the producers, like here the farmers, they are also consumers. So when we combine them, there will be negative implications. So it's not that only producer surplus is positive, we will be happy. We have to be happy that consumers are also gaining because farmers are also consuming. Because if farmer, and India is largely the small farmer and cannot produce all the commodities that they require. So we have intervened with the climate smart technologies, and the technologies are classified into 5 different categories. One is a seed varietal technology that could be like heat tolerance, flood tolerance variety, then fertility management, irrigation water management, and crop protection. And finally, we have grouped the varietal development technology as with the irrigation water management technology. Because in most of the times, we have observed that farmers adopt the improved variety along with the modern irrigation practices. So if that happens, then what will happen to our economic indicators? And the adoption rate, which we are taking here, quite optimistic kind of adoption rate that we are assuming by 2030, if 50% of seed varietal technology adopted, that is a moderate kind of adoption scenario. But in the case of high, we are assuming 60. So more or less, we are assuming more than 40 to 50% rate of adoption by 2030, and then by
Dr. Paul, you have to conclude quickly.
Yes, I'm coming to that. So no, I'm not going to repeat this impact on the crop yield because most of these technologies we have identified have the potential to rise yield. But what is the major challenge or impact which we would like to see is the welfare measure. That if we take that optimistic assumption of your adoption, then how much gain we can have in terms of losses, in terms of welfare losses which we observe due to climate change. So what we found is that with the adoption of CSA technologies, we can reach even 168 billion per year under the moderate adoption scenario, which as compared to the loss of 1.5 trillion per year without CSA. So in summary, the rice is projected to fall, rice yield, and this drop will be very huge. And welfare loss will be around 1.5 trillion per year. But adoption of CSA technology can give us welfare gain for both producer as well as consumer. But CSA technology alone cannot solve this problem. We need the policy and as well as institutional measure to scale them up. But the issue is that we must say that government initiatives are also continuing that may not explicitly focus on climate smart agriculture, but there are policies which are potential to scale up climate smart technologies. And few of them are like this. So when we map those policies with the different pillar of climate smart agriculture, what we see is that there is a huge number of policy programs, and the different components of the program has the potential to scale up climate smart agriculture, like Prime Minister Kisi Sinchai Yojana, and under which there is a lot of irrigation scheme has been converged. And then there is RKBY, and at RKBY also there is a component called natural resource management micro irrigation. So this is the way we have tried to map, and we found that there are policies which are leading to the climate smart agriculture, and we need to strengthen them to scale up the climate smart agriculture. Although it was very brief, and if you want to know much detail about it, so there is a book, Climate Smart Agriculture in South Asia. So you may refer that, and you can reach to me if there is a question, and I'll be happy to answer any comments and query on this platform. Thank you. Thank you very much, sir.
Thank you very much, Dr. Paul. It is a very interesting study, and I think the investments that will be required to strengthen this climate smart agriculture is going to be a big question, whether at the policy level we will be really able to make that investments or not. But it is a really interesting thing for the starting a discussion on that part. May invite Dr. Sandeep Kaur, who is expected to speak on evaluating opportunities and challenges for direct seeding rice as green technology in Punjab. You have to unmute first to speak. The speaker has to unmute, I think.
Very good afternoon, sir.
Yeah, go ahead, please.
Let me do. My screen is visible to everyone?
Yeah, it is visible. Please go ahead.
Yes, sir. Very good afternoon, respected chairperson, Professor K.S. Rao, and my dear fellows in this panel. Today, my topic of presentation is evaluating opportunities and challenges for direct seed rice as green technology in Punjab. First of all, I want to tell you why I have selected this topic. The direct seed rice has been proposed many times as a green technology in Punjab, but Punjab farmers are reluctant to adopt it. But during COVID-19, it's an ample opportunity for Punjab to adopt it. Let's look at this scenario one by one, then we can get the picture whether this technology is successful or not. First of all, see the climate change and groundwater. There are two major challenges at present. We have water scarcity and food security. There is a temperature increase between 1.1 degrees Celsius and 6.4 degrees Celsius by the end of 21st century as per the projection of IPCC. There are other predictions regarding an increase in average ocean level, sea level, all have an impact on water resources. And now come to the climate change and agriculture impact. There is a definitely adverse impact on agriculture productivity by climate change. Unequal use of natural sources in agriculture has vastly affected the sustainable agriculture development. And Punjab is one of the agrarian states where monoculture of paddy and wheat has not only depleted the water table, but also increased the post-production and soil degradation, and many more things. Before going into the depth of this study, let's look at the pattern of Punjab agriculture so that we can think about the DSR scenario. There is a assured market for paddy and wheat in Punjab. Availability of irrigation facilities in Punjab, it is not possible to come out from the vicious circle of this monoculture of wheat and rice. The recent reports also spoken about that the extraction of groundwater has increased from 149% in 2013 to 165% in 2018 in Punjab. And the more worse situation in central Punjab, that is 70% depletion of groundwater, very alarming situation. And in paddy is a water intensive crop, and out of 3 million hectares of paddy, 2.94 million hectares is irrigated through tube wells. That means giving another chance to deplete more water. And now, once we want to talk about the climate change adaptation strategy, whether it is possible for Punjab to adopt it. If I look at the various strategy into 3 categories, that is changing cropping pattern, either Punjab will change the cropping pattern, which is not possible. It's at in a short period, it need a long way to go, changing location because agrarian land is limited. Much land of Punjab is for industrial use. That is also not possible. Now I am looking for tilling method. Just see what is that, and we will come to this method. Paddy. Paddy is grown by traditional plantation, and paddy is a water intensive crop, and it has given an alarming situation of water depletion in Punjab. And in a traditional plantation, there is a need of high labor cost. Due to all these reasons, that DSR, that is another tilling method, is preferred. Let's look at the traditional versus direct seeded rice technique. In traditional plantation, there's a need of huge amount of water, as it is grown by planting seeds, transplanting the saplings, and keeping them 3 to 4 inches of water to reduce weed growth. And it involves a much labor. But in direct seeded rice, there's no nursery stage. Seeds are directly drilled into the fields by the machine. And this technology is also known as a green technology because it saves water, less soil degradation, low amount of methane gas, and low cost production. Now, during COVID-19, there is an ample opportunity for Punjab to adopt it. It has become popular during COVID-19. Farmers initiated this technique. The main reason behind that, scarcity of migrated labor. In Punjab, nearly 12 lakh laborers come from other states like Bihar, UP, and Jharkhand. Punjab labor is costly as compared to migrated labor. Therefore, in this technique, where labor is not much required as traditional plantation, therefore, farmers has taken the initiative. And moreover, the target of a quarter of paddy sowing area under this technology has been set by the Punjab government. And in view of that, Punjab government has put subsidy rates for DSR machines. Now come to the directly to the field survey. Me and my one of the friend, that is Happy Singh, I'm really thankful for him for deeply survey in the various fields during COVID-19. What are the main facts come from the field survey? Very interesting, very alarming facts have come out from the field survey. There is an overwhelming response of farmers for DSR technique. That is a very good sign for Punjab. But simultaneously, the farmers use both techniques, traditional as well as DSR, because they have a fear of loss of productivity. And in Punjab, as well as in India, we have nearly 85% small and marginal farmers, and therefore they cannot afford the machines. And what happened? They have hired machines of DSR at rupees 1200 per acre from large farmers. And some farmers are so innovative, they have modified existing machines, that is a weed drilling machines. I can show you in this slide. See these modified machines which they have used for DSR. Though Punjab government has announced a subsidy for DSR machines, but they are reluctant due to cost or due to other circumstances for this. The main thing is production of paddy is not as traditional plantation. The main reason is weed growth. Traditional plantation puts a water layer and therefore weed is not grown. But through DSR, weeds has grown at a large level, and farmer claim that their production, the paddy production, hasn't come into that scene. One more interesting thing, unable to manage paddy stubble due to use of both technology, because it is always said by DSR that because through DSR, crop matures 5 to 7 days before, and farmers have enough time to manage the paddy stubble. But farmers have not adopted paddy stubble management until they are waiting for the field which is also having traditional plantation method. They waited for that crop to be matured so that they can manage to gather, harvest, as well as market facility. So therefore, paddy stubble management, we cannot do that. And more than 50% farmers from my field survey, they initiated DSR technology, but after some time, they shifted to traditional plantation. They couldn't adopt, they couldn't succeed in later stages, and therefore immediately they shifted. There are other facts also from the field survey. Farmers having a technical knowledge, there's a lack of technical knowledge. What is a proper sowing time of different varieties of paddy under DSR? There's no information about the quantity of the use of seed per acre. And moreover, there's a lack of irrigation management strategy, because farmers are not aware of pre and post irrigation interval time. Because the weed growth is so fast, and therefore they couldn't manage the weed, control the weed. And this is a very lethargic situation for the farmers, because they have to hire the laborers for picking up weeds. And it's so interesting, the earlier stages they are not using labor, but in the later stages they have to pay labor cost to pick up weeds. And moreover, at the same moment, the machines, the DSR machines demand is so much, and therefore the non-availability of machines also made their situation not successful.
Please conclude, Dr. Kaur.
Yeah, this is my last slide. For these all scenarios, I want to say that DSR technique is environmental friendly, as it reduces methane gas emissions, less use of water, but still needed technological improvement in DSR to get more benefits to farmers. As a green climate adaptive strategy, it will help in reducing greenhouse gases and sustain growth water. But main problem is where? Dissemination of knowledge. The knowledge is not properly disseminated through proper channels. Though I can say that during COVID-19, social and fiscal distancing measures, Kisan Melas and proper training and campaigning is not available. But online platform toll-free numbers are also not being utilized. That is, therefore, there's a need of some education to be provided to the farmers so that they can get, because it is very tough for the farmers that in the next season whether they will adopt this technique. Yes, it is from a very experienced farmers. They agree and admit that more than 20 to 30% water has saved. And one more thing, weed management strategy is not available. At a very early, before the plantation, they have already used pesticides and herbicides because they know that weeds will grow. But that is also a sad situation. On one side, we want to save groundwater, and other side, high use of herbicides and pesticides for the management. That is also a big cost on our green technologies. And moreover, provision of machinery to the reach of small and major farmers should be, we have to think on these grounds. DSR is a good initiative, green climate adaptive strategy as alternative of traditional technology, but there are big loopholes in the implementation. Instead of proving advantageous in the form of cost-effective water-saving technique, it couldn't prove 100% success because as it has put an extra burden of cost and loss of production as compared to conventional technique. And therefore, there is a need of government and agriculture institutions set up to do some ground level field work for DSR. And also there is a need to control weed. For that, there is a need of more technological innovations. Then only we can adapt green technologies in Punjab, which is having a very lowest level of groundwater.
Thank you very much,
so
Dr.
much.
Kaur. I think it is a very interesting study. I think certainly the extension of this technology is going to be a boon to the Punjab farmers. So we really thank you for the informative study. May I invite Professor Girishan, who is expected to speak on water budgeting for sustainable development, experiences of micro-level study on climate resilient agriculture.
Thank you, Professor Rao. At the outset, I would like to thank Professor Sunil Nautiyal and Professor Anil Gupta from ISEC and NADM respectively for giving me an opportunity. In fact, the objective of the paper is to ascertain the demand and supply of water in a village panchayat of Tamil Nadu through a systematic approach and scientific process of water budgeting. And the paper also tries to analyze the influence of climate resilient agricultural practices in the area by examining the changes in the demand and supply of water on a longitudinal pattern and to put forward suggestions. I think we all know it's an established fact that climate change affects agricultural productivity through physiological changes in crops. And agriculture sector is very much vulnerable to climate change. And any negative variation in that sector could affect the country's food security and nutrition security. And we all know about 86% of the operational holdings belongs to small and marginal farmers. And these farmers have several handicaps and cannot easily adapt with the impact of climate change. And it says it's not always enough for adaptation. It is important how a farmer perceives the risk associated with the climate change. And climate change is expected to make substantial adverse effects in India, where the farmers makes up about 55% of the total workforce as per the census 2011. And it's likely to have a serious impact on water security, food security, and nutrition security. And its impact will be at multiple levels: global, regional, national, state, and local. And here the responses to these impacts also need to be made at multiple levels, calling for strategic interventions at each level. And here this is an attempt made at the local level. And coming to water budgeting, it involves an understanding of water availability, communities' existing needs and requirements, crop planning based on availability, optimizing irrigation, equitable sharing of excess water, and considered or informed decision on groundwater withdrawals. And of course, it can be also used as a tool to motivate the communities to protect, preserve, and optimally use water by having informed and calculated decisions about the use of water, selection of crops, and crop patterns, food practices, and all that. And it cannot be used as the process of judiciously identifying the use of water for human being, livestock, agriculture, industrial purposes, and all that. And at the micro level, we can use this to enable the farmers to be aware of the vagaries of climate change, and also to enable the farmers to adopt climate resilient agriculture using the traditional wisdom and other inputs. And at the macro level, it could contribute to the policy discourses on disaster management and other cross-cutting domains. And the process demands calculation, analysis, and documentation of the availability of water resources and quantum of water usage in a specified area. And here, for the availability of water, we have tried to take the inputs like total area, annual rainfall, and groundwater storage, surface water storage, and recharging of groundwater from surface water. And for the quantum of water usage, we try to analyze the quantity required for human being, livestock, agriculture, industrial purposes, other things in the specified area. And the inputs, as I said, area, annual rainfall, and measurement of water bodies in the area to have a record of the surface water and population, which includes even migrant population, livestock, and also disaggregated data of the livestock like small animals and big animals like goats, sheep, cows, buffaloes, and areas under the cultivation, like again disaggregated data for different crops like paddy, pulses, vegetables, fruits, flowers, and also water for industrial requirements. And we used a mixed methodology and interviews with the key stakeholders, and also wide use of participatory tools and techniques like resource mapping, social mapping, trend analysis, and seasonal calendar. And we used a longitudinal approach by trying to take the data from 2 years, 2011 as well as 2018. And we have taken a secondary data from the Sembed village panchayat of Tiruvallur district of Tiruvallur, Tamil Nadu, and also from the various government departments like Public Works Department, Revenue, Animal Husbandry, and Social Welfare, and also from an NGO which has been working in that area. And a brief about that village panchayat, it has a total area of 941.64 hectare and has a rainfall. Of course, there is a variation in the rainfall, and there is an increase in the population. We could see there is a variation in the livestock like cows, buffaloes, and goats, sheep. And there is a variation in the total cultivable area during these 2 periods. Like you can see, there is a drastic reduction in the paddy, and there is also a reduction in the groundnut and pulses, whereas you could see there is a surge in the jasmine and vegetables. And for this data, we have taken from the Tamil Nadu Water Supply Board. For a human being, 70 LPCD, and for livestock, for the small animals, it's 25 LPCD, and for cows and buffaloes, it is 60 LPCD, and for agriculture, paddy, pulses, vegetables, all these things taken from the Tamil Nadu Water Supply Board. And this is how we have arrived at the calculations for the total water availability area into rainfall into 10,000 lakh liters, and groundwater, surface water, and storage in the tanks, ponds, and recharging. So all these things have been calculated. I think because of positive time, I'll just quickly move to the subsequent slide. And we could see when you have a comparison of 2011 and 2018, we could find there is a reduction in the rainfall, and of course there is a increase in the population, and there is also a serious, you can say, variation in the cows and buffaloes, like there is a drastic increase, and whereas the goats and sheep, like small animals, have come down. And you can find there is a drastic reduction in the area under cultivation for paddy, as well as there is a reduction for the groundnut and pulses, and you could see a surge for jasmine and vegetables. As I said, variations you could find. And the deficit of water in the area, like from the net water storage, from the total water availability, we could find there is a 4,682 lakh liters. There is a deficit on a comparative scale, on comparison of these two these two periods. Some of the important findings, you could find there is a drastic reduction in the cultivable area for paddy. It has reduced to 38%, and whereas groundnut it has reduced to 75%, whereas flowers and vegetables it has increased to 177%. We could find in this specific area, the paddy cultivation came down from 3 crops in 2011 to a single crop in 2018. And we could find there is a drastic variation in the agricultural practices and productivity owing to the shortage of water. We could find in this village, the farmers have moved from paddy to groundnut then switched over to flowers and vegetables during this 8 years of period. And the reasons could be very many reasons: reduction in rainfall, which also resulted in reduction in availability of water for agriculture. And also we could see by interacting with the farmers, it was an informed and conscious decision by the farmers to switch over from one crop to another crop. And of course, we could find the availability of easy and ever-ready market for jasmine and vegetables. And cultural factors, I think the importance of jasmine in the market is, especially in Tamil Nadu and Pondicherry, it's very, very significant, and easy returns from the crops, and also preference for the financial support from banks and other financial institutions, because banks and other financial institutions, they were much more eager to provide support for farmers who are growing jasmine and vegetables than paddy, and lesser dependence on extra labor, because most of these works could be done by family members and they don't have to depend upon people outside the family. And we could find the farmers in the village have started, there is also a variation in the animal husbandry pattern, because they have started rearing more big animals rather than small animals, because of the state government scheme, they have received more milch animals. And also there is an increased dependency of farmers on milch animals to compensate the reduction in the agricultural productivity. And because this area, since it has faced a lot of variation in the migrant population, I think there was an increase in demand for milk and milk products, because there are a lot of people from the north and the northeastern parts of country have come to this in this area. So looking at that, the increase in demand, the farmers on their own have switched over to more animal husbandry, especially like cows and buffaloes. And of course, there is also a change in patterns in the food patterns and preferences, where they have started consuming more meat. That's why there could be a reduction in the goat and other small animals. And we could find the traditional knowledge, practical wisdom, understanding about the varying market needs, and lesser dependency on non-family labor force, and urge to reduce input costs. All these things we could feel here. And of course, there is also an increased preference to cows and buffaloes rather than goats. Could be the manifestation of the practical wisdom as per the market demand, considering the rise in demand for milk and milk products in this area due to the migrant population. And I would like to conclude by highlighting water budgeting could be carried out in a village is an effective tool, as well as it can be viewed as a strategy to analyze the availability and demand for water, aiming at sustainable development. And here we would like to portray the different ways practiced by small and marginal farmers in a small locality, and how they adapted to the climate resilient agriculture in allied areas. And this study was carried out in a small area, but at the same time, the methodology and procedures of the water budgeting, it could be replicated elsewhere by making relevant contextual variations. And this exercise shall be done at periodical intervals involving all key stakeholders, because here we are able to bring out this analysis because we have done this exercise on a longitudinal pattern in 2011 as well as 2018. And the outcomes of such efforts could be factored in disaster management strategies and measures, considering the simplicity of the tool and the pathway adopted. And I have no doubt to say the water budgeting has the latent potentials to provide value-added inputs to climate resilient agriculture, as well as nutrition sensitive agriculture, towards realizing food security and nutrition security. Thank you.
Thank you, Professor Jason. It is really a very interesting study. It would be really interesting if somebody could evaluate where from these people are getting fodder, because the increased number of cows and buffaloes certainly would be putting more pressure for the fodder resources as compared to the small animals. Certainly very interesting study. Thank you very much. We'll take the questions if there are any later. Okay, thank you very much. May I invite Dr. Xavier Susai Raj?
Yes, sir. Yes, sir. I'm here, sir.
Okay, please go ahead.
Very good evening to one and all present here, respected Chairman, Dr. Rao, Dr. Nathial, and Dr. Bala. First of all, I would like to thank Dr. Nathial for giving me this wonderful opportunity to present my paper. So good evening, and once again, I thank Dr. Nathial. Dear sirs, madams, and dear research scholars, the paper which I am going to present is Estimation of Rural Drinking Water Supply in India, a Contingency Valuation Method. Introduction. Water is the most valuable, precious natural resources and basic need of human life, animal consumption and crop production. As the world population was 7 billion in 2010, 10, and it is expected to increase 8.6 billion in 30s. The United Nations Population Division estimated that nearly 50% of the global population will be living with water shortage due to demand outstripping supply with climate change. And nearly many lakhs people are dying due to water contamination. Now, what is a water scenario in India? India is a water-stressed country and moving towards water scarcity status to its low per capita water consumption. For example, in the year 2002, the water demand was 85 liters per capita per liter per day, that is LPCD, and it is going to increase 125 to 170 LPCD in 2025. Now, if you go to the rural domestic water demand, is also was 70 LPCD in 2000, and it is estimated to be 150 LPCD in 2025. In India, every year 2 lakh people are dying without a good quality of water due to water contamination and water pollution. Now, the climate change and the water. The global temperature have risen by 0.7 degrees Celsius and are continuing to rise at an estimated rate of 0.2 degrees Celsius per decade. If we are not checked with this, the global warming at least by 1.2 degrees Celsius to 2 degrees Celsius by end of this century. According to the Millennium Ecosystem Assessment, the climate change may already be causing a long-term shift in seasonal weather patterns and runoff production threat that defines a renewable fresh water. Now, for this, there is the United Nations organization has given a lot of importance to the drinking water. Now, for example, the Millennium Development Goal and Sustainable Development Goal, they gave much more importance to the pure, safe drinking water supply. In the Millennium Development Goal, the 7th goal emphasized about the safe drinking water to the people. And the Sustainable Development Goal was framed in 2050. They emphasized, the 6th goal emphasized about the pure, aiming for providing a clean and pure water and sanitation before 20 and 30. Now, even the Indian Constitution, the Article 47 and 33 and 234G says that the duty of the state to provide clean water to the people. Now, I will move on to the research gap. With this background, we conducted a study, the empirical study on contingency evaluation method. There are a lot of literatures are available, particularly the Venkatachalam, the recent literature, and many more literatures. They talked about the willingness to pay. But many studies have been conducted to measure the willingness to pay for water. Still, there is a knowledge gap in this area. The willingness to pay have not attempted to measure the household perception of existing water sources as a determinant, as an indicator of willingness to pay for clean water. So there is a need for empirical research which focus all problems related to water and people's willingness to pay for improved drinking water in rural areas. Therefore, the present study will focus on rural drinking water supply in a district, Tirunnamalai in Tamil Nadu. Now, what are the research questions? The following are the important research questions. Whether rural sample households are willing to pay for improved quality water. The second research question is, do socio-economic and demographic factors affect the willingness to pay for quality drinking water? With this research question, we framed an objectives. The following are the important objectives. To estimate the cost of assessing the drinking water in the study area, that is in Tirunnamalai district in Tamil Nadu. To estimate the willingness to pay in assessing improved quality of drinking water in the study area, Tirunnamalai district in Tamil Nadu. Now, this is a map. We have selected Tamil Nadu. Then from Tamil Nadu, we have selected the Tirunnamalai district. Now, the reason for selecting this particular district is that it is a rural, most of the places are rural, and there is no speciality in that district. Mainly, there is no industries and no big malls are available in the district. And water is also one of the biggest problem for the rural people, particularly in the Tirunnamalai district. and how we collected the data. A well-structured entry schedule was used to collect the data from the respondent, the household respondent. Now we have used a multi-stage random sampling method to collect the information from the households. Nearly the total sample is 540 households consisting of rural households. So we developed a model that is a contingency valuation method. And what is a contingency valuation method? It is nothing but to estimate the monetary values of environmental goods and services, particularly the water. So we developed a model with contingency valuation method is also based on the people's perception. So we developed the willingness to pay model we have used. Now, what is the willingness to pay? Willingness to pay is an economic concept which aims to determine the amount of money a consumer is willing to pay for and supply of the water or natural resources. So the model starts with the utility function U is equal to UXZQ. That means utility, quality of water, composite of other market goods, and quantity of water. So the model as we developed, we have used the ordinary least square method in order to estimate the willingness to pay for the consumers as well as to the household. And finally, we derive these equations. And finally, we have used the Hicksian analysis, and the specific model is that WTP is a function of RO, then using water treatment device in home, the taste of water, hardship of water, color of water, age of respondent, the gender of the respondent, education of the respondent, and income and the water bill. So this is a final equation we have developed in order to identify the factors influencing the household willingness to pay for improved water quality. And these are the results after collecting these 540 samples from the rural areas. Actually, we taken the Tirunelveli district as a sample study area. From the Tirunelveli district, we selected 3 blocks. There are 10 blocks are there, and we selected some 3 blocks. From the 3 blocks, we selected 2 revenue villages. So from the 2 revenue villages, altogether, we collect 540 samples. All of them are rural household. From this, these are the, and also we have collected the information from different people. For example, if you take about the socio-economic condition of the people, nearly 75% of the male we covered, and the age, if you take about the age, less than 30 years, 67%, and 30 to 40 years, 181%. And regarding the educational qualification of the respondent, all of them, that means 70% of the respondent, they are below SLC, and 24% from the higher secondary. Then occupational status of the respondent, that is, most of them are agricultural laborers, that is 44%, and non-agricultural laborers comes around 34.0%, and the government employees only 6.2%. Now come to the income level or income status of the respondent, that is nearly 54% of the respondent or the household, they are below 1 lakh per annum. Now, regarding the water supply, when we collected the information from where they get the water supply, there are 5 different sources of drinking water supply.
Dr. Raj, please conclude.
Yeah. Just a minute. Wait. So we used the TOBIT analysis and to improve the quality of drinking water. From this table, we concluded that most of the variables are significant, particularly the RO, then color, gender, education, age, and water bill. So these are the factors which influencing the willingness to pay for drinking water supply in the study area. Now this is the amount they are ready to pay. Actually, 50 to 75 rupees they are ready to pay for buying the water. Now the policy implication. The individual tap connection to every household is required, as our Prime Minister has announced. The Jal what you call as Jal Shakti Abhiyan scheme has to extend it to all villages. Then village level water monitoring committee should be set up. The unused hand pumps may be brought into reuse to create awareness about the efficient use of water. Leakages of water to be controlled and monitored by the local government. There should be adopted a low carbon and climate resilience to development practices to increase the renewable energy sources. So these are some of the important policy suggestions we would like to give. Then another interesting thing, people are spending more amount of time to fetching the water, particularly the women and the children are vulnerably affected by collecting the water. And these are all our major findings from our study. With that, I conclude my presentation.
Thank you very much, Dr. Rao. It is an interesting study. We will take up the questions if there is time in the end.
Yeah.
May I invite Mr. Sunil Mysore to speak on breaking the water energy food nexus.
Yeah, good afternoon, everybody. Am I audible?
Yeah, please go ahead.
Good afternoon, sir. Good afternoon, everyone. Thank you for giving me this opportunity. My name is Sunil. I work as a director of a company called Hindran Engineering. So the topic I have decided to talk about is breaking the energy, water, and food nexus. Okay, is my screen visible, sir?
Yeah, it is visible. Please go ahead.
Yeah. Okay. So I am Sunil. So I start by saluting everyone here. I salute all the great men and women here who are working for the good of the society. I am going to strictly restrict to 8 to 10 minutes. If I am exceeding, kindly let me know. I will stop immediately. So as an introduction, we have always seen these three things: energy, water, and nutrition in isolation. Okay, because all our studies, all academic literature, most of it is addressing these three important things in isolation. But actually, all of them are very, very, very closely interlinked. Okay, a United Nations report in 2004 gives very, very categorical picture that you cannot, the society cannot afford to look at these three very important things in isolation and needs to address the challenges together. Okay, so this is a slide which I picked up from the same report. See, actually, if you see here, we are using a lot of energy for producing water, and we are using a lot of water for producing energy. So net, actually, we are not saving anyone or becoming more efficient in any of them. Okay, so this is the background in which actually I even started my company based on this slide. So the same report, it's there to read. I don't want to go into details of all these things because it's very simple. Like if you divert more water to irrigation, that water is compromised for domestic and industrial use. If you use pressurized machines for agriculture, you are using more energy. So you're compromising energy elsewhere. If you grow more bio crops and bioenergy crops, again, the classical food versus fuel problem will start. So I think the need of the hour, in my opinion, is to actually recognize these synergies, and balancing these trade-offs is central to ensuring water, energy, and food security. We need to look at all the three in a very holistic way and address all of them together without compromising others. So we have to look at some sweet spot in which all of them are not compromised and efficiency, all of them are increased. Okay, so I have come across this very famous statement somewhere. It says a well-defined problem is half solved. So these are the numbers which we're actually staring at. I just would want to, I would just want to concentrate on the last item here. If India, whatever the superpower means, the energy footprint, we're looking at around 8 trillion units. You need to be producing energy at 8 trillion units per year if we have to be somewhere so-called superpower. I don't know what it means. So at 8 trillion units, one can imagine what the amount of water we're going to use for hydroelectricity, for nuclear, for thermal power plants. So this 8 trillion units is not going to just come free like that. Okay, it's going to be a lot of water footprint for that, a lot of energy footprint for that. And we have to innovate some way in which we have to address 8 trillion units without compromising both food and water security. To sum it up, it just says, we need to produce more food with less water. How we are going to do? That's our engineering challenge. And we have to generate much, much more energy than what we are consuming or generating today without harming the ecosystem. So this is going to be a challenge for the next generation, and we will see how best we can actually address this. Okay, the other details I don't want to go into because of the paucity of time. If there are any questions with my limited knowledge, if I can address, let me see. So again, I will not go into this thing I just explained in the previous slide. There is a need to find the sweet spot now. We need to actually break this jinx between energy, water, and nutrition so that each one can be addressed independently and the trade-offs and the degree of nexus is as minimum as possibly we can. So the need, in my opinion, is to actually innovate a hybrid model in which these things are addressed together. At the same time, the jinx between them are broken. So I have done some experiment, a very, very basic experiment, to actually see how this can be made as independent as it possibly can. And my area of my experiment is 2.5 meters from my head. That is my rooftop. Okay, that is where all my experiments are actually carried out. So what actually I mean by an experiment is I have coined this term called a sustenance roof. Okay, so in this sustenance roof, all my basic requirement of energy, nutrition, and water should be met. Okay, without compromising its both quality and quantity. Okay, so there's a set of experiments, an everlasting experiment, which is now it has become more of a spiritual exercise for me than an engineering exercise. So I can go on talking about it, but I will try to limit my presentation to about 8 to 10 minutes. So my idea is a model in which my roof is able to sustain me in terms of my energy, water, and nutrition requirement. I have coined the term called sustenance roof, where this roof is maintaining all the necessary inputs for me. So I will try to address each of them now. Now, first and foremost is the water. Okay, so the water, which the cup of water which I am holding in my hand, is the water which fell on my head yesterday. Yesterday's rain on my head actually is what I am drinking now. So to put the numbers, I have an area of about 105 square meters. Okay, with the Bangalore rainfall of 970 mm, more or less it is the same in the last 25 years. So I harvest about 86,500 liters of water. Okay, with the family of 3 and the family of 200 plants. Okay, our water footprint per day is about 430 liters. So if at 430 liters and 86,000 liters of reception, we are about 200 days of water security assured, okay, per year. And the most important thing is, a part of this 86,500 liters goes directly into the earth through what is called as a recharge well. So we are saturating the soil around the well so that the aquifer becomes saturated and it becomes yieldable, or rather it's always started yielding, so one can extract the water from the shallow aquifer. So actually, if you click on this photograph, you can actually see a video. I'm not playing this because we don't have time for all that. But if you can see the right side video, this is actually a recharge well which I did just about 400 days back. There was no water. And I consistently recharge the aquifer in the last 1 year and now have 3 feet of standing water. And now this 3 feet of standing water is irrigating all my 200 plants at about 1.50 rupee per unit of energy. The same water, if I had to buy from the BWSSB, that's the corporation responsible for supplying water, they are charging me 8 rupees per kiloliter. This water, which comes from 20 feet below my feet, is at a cost of 1.50 rupee per kiloliter. So in terms of quantity, in terms of quality, in terms of my security, this is a very well judged investment. So what I would say, and see, most importantly, coming to how it is actually breaking this jinx, this water has no energy footprint built into that. This is falling on my roof, what I call the water path. From the time of reception and the consumption, the linear distance traveled is just 20 meters. So there's no embodied energy in this water. So entire water which falls on my roof is either directly consumed or goes into the recharge well, which again comes back to either consumption or for irrigation at no embodied cost. And mind you, there's absolutely no energy involved in either transmission or treatment. So this saves, not only saves, it actually breaks the jinx of the energy for water. So this is both in terms of sustainability as well as economically, this makes a lot of sense. So I will not go into details of what is sustainability and how it is achieved because we don't have time. So next comes the energy portion. Now how I'm going to address the energy thing. So again, we are a family of 3 and a significant floating population. And again, there are quite a number of plants here. So to address the energy issue, I have a 3 kilowatt rooftop PV system and a 150 liter rooftop thermal power system. So at a normal middle class family, we consume about 5 units of energy, including cooking. The energy required for cooking as well as for our heating, lighting and other energy demanding applications, we use about 5 units of energy. And this 3 kilowatt is generating about 12 units of energy per day. So we are actually generating arithmetically double our requirement. And what we are also doing is a part of this solar thermal system is connected to the kitchen. So the water which comes into the kitchen is preheated to a certain extent, not to the level in which it is used for cooking, but it is preheated. So the energy embodied in actually cooking is reduced because the water is already hot. So, and we are also generating excess energy, which we are actually giving it to the grid at almost free of cost. And that goes into the grid, good clean source of energy. What we have also done is we have painted the roof white. So the temperature on the roof and temperature below the roof both goes down. So that becomes thermally more comfortable. It's a very old house, as a matter of fact. So thermally we are very comfortable because the heat dissipation into the house is much lower. And for this reduction of heat, we are not using any energy. There is no embodied energy and there is no embodied water also in this. So again, this is you can click on this photograph, it will take into a video. I am not playing it because we don't have time. To summarize in the last 1 year, see this is the left side photograph is our solar power plant. What actually I call it as an agri photovoltaic power plant. So in the same real estate space, we are also growing nutrition and we are also generating energy. And the water which falls on the solar panels goes into my remote harvesting system. So this 200 square feet of land is actually giving me my water, my energy, and my nutrition. And the right side is a graph in which how much the orange is what we consume, the energy, and the blue is what we produce. So we have produced almost double than our requirement, which we are actually giving it to the grid. So that goes in the neighborhood, a good clean source of water with absolutely zero embodied water goes into the grid. So this energy has no water footprint, has a very minimum water footprint. If you go into research papers, there's something called EBDT, energy payback period. Solar power plant, it is said it's about 1.4 years. So they have recovered the embodied water as well as the embodied carbon footprint. So energy required to manufacture the solar panels is already recovered. Plus, we have also generated good clean electricity. Not only they are consuming, they are also giving it back into the grid. So how it is going to solve the energy water nexus is very simple. The energy which is generated has no water footprint. Neither it is coming anywhere, nor this water was taken to produce any power. The solar is independent, almost independent of the water. So other details I'm not going into details because I'm already, I think, 5 minutes up. So I'm not going to discuss how it is more sustainable. It's very well known. It's proved in many academic papers that solar is more sustainable than any other source of energy. Now comes to food. It's my favorite topic because I like food.
You have to conclude it quickly.
Yeah, I'm almost done, sir. So agriculture is perhaps the most difficult science. So I'm still exploring how best to actually grow our own food. But the agri-photovoltaic system, which actually we have in our roof, is actually sustaining about 15 to 18 days of our nutrition requirement. The water used for this crops again is coming from the shallow aquifer, which is not being transported from any distance. So the embodied water and embodied energy for the crops which we are actually growing is zero. So technically, if you have to deduce it, about 30 square meters is sufficient for someone to grow all the energy needs throughout the nutrition needs throughout the year. So again, if you can click on the video photo, you can go to the video which I have explained how things can be done. I'm not playing this because we don't have time. Again, I'm not going because I'm already running short of time. I'm not going to discuss how the nexus is broken. It's quite simple. The water and energy footprint for this nutrition is almost zero. So we have not actually consuming any energy or any water to actually grow this food. So again, what happens to the waste generated? It again gets recycled. So it's a complete circular stuff. So whatever waste comes from the garden and the waste which comes from the kitchen goes back into the same garden as nutrition. So there's neither logistics nor any carbon footprint involved in movement of these items. So nothing even goes out. So there's no question of waste management because there's no waste being generated at all. Okay.
Yeah.
So my conclusion is it's very much possible that your roof can sustain most of your energy, water, and nutritional requirement. Okay. More the decentralization, the lesser will be the degree between food, water, and energy nexus. Of course, all of them are very small steps. There's a long way to go. This is, as I told you, there's going to be an everlasting experiment with a lot of learning and relearning and unlearning. So this is so far what I've done. These are my findings. If there are any questions, if I can answer with my limited knowledge, I'll definitely be able to do it. Thank you very much.
Thank you, Mr. Mysore. It's an interesting study. I think replication of such technologies is going to be important for the future of the society. The session is having a very interesting mix of the papers. And there are some interesting questions in the chat box. I hope the organizers will circulate those questions and get the answers to the respective persons who has asked these questions. As the time is, we have already exceeded the time allocated to us. I will now request Mr. Himanshu Datta to summarize the session, and then thank you very much, the organizers.
Sir, thank you so very much. Dr. Datta is not here with us. He has to go for some go for some urgent work. So on behalf of him, I would like to extend our sincere thanks to our chairperson of this session, Professor K.S. Rao sir, for conducting this session very meticulously and in a very high scientific manner. I thank all the invited speakers for making excellent delivery and sharing their vast knowledge with us, and they have very systematically and scientifically linked their finding with the theme of this contemporary international workshop. Thank you so very much. And because we don't have much time, so last request to you all our invited speaker, please share your presentation. Also, please share your manuscripts as soon as possible so that we can initiate the review process for the further publication of the manuscript in the form of book. Thank you so very much, you all. And now we move to next session. The last session of today is session number invited lecture, special invited lecture 3rd, Forest and Biodiversity. I request Ms. Fatima Amin to take over and to introduce the chairperson of this session. Professor Anil Gupta supposed to chair this session, but due to unfortunate circumstances, he had to leave us for the day. I hope he will join us tomorrow. Ms. Fatima, you take over and kindly introduce the chairperson, Professor Manoj Goyal from IIT Indore, and then conduct the proceedings. Thank you so very much.
Hi, good afternoon, sir. Am I audible, sir?
Yeah.
Hello?
Yes, you are audible.
Okay. Yes, thank you so much, sir. Thank you giving me an opportunity to be the part of this 3-day international workshop come training on green growth strategies for climate resilience and DRR policies, pathways and tools. Yes, I am going to organize the special lecture 3, and for that I'm going to invite the chairperson of this session, Dr. Manish Kumar Goyal. Before inviting him, I would like to give a brief about him. Dr. Manish Kumar Goyal is an associate professor in the discipline of civil engineering in Indian Institute of Technology, Indore. His research interests include water resource engineering, GIS and remote sensing applications in water and environment and climate change. He has received B.Tech degree in civil engineering from NIT Warangal with distinction and M.Tech degree from IIT Roorkee. After being in cooperation with, he pursued PhD degree in IIT Roorkee in collaboration with University of Waterloo, Canada. He went to pursue further research as postdoctoral fellowship at Narayan Technology University, Singapore and McGill University, Canada. Dr. Goyal has I index and H index equal to 46 and 22 respective, with total citation of 169. He holds more than 100 publications on different domains and of GIS and remote sensing, water resource, climate change, hydrological and hydrodynamic modeling, snow and glacier melt, soil carbon sequestration, anthropogenic change, risk and resilience. He serves as an associate editor for ASC Journal of Hazards, Toxic and Radioactive Waste. He recently edited a book on sustainability fundamentals and applications with Joint Valley and Sons, with contribution from subject experts from over 100 countries. Has received overwhelming response from worldwide. He is among the top 20 scientists in the world, prepared by the Stanford University, and also in top 500, the leading researcher in the field of environment. His contribution fetched him recipient of American Society of Civil Engineers, Environment and Water Resource Institute Visiting International Fellowship, Dr. R.J. Gardy Research Award, Indian Society of Hydraulics 2019, recipient of American Society of Civil Engineering, ASC Best Theoretical Oriented Paper awarded 2018, NVITA GPU Research Grant 2018, IIA Young Engineers Award in Civil Engineering Division 2017-18, Indo-US Wari Fellowship awarded 2016, DST SERB Young Research Scientist Fast Track Grant 2015, Inspire Faculty Award 2014, Erasmus Mundus Intervary Award Europe 2014, JSPS Fellowship Award, University of Tokyo, Japan 2013, and Canadian Commonwealth Scholarship Award. Dr. Manish Kumar Goyal, are you with us, sir?
Yeah. Can you hear me?
Yes, sir.
Yeah.
So, you just over to you, sir. Just
Okay. Yeah. Thank you, Fatima, for nice introduction, and welcome everybody. Good afternoon. In the special invited lecture 3, Forest and Biodiversity. So in this session, we have 7 distinguished speakers, Dr. Shalini, Dr. Anjan, Dr. Francis, Professor A.G. Koppad, Dr. Ruchi, Dr. Bibhu, and Dr. Balasubramaniam. So in this session, we are talking about different aspects: climate variability, land use and cover change, ecosystem services, wetlands, human wildlife, and even economics, public expenditures. So I request all the speakers to have around time of 8 minutes so that we can finish the session on time. So without wasting, I request Dr. Shalini to please go ahead.
Thank you, Professor Manish Goyal. I hope you can see my slides and you can hear me as well.
Yes.
Yeah. So without wasting much time, I'll start with the first talk of this session. And my talk is on climate variability, forest and socioeconomic vulnerabilities, their interlinkages and adaptations. And I would like to focus mostly on Himalayan ecosystems and how these climate variabilities are leading to vulnerabilities, and especially socioeconomic aspects, and how we can actually plan adaptations to improve, reduce disaster risk in this area. So if I briefly tell about the Indian Himalayan region for all those who are not much aware about these ecosystems. So these are high altitude ecosystems, globally very important centers of biological diversity. They have environmental resources that are not only important for upstream people, but also largely for downstream people in India and other parts of South Asia. They cover almost 18%, Indian Himalayan region covers almost 18% of geographical area of the country. And it has more than 50% of India's forest cover. So that means that this area is actually very important in terms of biotic and abiotic components. And more than 40% species of this region are endemic to Indian subcontinent. But if I see last few decades, what has happened, we all know there has been a rather faster pace of development and modernization, especially infrastructure development in terms of hydropower projects, road building, road construction, road broadening, increasing tourism, so on and so forth, that has led to a huge disaster risk for this region. And this kind of development is physically and culturally much more, disasters that this region could actually absorb. And if I provide a bit of a conceptual framework, how this socio-ecological system works in Himalayas. So we all know the different ecosystem services that we draw from biodiversity and ecosystems in this region, be it carbon sink potential or water properties, water quality and quantity, the nutrient cycling, biogeochemical cycling, and other kind of disturbance regimes. They all have a great amount of interaction with social systems that includes human population, well-being of human, and also governance that basically regulates ecosystem and social system both. So this kind of socio-ecological functioning is very much important and should be in a proper place so that we can conserve ecosystem while also ensuring human well-being. And if I move to one of the important IBS Intergovernmental Panel on Biodiversity and Ecosystem Services conceptual framework, we all know that this has been very much established, not only regionally, but also globally, that if we want good quality of life that ensures human well-being and also ensure resilience of resilience building for ecosystems as well as society, we need to understand what kind of drivers are there, what kind of anthropogenic assets we have, and what kind of governance we are having, So governance becomes a very important aspect when we talk about ensuring good governance and ensuring protection of these ecosystems. So everything has to be in place. Governance has to be more interactive in nature, more bottom up, and all kind of stakeholders should be part of this to ensure well-being of humans. Largely, if we see in our panel, we have one of the lead authors of this Hindu Kush Himalaya ecosystem, Dr. Ruchi Badola, who has been part of this this assessment. So this assessment already said that this Hindu Kush Himalayas has been going through a large amount of disaster risk. And this is also one of the areas where the policymakers, planners, and disaster managers have to put special consideration to ensure that we have reduced risk. And that can only be done if we have more climate adaptive restoration planning and ecosystem management in this area. Now, when we talk about vulnerability, we have to understand that vulnerability is more socio-ecologically connected. So that means if there is forest degradation or ecosystem degradation, loss of biodiversity in any area, it actually not only leads to slope destabilization or any kind of landslides, but it also actually leads to reduced flow of ecosystem services. It may also enhance women drudgery because, as we know, in mountains, women are the backbone of economy. So largely, it not only affects ecosystem, it also affects education of people, social environment of families, and women drudgery. Now, coming back to Western Himalayas, where largely my research has been focused, we all know we have some of the best forest types and forest in terms of both quality and quantity in Uttarakhand. The geographical area, the total 63.42% of the entire geographical area is covered by forest. So it's still, the state is very much green and largely biodiverse. It is one of the important ecoregions of high biodiversity and conservation importance that has been considered not only by WWF, but also by IUCN Commission on Ecosystem Management and also BirdLife International. When I talk about important forest types, we all know that moist broadleaf forest area is very, very important because Banjok is one of the keystone species of this forest. And this largely covers a huge chunk of this forest in this area. And when I talk about Banjok forest, I should also mention that these are very, very diverse forests and have sometimes more than 35 to 43 species present in this area. Now coming back and talking a bit on what kind of benefits other than provisioning benefits they provide to us. Now, when the entire world is talking about climate negotiations and adaptive capacity building, I need to stress on the sink potential of these moist temperate forest areas, and my graphs can show how best they can actually sequester carbon in these forests in comparison to monocultures of Pinus roxburghii that is slowly encroaching these forest areas. So there are a lot of other multiple benefits that ensure human well-being. But when I talk about socio-economic drivers, that has become one of the hidden but very, very strong drivers in not only Uttarakhand, but other parts of the country that are biodiverse regions, be it extraction of medicinal or aromatic plants, where the demand is increasing because of pharmaceutical and nutraceutical products, or Kida Jari, the fungal gold being extracted in alpine areas, or lichen and any other kind of products. So we need to understand that unless we address poverty in these regions, we will not be able to ensure conservation of these and will not be able to ensure adaptations or disaster risk reduction in these high value ecosystems. So what we did, apart from the basic previous studies that we did, I also tried to look into about these keystone ecosystems of Quercus leucotrichophora. Are there any climate impact on these forests? Because oak are again the forests where a lot of spring sheds are present, and Niti Aayog has already given a lot of stress on these ecosystems. But when we try to do some simulation exercise on these forests as per 4th IPCC representative consultation pathways to understand if the area is going to show a kind of shift or increase or shrinkage. So if when we started, we tried to first of all look to land use, land cover changes over the time period through time series data. And if you see the built-up area across the forest of Uttarakhand is tremendously increased in last almost 3 to 4 decades. So this is kind of very alarming situation. At the same time, there is a lot of fragmentation that has also happened in Uttarakhand. So when we did habitat suitability modeling, we were using more than 30 years of data from published literature. We were also using the data that we generated for occurrences. And at the same time, we also used global biodiversity information facility data. And they were all around 280 points. And previously, this kind of information has not been used when they were simulating this tree species. So you can see the map. We have huge coverage of forest across Uttarakhand using diverse mapping methodologies. And when we actually use this bioclimatic data and slope and altitude were the main predictor variables. And when we mapped this, we found it that by 2050 and 2070, there will be significant decrease in potential habitats. If we see for RCP 2.6 and 6.0, there has been a tremendous decline in area and as well as increase in altitude. So summing up the findings, the high probable habitats will have a decline significantly, and in many areas there will be a tremendous result that most of these habitats will be vanished. The second important finding was that potential habitats have shown decline from 20,933 square kilometer to 4,187 square kilometer. That's a significant damage to the entire ecosystem. And this is almost 80% decline. And the altitude also shifts from 1,754 average altitude of meter above mean sea level to 2,550 meter above mean sea level. So this also shows that the species might go to higher elevation, but another point that comes into mind is if the species starts moving to higher altitudes, what will happen to other high value medicinal and aromatic plant species? So the temperature, seasonality, and altitude was a significant influencer. Now coming to some of my concluding slides. So what should be taken care in Himalayas is we need to have a more climate adaptive or climate resilient hybrid knowledge framework for restoration planning. A planning network where not only a state-of-art science-based tools are used like advanced remote sensing and GIS and habitat suitability modeling tools, but at the same time, indigenous and traditional local knowledge systems should be given enough of importance and privilege to be incorporated, because people have more idea on what kind of species are better suited, that what can better be adapted to the situation. So based on that, this framework was developed and we planned the planning, implementation and post-restoration phase. And when I talk about post-restoration phase, we need to keep in mind that citizen science approaches need to be included and more artificial intelligence and big data analytics should be part. So we need to move ahead from our basic and very slow moving restoration approach to fast paced science and indigenous knowledge based hybrid knowledge framework. So this is already approved. So I think stakeholders and especially policy planners can have a look and decide how best it can be implemented. And we already tried this approach of fodder based bank model that my previous chair of the last session was discussing about, that we need to talk about fodder issues in India and how best we can ensure enhancing fodder. So unless and until we ensure participatory tools where we involve people on developing such models that are more replicable in nature, they can actually not only benefit in giving human well-being, but they can also help in reducing disaster risk. So this was one of the models that we developed on a bioengineering approach where both gray engineering and bioengineering approaches were mixed. And they actually provided us good inputs. And this model was very much appreciated and thought as a model that is worth replicating across Himalayas, because this was environmentally sustainable, more cost effective and socially and economically responsible, where fast growing high biomass yielding species were not only included in wastelands, but also cropland bunds. And they have the potential to increase lactation yield on animals also. So at one hand, you are actually addressing the livelihood benefits of people. On the other hand, you are also targeting soil erosion reduction and slope stabilization. So that is quite an achievement that needs to be replicated. So overall, because my timing is quite small of 8 to 10 minutes, I would like to say that when we talk about climate variability, when we talk about ecosystems and biodiversity is in one of the threatened fragile but high value ecosystems across India, we need to understand that this should not be a very much a biological, ecological, or social approach, but a much sophisticated approach that helps to understand contemporary trends of subject. So that is where civil engineer or geophysicist or pedologist, political science background people and economists can actually contribute to understand what this whole climate resilience and how best it can be planned for Himalayas and other fragile ecosystems of the country. So with this, I think I summed up well in time in 10 minutes, 8 to 10 minutes. So this is all what I have to mention about what we have done. Thank you so much for this privilege of giving me space in the session. I thank the organizers and my session chair. Thank you.
Thank you, Dr. Shalini. I think it was an excellent presentation on Uttarakhand IHR region, especially ecological functioning and vulnerability, and you talked about habitat suitability modeling. So thank you so much. I think perhaps some study may be required in the eastern Himalayan region like Sikkim, Arunachal Pradesh, similar kind of study, so that both part of the Himalayan can be compared.
Thank you so much.
Yeah, thank you.
Just started something on Eastern Himalayas as well, and I hope by next year we'll be able to share those findings as well. Thank you so much.
Great, yeah. So next I will invite Dr. Anjan Kumar Pusuti.
Dr. Goel?
Yeah.
Can I please request you to invite Professor Francis Birle?
Okay, I think I got a message that in the chat box that I should invite Dr. Anjan Kumar first.
No, please
Okay.
go with,
Okay. So I request Dr. Francis Birle, Senior Lecturer in Ecology, Manchester Metropolitan University, to please go ahead.
Okay, thank you, certainly.
Yeah, I think there is some kind of miscommunication. Sorry for that.
That's all right, don't worry. Thank you very much, Mr. Chairman. And of course, thank you for the invitation. So let me just start my slideshow. Here we go. So again, thank you very much for the invitation to talk at the workshop today. And good evening, everyone. And today I'm going to be talking about developing forest monitoring networks to understand the role of forests in the global carbon cycle. So we know that forests are important for biodiversity. You know, tropical forests have perhaps 10% of the world's land surface, maybe 50% of their species. And of course, with such an amount of the land area, they're important for the livelihoods of many, many people who can obtain various products, various goods and services from these forests. But of course, more recently, with our emerging understanding of the global carbon cycle and how humans are changing that, we know that forests can be incredibly important carbon stocks, and we've seen in the very nice talk just earlier the carbon stocks that are in the forests of the Himalayas. So a few hundred tons of carbon per hectare in many of these forests. And when we add up hectares and hectares, square kilometers even, of forests, we can see how they can be an incredibly important carbon store through sequestration and storage of carbon over long periods of time. And of course, trees are long-lived, and this means that they can retain this carbon in their biomass as long as the forests, largely speaking, remain undisturbed. So a very simple method that is used to monitor forests are permanent sampling plots. And this is thought to be developed by Sir Dietrich Brandis, who was the Inspector General of Forests in India about 150 years ago. And I'm going to be talking about work that I've been doing in Indonesia, so in the island of Borneo, but I should just say that this is now being extended with colleagues in Mizoram, at Mizoram MZU. We're setting up permanent sampling plots in northeast India now as well. And here in Indonesia, we're in the very center here, more or less on the equator, where we have dense tropical forest. still remaining largely undisturbed. And where our study site is, if you're familiar with the geography of this area, it's mountainous in the center of the island and with many low-lying plains around the edge. And we're just on the edge here of the mountainous region. So here we have 4 hectares of forest plots, and what we do is we measure the size, the diameter, the height of the trees. We identify them, we mark them, and you can see here one of our helpers on the right hand side just tagging this tree. So I've had here approximately 2,500 trees that have been measured since 1998, which is when I got involved in this during my undergraduate project. So that's more than 20 years ago, and we've been carrying on since then. So what we're interested here in particular is looking at different forest types, how soil influences the forest types. It's always difficult to get a good picture of a forest, but what we can see here on the left is a stunted forest found on a bleached white sand podzol, and this forest has about half the biomass of that on the right hand side, which is a more typical lowland evergreen rainforest that we might find in tropical regions. And here a much deeper soil, much clayer rich, and more nutrient rich. And what we're interested in looking at the forestic composition, but also the biomass and hence the carbon stocks and also the growth rates. So how much carbon are these forests taking up over time? And we see here the heath forest, which is our podzol, forest on podzol, and our lowland evergreen rainforest, which is our more larger, more nutrient-rich soil. And this is looking at the growth rates in centimeters per year. This is the diameter growth rate, as dependent upon the size of those trees at their initial census. So actually what we see is that in the smallest size categories, actually the trees in the more nutrient limited soil are actually showing faster growth rates, because what we suspect is that the trees in the lowland evergreen rainforest are more limited by light, because in this smaller size category, they're actually going to be in the understory, whereas in the smaller size category in the heath forest, they're going to be subject to more light, so they're going to be closer to the canopy top. Whereas in the medium category, the growth rates are about the same, and in the larger category, we've got faster growth rates in the lowland evergreen rainforest, again, because we've got some very large emergent trees going up to 50 or 60 meters. And what we're doing now is we're extending this work from a single study site into a monitoring network. So here, this is by my colleague Lainey Chur, who's working in Leeds, but she was working in Borneo at these various sites. The orange is where she's been working, but she didn't set up these plots. She went and remeasured a number of the plots that had been set up as early as the 1950s. So she was interested to see what's happening to the dynamics of these forests over up to 70 years. And what do we find incorporating all these, excuse me, incorporating all these plots across the island of Borneo? Well, the first thing to note is that the above ground biomass, that's AGB, is increasing in the forests of Borneo. This is this green bar, and it's increasing by about 1 ton per hectare per year. And what this is attributed to is a carbon dioxide fertilization effect. In other words, carbon dioxide concentrations are increasing in the atmosphere. We know that many plants will grow better when given additional carbon dioxide because it's required for photosynthesis. And therefore, the suggestion is that these trees are slowly increasing in their biomass and sequestering some of this carbon into their biomass from the atmosphere. And this is in line with the patterns that have been shown already from the Amazon forest and the African forests. So in the region of about 1 ton per hectare per year, on top of an average biomass of somewhere between 250 to 300 tons. But what is important is we notice that at the edge here, where we've got edges, we've got edge effects. So in other words, where we see forests that are close to a fragment's edge, they're declining. Oh, sorry, they're not changing in biomass. So there's actually, what we're seeing is close to the edge is we're getting no change in biomass, these forests are not increasing. And potentially over time, we could start to see a decline because we're getting disturbance to this forest. We know that the microclimate is changing. So we've got edge effects here in the biomass and carbon dynamics. But we've also got effects due to droughts. So in 1997-98, there was a strong drought in the forests of much of Southeast Asia. So this is looking at our woody productivity, above ground woody productivity before, during, and after the drought. The second set of graphs is looking at the mortality. So what we see is that during the drought, our mortality rate increases, and consequently, our biomass declines. But then after the drought, we've got loss of trees, death of trees, and we've got therefore more space for other trees to recruit into this stand. So after the drought, our woody productivity increases and our biomass starts to increase again. And more recently, my colleague Martin Sullivan has now extended out basically across the globe. He's looked at forests in South America. This is SA, Africa, AF on the graph here, Asia, AS, and AU. And of course, this new plots that we're setting up in India, there'll be an important additional geographical data point. And what he finds is that as temperature increases in these various forests across the globe, the biomass or the carbon stock declines. Right? And this is consistent across each of these 4 geographical regions. So we have a decline in the carbon stocks with increasing temperature. And on the right-hand graph, we can see that this is because of declining gains in carbon. In other words, the increase in the carbon is slowing down at higher temperatures. So probably what's happening here is with higher temperatures, we've got increased respiration, and also plants are perhaps coming towards their temperature limit for photosynthesis. And then what he does is he calls this a breakpoint regression. And we see that essentially around about 32.5 degrees is where we see this sudden change. So once the maximum temperature, we should note this is the maximum temperature rather than the minimum temperature, goes above about 32.5 degrees, then we start to see, or we're predicted that we're going to see declines in carbon stocks. So to conclude, hopefully I've shown some data from our study site in central Borneo, looking at the impacts of soil type on forest biomass and forest growth rates, and then extended this out with our forest monitoring networks across Borneo to see how we've got impacts of disturbance on forest carbon dynamics. And then just now in this study, extending this further across the globe to look at the thermal sensitivity of Earth's tropical forests and the influence of temperature on their carbon stocks. And we can use this to make predictions about how forest carbon stocks are going to be changing over time. So thank you very much for your attention. And of course, I'm welcome to take, I'm not sure if we're taking questions now or later. And of course, you're always very welcome to email me as well if you have further questions. So thank you again for everyone.
Thank you, Dr. Francis. I think it was an excellent presentation on field study, especially in Indonesia regarding carbon sinks. So thank you so much. You have shown the 2 papers. They are very excellent. I think one in Nature, another in Science. So thank you so much.
You're welcome. You're welcome.
Yeah. Okay, now I invite Dr. Anjan Kumar Prasuti.
So you just go with the sequence, like we are having Professor A.G. Kopak, you just introduce them. Maybe Dr. Anjan will be presenting the last.
No, I think I got the list that says Dr. Shalini first, Dr. Anjan second.
Sir, I too got the list. I don't just, sir, you go with the list. Yes, sir.
So, okay. So, Dr. Anjan Kumar Prasuti, please. Please go ahead. Dr. Anjan, you are not audible, please.
Yeah, and it's a humble request to the everyone who's going to present the papers. Please mind the time. Like you have assigned some 10 minutes of time, so please.
Dr. Anjan Kumar Prashni, you are not audible, sir.
Maybe he has muted his mic.
I think we'll go to next presenter, sir.
Yeah. Professor A.G. Koppad, please.
Yeah, sir.
Please go ahead, sir.
Okay. I can start screen to share while the other participant is sharing. Yeah, here. Okay. Share. Am I audible, sir?
Yes, sir. Please go ahead. You have 8 minutes time.
Okay. Okay, thanks for the opportunity given. So I'll just go for this land use, land cover and forest vegetation classification using SAR as well as optical remote sensing. I'll just go very quickly. And the introductions I think is not required. So we know that remote sensing technique is acquiring the data without contacting, but we are just highlighting both optical and as well as SAR data. And when we combine these two, then what may be the efficiency when we get for the forest classification or land use land cover classification, that we are going to highlight in this study. And this is the study area in Uttara Kannada district of Uttara Kannada district of Karnataka. This is the things, and we have used two sensors. One is Sentinel-1A with C-band with PV and VH polarization, and Sentinel-2A with 8 bands. So we have done the classification separately with the Sentinel-1A, that is SAR data as well as optical data, and we try to combine these two, fusion data, and then again classify it, and then got a little bit higher classifications than the usuals. And this is the flow charts where it gives you the how exactly the methodology that we have followed with the SAR data as well as optical data. Then after image fusion, we did the supervised classifications, and after that accuracy assessment with cutoff correction. And again, the steps what we have followed to get the sigma or backscattering, Peckel filter and other things, all details I will not explain because we know that when the SAR data, the I and Q values are there, in order to get the backscatters, what are the different steps needs to be followed in order to get the backscatters for the surface double boards and as well as volumetric these things. All details I think sensing it already known. I will not explain in detail about that. And after that, image fusion was done for classifications. And with these classifications, I think we have done the land use land cover classifications of dense forest, moderate dense forest, and open forest. While classifying the forest, we take into consider the densiometers, where as far as the IFS classifications, more than 70% of the ground density is considered dense forest, 40 to 70% as moderate dense forest, and then 10 to 40% as a cover as a open forest, and other land cover and classifications has been done. So when we combine these area fusion image, so we have got consistent these things about 38% and 28% dense as well as moderate dense forest. And I will just show you some of the images where this is the C-band SAR data classifications, and this one is supervised classification with the optical data. And when we combine these two, we have got this is the image where the classification was done, and it was a little bit clear when we go for classifying the different land use land cover classes. Some of the field photos I will show you where the coverage is taken, the percentage of coverage is taken with the densiometer, and some of the field data like the DBH as well as the height was measured, and some sample plots about 20 by 20 sample plots were taken 20 by 20 meter, and finally we worked out the even the classification accuracy also. And when you go for kappa coefficient, say in the Sentinel or the fused data has given the higher the kappa coefficient, or you can see the classification efficiency is higher when you go for both Sentinel 1A and 2A combined compared to the individuals. And then when come to the biomass estimations of fused data, where only these three classes were taken: dense forest, moderate dense forest, and forest, sparse forest. Out of these three, we are able to estimate around 22.6 million tons of carbon sequestration, and the different steps that is followed for carbon sequestration we will not explain. So everybody know that how exactly the above ground biomass is calculated. With the density of the tree species, we will get the million tons, and also the carbon sequestration where 0.47% of the AGB is considered as the carbon sequestration in million tons. And this is a huge one, and we will compare the Sentinel itself is 19.57 million tons, and if it is as optical, it is 20.87 million tons. So because of classifications is very clear, and also it was very accurate also, and this comes to be a more accurate when we are estimating the biomass of the forest. Based on conclusion, I think the same things we have indicated in terms of the values, the table that we saw. The carbon sequestration in fused image is 22.6 million tons, followed by these two. So the finally we can conclude that the fusion of data with optical as well as the SAR data will give you much better classification and also the more accurate estimations than the individual. So with this, I conclude my small presentation, and I thank Dr. Sunil Natiyal for giving this opportunity to present this data. Thank you for all.
Thank you, Professor Arun Koppad. I think it was an excellent presentation on forest classification and land use land cover classification, and also how to compute the biomass using the basically optical and SAR data using Sentinel. So thank you so much for baseline study.
Thank you.
Okay, now I invite Dr. Ruchi Badula, scientist, G Wildlife Institutes of India. Madam, please go ahead.
Thank you very much. And I'll just start sharing my screen. So the topic that has been, can you see my screen?
Yeah, I can see your screen.
Okay, thank you very much. So my topic is, since we've had a lot of talks on very interesting different aspects, but there is another very critical aspect of biodiversity conservation. And today when we talk about it, human-wildlife conflict and conservation is at the topmost, but it is also a huge opportunity. And probably my talk will focus upon a little bit on conflicts and a little bit on the opportunity. There is a very limited time, so I'll try to make it very short. So we do know that 70% of protected areas globally are having human populations inside. What I'm trying to maintain here is that most of the natural, so-called natural areas are now being used by humans or have been approached by humans, including the biodiversity hotspots globally. And there is a critical role of these areas for reducing poverty, providing livelihoods, and at the same time, providing the critical ecosystem services so important for human survival and sustainability of human lives and livelihoods. So that is the biggest challenge for the managers, to balance between the needs of conservation or needs of present vis-a-vis the needs for long-term conservation. So the conflicts arise due to the scarcity of resources, the imbalance in bearing the costs and benefits of conservation, of course, the increasing human populations, the land use transformations. Any area that we can go to now, we see that anything outside that area, the land use may not be totally friendly or conducive to any kind of conservation. So these areas are more like protected, more like islands surrounded by seas of humanity. But at the same time, there are a lot of opportunities now. There is a lot of growing interest in ecotourism and access to protected areas, just not for exploitative use, but for non-consumptive use. There is a lot of success that we are seeing from conservation programs, and of course, a lot of livelihood options emerging from the traditional livelihood options. The human-wildlife conflict, in fact, the negative conflict, has impacts both financial and psychological for people. And several studies have pointed out to this fact that wildlife damage particularly impacts the poorest of the poor or the marginal farmers more. And it is the communities who live in the vicinities of these areas who bear the opportunity cost of conservation, which is reflected on the time spent in guarding, on repairing, on doing a hoard of stuff which otherwise could have spent in other activities. So there are visible impacts of human wildlife impact, and there are a lot of hidden impacts. Particularly here, it becomes important because these hidden impacts are more for the marginalized groups, particularly women and children. And of course, they also have an impact in terms of the different constituents of well-being. So these human-wildlife interactions are inherently very complex and difficult to address, and they require a rational approach that is integrated, which in fact incorporates all the additional, all the interested parties or the stakeholders in a productive way, which focuses on sustainable use and which uses conservation-based incentives as viable tools for reducing the conflicts, and definitely nurture the local religious, cultural, and other values, including the religious things of the people. So here, briefly, I will share with you a case study of our work, which we have done in the Ganga River, which is the river for all, the holiest river in the world, the economically and ecologically one of the most important river systems in the world. So as you must be aware that all Ganga in the upper reaches, middle and lower parts has a very close interaction with humans. And in fact, there are people living just on the banks of the river. And this river supports one of the most densely populated, it is one of the most densely populated regions of the world. And it is a wonder that despite such uses, you can see what are the different land use changes, despite the cultural and religious uses of the river, it's still maintaining its Nirmal and Aviral Dhara. It is really a wonder of management, a wonder of conservation ethos of this country, and sometimes an ecological wonder too. And you can see that what has conserved this river. 10% of the river receives, this is the main stem Ganga, I'm not talking about the tributaries. 10% of the Ganga river has incidental protection with protected areas. We have national parks, wildlife sanctuaries, and a biosphere reserve along the river. In fact, 3 riverine sanctuaries, Hastinapur, Kachua Sanctuary, and Vikram Chilar Sanctuary are on the river itself. 1/4 of the country's population also resides along this river. So we initiated I'll just focus on the community part of the work, to sensitize the people in the upper parts of the Ganga that we will talk in the people's language. Ganga Jaiv Vividta Pad Yatra, where the scientists, the students were taking their research to the doors of the people. And here they followed the traditional Yatra route, which was followed by the Yatris in the ancient times, and they visited the villages. So from Devprayag to Rishikesh, a 10-day-long Padyatra was conducted to sensitize the people all along this area. After that, all along the Ganga River, we held a large number of meetings with people. We used a lot of community-based tools, including Padyatras, wall paintings, paintings on the ghats, rallies, plantations, etc., to bring people to our fold, and established a cadre of people known as Ganga Praharis, or guardians of the Ganga. Today, we have a trained cadre of more than, it's in fact closer to 1,400 motivated and trained volunteers. We have only focused on one thing and one thing alone, that is building their human capital, investing in the human capital, building up their skills, capacity, awareness, etc. And at the same time, ensuring that they are getting a platform voice their concerns, getting a recognition for their efforts. And these are the people from all walks of life, young, old, women, rich, poor, students, fishermen, who have joined this cadre and are tirelessly working for the conservation of the river and its wildlife. But the biggest thing that brought our success was that we incorporated the livelihood concerns of these people and others into our conservation efforts. And large, you can see more than 1 lakh people were approached, sensitized, lot of meetings with different stakeholders have been held. It's an extensive, huge effort. And we used all sorts of platforms, including songs, dance, poems, every possible media was used to sensitize the people. And Ganga Praharis are still now being trained and retrained in different aspects, including village level micro-planning, surveys, mobilizing the community, plantations, government schemes, rescue and rehabilitation of wildlife in distress, etc. And in fact, in their own areas, they have emerged as social leaders. It is in fact a mass movement, a citizens movement, wherein we have these trained people who have in fact created a movement for the conservation of Ganga and its biodiversity. And a critical group of people living around, biodiversity-rich areas have been trained as first responders, which means that if anything happens to a species there, it is these first responders who come to know about it, and they immediately know that legally and ecologically what they are supposed to do, whom they are supposed to inform, and before help reaches, what they have to do. And in fact, if you visit our Facebook and Instagram pages on Ganga rejuvenation and glimpses of Ganga, you can see that every day some or the other news comes from the field where these volunteers are working tirelessly day in and day out. You can see some of them.
Sorry to interrupt, ma'am. Ma'am, can you please come to the concluding part, please?
Yeah,
It's all...
just give me 1 minute.
Okay.
And you can see that during the Kumbh also, the Ganga Praharis have played a very important role along with the Ganga Task Force, the Mela Pradhikaran, etc. and doing all sorts of activities here to ensure a clean Ganga and a Aviral Ganga, and also that nothing wrong happens to the wild species. And a lot of livelihood programs and trainings are being conducted for these people. And you can see the details here in different aspects, depending on their backgrounds, depending on their skills, depending on their traditions. We have established a floating market at Varanasi known as Jalaj, which is now being taken up as a concept for Arth Ganga to be launched by the Niti Aayog shortly. And you can see how these livelihood centers have created a huge impact, particularly to involve women in our efforts. One of these livelihood efforts recently was the launching of dolphin safari. So now the people who are actually, catching fish, etc., are taking tourists to show this very biodiversity and earning a livelihood out of this. Ganga Avlokan Ganga Museum, which was recently inaugurated by the Honorable Prime Minister, has been established. Village level micro planning on a digital platform has been done. And this program has been extended to Ganga Prahari mentors, where all of you can join. People living abroad have been brought in as Pravasi Ganga Prahari online program. And for the children, there is a Bal Ganga Prahari program. So these are huge extensions of this program, a lot of outreach which can be found here in web pages, in YouTube films, and also in the website of the National Museum for Natural History. And so it is a continuous work. This happened a few days back, where the Ganga Prahari is releasing a dolphin which was caught in a net. So there are, as I said, there are a lot of conflict, but huge opportunities for sustainable livelihood models. Thank you.
Thank you. Thank you, Dr. Ruchi. It was an excellent presentation. Though time was less, I think I really enjoyed the presentation, especially Ganga Prahari and all these.
Yes.
I will also join the bandwagon.
Everybody is welcome to join as mentors. This is an online platform. Please join and write to us. We need you. Thank you.
Thank you. Thank you so much. And now I will like to invite Dr. Bihu Prasad Nayak, please.
Yeah, thank you, Chair, and thank you, organizers, for organizing this workshop. So I'll be talking about the public expenditure in the context of Tiger Reserve. In fact, the presentation by Dr. Ruchi made my task easier. I can save 2 to 3 minutes, in explaining certain things which she has already talked about. this biodiversity expenditure or something like that's an important issue given the volume of the fund, the finance that is required for this conservation effort. There is no discussion about whether we need such kind of expenditure or not. That there is more or less an agreement on this, and it is quite huge. Globally, it's around 70 to 91 billion US dollar per year. And like a large chunk of this come from the government sources. I mean, mostly the public domestic expenditures by the national governments. Apart from these expenditure, it's a different matter that government also spends quite a huge amount to on activities which actually results in biodiversity loss. But that's a different issue. I don't want to get into that. But then that's something. This expenditure itself is actually huge. Apart from this expenditure also has some other components. One is the opportunity cost that is involved, the community in terms of losses to losses due to human-animal conflicts and other kind of things, which already Dr. Ruchi highlighted in her presentation, and that's something which is also quite huge. And in the context of a human-dominated landscape like ours, this expenditure is actually quite huge. And that apart, for a country like ours, when the priority is something else, like in a year like this, like I'm talking about this Corona year, where the government's priorities in terms of meeting, fighting with the pandemic, ensuring livelihood, providing social security support, and all other activities, spending such a huge amount on biodiversity conservation probably is a big societal choice, that involves lots of difficulties. And if you see, in the context of tiger, I'm talking about the tiger because tiger conservation is one of the most intensely managed conservation programs in India, right? And the biodiversity expenditure is something which is much beyond what is being spent by National Tiger Conservation Authority. But if you look into, I have taken this from their webpage. If you look into the NTCA's expenditure pattern, it's around 200 to 300 crores annually. So that's quite huge amount. The next question is, are these expenditure worth it? Yes, there is no, I'm not really questioning this when I'm talking about the effectiveness. That's something which is understood. And also quite there is a consensus that yes, it's worth spending on those expenditures because it helps also in supporting livelihood and many different has lots of values. In fact, recently there was a study that conducted by NTCA along with IIFM, where they came up with some kind of valuation of the tiger reserves. But the question here is, can they be made more effective? That's what we are trying to deal with this specific study. Just to take you quickly through this tiger conservation in India, it started in 1973 by the central government, and that's something we started on our own without taking help of all big sorts at that point of time, be it IUCN or Smithsonian Institute for different political economic regions. And it started with 9 tiger reserves in 9 different states with around 9,000 square kilometers. I do not know whether there is any magic with these 9 numbers, but or it's a mere coincidence. But that is how. But now it has increased to 50 tiger reserves that spread across 18 different states with 40,000 square kilometers of core areas and 30,000 square kilometer buffer areas. The land areas is also huge in terms of this. And it's though it spread across all different, as you can see, all different types of ecosystems. That's not the only variation of the states. It also varies in terms of size. If you look into the core areas, it varies from 79 square kilometer to 2,596 square kilometer for Nagarjuna Sagar Tiger Reserve in Andhra Pradesh. So the variation is also huge in this specific thing. And probably everything was quite well. We are boasting of our tiger conservation initiatives, and probably now also we are the country with the highest number of tiger population in the wild. So and probably everything was all going on well till the Sariska tragedy happened. When we started questioning about this entire initiative about this in 2004, when a journalist came up with a news piece that there is no tiger left in Sariska Tiger Reserve. Subsequently, that created lots a huge uproar in the country, and this figures here shows the tiger numbers till 2002, where we had conventional methods, and 2006 onwards we had something which was that's one of the recommendation of the committee which is considered to review the tiger conservation initiatives in the wake of Sariska tragedy. It suggested several changes. So in more recent years, with we have a much more scientific approach towards estimation of the tiger numbers. So 2006 to 2018, all 4 different censuses that I had also experienced change in the tiger number. But in terms of occupancy is the area, the habitats for the tigers, or the area where the tigers are found. That's something which has declined. So in terms of the challenges that tiger conservation faces, one is the habitat quality and prey, something that I was referring to. The occupancy has gone down, in all these more recent censuses. So is the prey population in several of these. And mortality still is a concern, with poaching being one of the major factors, are contributing close to 1/3 of the total tiger mortality in India. The other factors are the diseases, infighting, and the natural death, which is quite common. But poaching, in spite of all these intensely managed conservation program that we have, poaching still is an issue. And poaching, it's for the commercial gains. Sometimes it's also for the revenge killing. So there are different factors there. And we still have a huge community who live inside, in the core and buffer areas alone. Let's not talk about the communities who live just outside, just the peripheries of the tiger reserves, because that also has, they also do depend on these tiger reserves. If I go by the numbers, I'm only talking about fewer tiger reserves because we don't really have data about the total number of villages or the communities living in in all 50 tiger reserves now. So that's something which has been there. And the approach of the conservation has been tiger centric. That's one of the criticism, and it is top down, where the plans and policies are designed at a centralized level. And the effectiveness, what we call about, is something which is more determined by the local leadership of the tiger reserves. And effectiveness is something which is also quite old. We have been talking about for quite some time. The 2000 Tiger Task Force also up in the aftermath of Sariska tragedy also talked about it. In 2006, there is a review by the CAG. Then subsequently, NTCA also comes up with these management effectiveness evaluations, which are mostly qualitative indicators. It has been subject to lots of criticism to this. Yes.
Please bind up.
Yes. So when it comes to the expenditure, and for this specific data, we have this specific thing that I would like to present here. We have taken expenditure pattern in 20 tiger reserves. We have used mostly the annual plan of operations of NTCA for this. And the tiger population, the census report doesn't talk about the tiger reserves. It talks about the tiger number at landscape level. So we worked with WWI scientists who are part of the census team who helped us in generating numbers for each of the tiger reserves that we have conducted. So apart from these allocations from the central government and the state government, it's basically tripartite agreement. The central government sponsors around half, the entire non-recurring expenditure, recurring expenditure being shared by the state and center. That's the arrangement. Apart from these NTCA allocations, the tiger reserves also get money from other kinds of sources, but the major part of the money comes through this. This basically shows the, I'm just rushing it through. Yeah, so in this specific study, what we did is for these 28 tiger reserves, we looked at all these annual plan of operations, and then we grouped the expenditure by these these 7 major headings: infrastructure, protection, habitat improvement, relocation, human-animal conflict, and what the interventions which you couldn't group into any of these, we group them into other activities. Eco development is a different head already there. These are not the ones which is already available. We basically group them by looking at the kind of activities they have. If you see the allocation pattern, for instance, how the money.
Please wind up, Dr. Nayak.
Yes. How the money? Give me 3 more minutes. How this money gets spent. As you can see, large amount of money gets spent on relocation, which is around 38%, followed by protection and 17% is infrastructure. A very small amount of money gets spent like that's 2% spent on human animal conflict. And like if you see these and like we did some kind of regressions to understand what kind of expenditure works, right? So we didn't really get any our estimate didn't really suggest us any specific interventions, what kind of it work. But what was interesting to look at is what kind of expenditure gets priority, right? So if you can see like infrastructure, which is one of the major heads of expenditure, you have very differential perspectives when it comes to across when it comes to officials working at different levels. A project director, for instance, prefers the money to be spent on on the infrastructures, the guest houses or the vehicles or those kind of things, whereas those who work in the field, they prefer money to be spent on more local compensation, human animal conflict, and those kind of thing. Like you have very varied perspective on this. Similarly, on the protection, the kind of some of the tiger reserves spend quite a lot of money in fencing the forest, but there has been other interventions where fencing the farmland have been found to be more effective than fencing the forest, because putting the solar fences in the forest has its own technical as well as practical operational challenges. Habitat improvement, something which because we don't have time, but human animal conflict is something which is one of the major driver of major challenges in a country like ours with such human dominated what they refer to as human dominated landscape, where you have so much of people living around, but that gets the minimum share in this. And compensation mechanism, when it comes to compensation for the human animal conflict that we have, is something which is also that involves huge transaction cost.
Dr. Nayak, request to wind up, please. Now we have another
my
speaker.
last slide. Give me one more minute to say. So wrap this up. This, you have high transaction cost for both claiming as well as getting the reimbursement of the claims. So there has been innovations like high instant compensation, easing the compensation claims through different using apps and technological methods, which which is mostly outside the forest department interventions, right? So field Project Tiger intervention, that's something which also we need to think about ways through which those can be mainstreamed on this. Engaging communities, it has been a big challenge, though there has been some progress in terms of engaging communities in the territorial forest, but when it comes to wildlife divisions, there has been very limited approach on this. And like any other department, forest department is not yet used to work with other communities, or what they call it convergence, to deal with these kind of issues. And there are new innovative methods like performance payment, which is in operation in other parts of the world, where some aid can be, or some kind of reward can be given to the local communities for biodiversity improvement. Can also the ideas which can be talked about. Yeah, thank you so much. I'm sorry for exceeding my time. Thank you so much, Chair.
Thank you, Dr. Nayak. I think it was a good presentation on Project Tiger and budget allocation. Unfortunately, we don't have that much time. Next time, probably we will hear you more. Thank you so much. Okay, now let me invite Dr. Balasubramaniam, please.
Sir, Anjan is there. Anjan.
Okay,
Dr.
Anjan, please go ahead. Dr. Anjan, please. Go ahead, Dr. Anjan, please.
So check your mic. Is your mic muted or something?
Dr. Anjan, can you hear me?
I think there are some network issues over there.
Okay. So can we take Dr. Balasubramanian, please?
Dr. Anjan is trying to say, but we are not able to hear him, and there are certainly some network issues.
Dr. Anjan, you are not audible.
Hello, sir, we are not able to listen. We are not audible. You can do that, sir. Or else you can give presentation orally. That will be also fine. Just to start the presentation. Yeah, just do that. Just thanks. Yeah.
So, can we invite Dr. Balasubramanian?
Yeah, Dr. Balasubramanian, please. Dr. Bala is here.
Yes, sir. Dr. Balasubramanian is sharing the screen.
Can you share my PPT? Things not coming. I don't know. Thank you, Chair, and I would like to also thank my colleague Professor Sunil Notial. I'm audible.
Yeah, please go ahead.
Yeah, Sunil Notial and NIDM for this good opportunity. So I would like to add some more points. Already my previous speakers they contributed many things about ecosystem services like Professor Ruji and Bibu Prasad also. They talked about the financial aspects. So this presentation mainly focusing on economic value of ecosystem services with a special reference to Western Ghats. Recently, we have completed a project funded by Indian Council of Social Science Research. We don't actually. I don't want to explain all the ecosystem services basic concepts because of already we discussed a lot. So directly, I'm going to the economic perspective. So here, most of the ecosystem goods and services they are not traded in the market, as you know very well. There is a lot of gap. No, the valuation of ecosystem goods and services. So why we need ecosystem services? That is very important. I mean, previous literature already they mentioned very clearly about the economics of ecosystem services. Especially most of the ecosystem goods and services they are missing in the context of market. For example, especially the provisioning services. Some provisioning services they are estimated as economic value. Next one. Some ecosystem services. Yeah, stop. Some ecosystem services they estimated as economic value, but most of the ecosystem services like of regulating ecosystem services, cultural services, supporting services, they are totally missing in the market. The second point, the imperfect market or market failure. If they are, there is very basic problem in the ecosystem services literature, especially in the context of economic things. So market failure is one of the reason for degradation of most environmental goods and services. So that's why reason most of the economists they want to try to put some price to the nature. So since 1997, the famous paper by Professor Costanza, the estimated economic value of natural resources, especially ecosystem goods and services for 17 biome at the global level. The 1997 the nature paper was 18 times of global GDP. And that was the first paper and pioneer paper for economic valuation of ecosystem services research. The third point, the uncertainty involving demand and supply of the natural resources, especially in the future. In the current economic development model, they are exploiting number of goods and services, especially the ecosystem goods in terms of stocks. So we don't know about the future demand of the natural resources. So that's why reason at least we need some basic economic price for the natural resources for conservation purpose. Most of the social science aspects So sociologists, they want to put their own aspect for conservation of natural resources, and biologists, they have some kind of model for conservation of natural resources. But economists, they want to try to estimate the economic value that is for the conservation purpose. But this economic value not only conserve the natural resources, that is a more some addition point. So that is another reason. Most of the government, central and state government, they want to design the economic policy without knowing about the ecosystem goods and services. That is a basic reason. So forest policy or biodiversity policy, the how they are designing the policies without knowing the value of ecosystem goods and services. That's why if you do the valuation, the local policymakers, they can understand about the value of ecosystem goods and services. Finally, natural resource accounting, it is a very famous concept since of 1990s. Under the United Nations Statistical Division, they have the separate chapters, a system of environmental economics accounting, they call for SIAM methodology. They have SIAM methodology for forest, I mean, renewable resources and non-renewable natural resources. So in the context of India, still we are in the very beginning stage for estimate of economic evaluation of natural resources. After estimation, the evaluation resources, most of the studies, they are not properly integrating into the national income account or state income account. So these are the
Dr. Bala, your slide is not moving.
Okay, yeah, can you move the next slide? So there is the, I mean, these are the some reasons why we need for ecosystem services. As an economist perspective, first economists, they want to put, I mean, benefits. As you know very well, what are the benefits we receive from the ecosystem services, whether it's economic benefit or social or cultural benefit or ecological benefit. So the economic perspective, an economist already they framed the concept of a total economic value. The total, next one. The total economic value here, the use value and non-use value, the direct use value and indirect use values. So people, they can consume directly from the forest ecosystem services or wetland ecosystem services or dryland ecosystem services or reserve forest or protected areas. Then second part is non-use value. That's called for, I mean, option value and the extension use values. So these are some basic framework in the economic literature. They call for economic valuation methods. They call for total economic valuation. Next one. So here, these are, I mean, our study, we have conducted 3 protected areas in the Western Ghats. The one is the Pilligiri Rangasamy Wildlife Sanctuary. It's very famous in the for tourist place. The second one is Nagarhole National Park. The third one is Bandipur National Park in the Western Ghats. Next one. So these are the methodology we adopted. The provisioning ecosystem services, as you know very well, the basic market price method we use them. Then the second economic evaluation, soil erosion prevention. The third one is a carbon sequestration. The fourth one is the recreation value of ecosystem services, particularly for the tourism. Next one. So these are the provisioning services, as you know very well. Most of the tribals and forest dependent communities, they are directly and indirectly depending on the forest and ecosystem services. They are collecting, like, I mean, the non-timber forest product. So most of the non-timber forest product, already I said, whether it's a market failure or imperfect market or missing in the market. So that's why the reason we need proper price for designing, I mean, forest or ecosystem services policies. So we have to give more weightage in the economic value of provisioning services. So still is in the consideration in whether it's the government of India or the government of Karnataka. That's the reason our argument, we need proper price for the non-timber forest product. Next one. So this is the regulating services. As I said earlier, most of the provisioning services only they consider as economic value. If you see the regulating ecosystem services such as water regulation, carbon sequestration, soil regulation, these are the ecosystem services given by Millennium Ecosystem Assessment and the economics of ecosystem and biodiversity. All the the regulating ecosystem services, it is widely, the vital contribution to the human well-being concept. Already I said how we are measuring the benefits from the nature. So how much contribute to the human beings in the context of benefits. So the regulating services, it's missing in the context of economic evaluation. That's why the reason SIA or the TEEP and Millennium Ecosystem Assessment, they tried many methodologies for valuing of regulating ecosystem services. So we applied some very basic methodology for estimating economic value of soil erosion prevention and carbon sequestration for our Western Ghats and the 3 protected areas. Next one. So these are some results. Actually, what we estimated based on the survey. First, the Pilgiri Rangasamy Wildlife Sanctuaries, the provisioning services, the value, 30.24 millions based on the market price method, 140 household survey. The second one is carbon sequestration. Really, it's very interesting result. Nearly 75 millions of Indian rupees. The third one is economic of soil erosion prevention, 2,396.98 million. Then the final one is recreation services. So the recreation services we applied through the travel cost method based on revealed preference approaches in the economic literature. So the second one, the Nagarjuina National Park, because of due to the lack of data, they are not allowing collected of primary data for the household. That's why we estimated only the carbon sequestration 89,000 millions. I mean, yes,
Sir, come to the
2,000,
concluding
yeah,
part.
2,500 millions in the soil erosion prevention. Then 55.8 million the recreation services through the travel cost method. Another one is Bandipur National Park. The same thing due to the lack of data, not able to estimate the provisioning ecosystem services. So the carbon sequestration is a very high provided by Bandipur National Park because of there is a huge area. The next one, soil erosion prevention, nearly 3,486.77 million. Finally, recreation ecosystem services through the travel cost method, 5.7 million. So these are some very interesting results because of in government of Karnataka. I mean, the Karnataka in the context of Karnataka, there is number of studies already they investigated the various aspects. For example, the forest management. Livelihood aspects and conservation aspect, but still there are some scare in the context of economic evaluation. In ISEC, it's very familiar for economic evaluation of ecosystem services. Our former professor Nainan, he estimated with his colleague some very limited geographical areas. For example, Nagarjuina National Park. So this study we have covered nearly 5 protected areas. Due to some lack of data, we could not be able to add the 2 protected areas. So these are some very basic results. Still, we are in the very beginning stage in the economic evaluation of ecosystem services. As we know very well, Western Ghats is one of the global biological diversity. But in the context, how much we are receiving from the Western Ghats, that's the reason there is some policy debate. What basis the policy allocation going to conserve? I mean, going every year for conservation purpose to the Western Ghats. That is our argument. Because of we have we have some meetings with the state government forest department. We already suggested we need.
Please wind up.
Yeah. So we need basic. I mean, very basic level first. We have to estimate the economic value. We should know the value of ecosystem services. Then only we can argue how much we need from the state government for conservation of the natural resources, especially in the Western Ghats purpose. Next one. So this study also we estimated the consumer surplus, as you know very well, how much tourist visitor they would like to willing to pay and actual pay. The difference between the two things, the consumer surplus based on the microeconomics Marshall in demand theory, we estimate the consumer surplus for Pilgiri Rangasamy Wildlife Sanctuary for per tourist visitor. They would like to pay, the consumer surplus 38 rupees for the total the social benefits from Pilgiri Rangasamy Wildlife Sanctuary, 3.8 million. The Nagarjuina National Park, 55.8 million. The Bandipur National Park, 5.7 million. So these are the consumer surplus. Some interesting things are there. How much? The existing entry fee. This is more than. The existing entry fee. It's very low. Most of the tourist visitors.
Sir, we have one more presentation, so
yeah.
please be
So
precise.
most of the respondent they would like to pay more than the entry fee. These are the some things. So that is very interesting policy implication for designing entry fees for the national park and other protected areas. So next one. So these are some policy recommendations from our studies. So linkages between economic and environment with the wide details of natural capital. The natural capital is one of the very important contribution in the economy, but missing in the calculation of economic value. Already I said them. without knowing the ecosystem services things, they are designing the policy. That's why reason we need the basic link between ecosystem services and economy for designing, I mean, in the policymakers. The second one, the regular update regarding on the production.
Dr. Bala, please wind up.
Services. Yeah, sure. So, I mean, the regular update for forest and ecosystem services. Third, policy implication, forest and ecosystem accounting. So the accounting purpose also is very important for the evaluation purpose. So designing conservation, the identifying region which high, I mean, ecosystem services value cluster together to potential information to the support the decision maker. Which area is high ecosystem services we are getting, which area is low ecosystem services we are getting. So finally, inform to the implementation of mechanism such as a payment for ecosystem services. Why government of, I mean, Indian context, payment for ecosystem services is very less attention. We have to estimate the valuation. So these are the some things. I thank chair and I mean organizer, my colleague Professor Sunil Notial and NIDM for this opportunity. Thank you.
Thank you, Dr. Bala. I think it was a good baseline presentation on ecosystem services. There are a few things like there is a model called Invest. If you invest, apply on the ecosystem services, you can scale up this same results. We have done the same work for Narmada River Basin.
Thank you, sir. Thank
okay.
you from Stanford. Yes.
Dr. Anjan, please go ahead.
Yeah.
Dr. Anjan, please.
Yes. Just.
Dr. Anjan, we haven't received your PPT.
Yeah.
We haven't received.
Oh, it has not been sent?
No, आपका इंटरनेट में कुछ प्रॉब्लम है उधर। कल निवार का इम्पैक्ट उधर भी पड़ गया मुझे लग रहा है।
I think so.
Dr. Anjan, without presentation, if you can go ahead and brief us and incite us for next 5 minutes, that will be great.
Yes, I think that will be better. So I'll do that.
Yeah.
I'll do that definitely. Maybe though the more we feel we are technologically robust, we are also a victim of yeah. So the talk which I wanted to deliver, a brief talk, was about wetland ecosystems and especially recognizing the stressors and drivers. And basically, as the audience is an amalgamation of from different domains, everybody knows wetlands when we consider it as a common property resource. So it is basically nobody owns it, and there is no ownership defined. And that's how the major stresses on the ecosystem is non-judicious use and unsustainable practices and harvesting. That's how precisely Ramsar Convention in its first declaration itself had mentioned precisely that it has to be a wise use of the resources, wise and sustainable use of resources. So now what we do basically in wetland conservation is something that is that requires more in-depth deliberation, is the framework of pressure, state, impact and response, PSIR framework. That is what precisely helps us. So pressure from nature and human-made dimensions, state, it is environmental, natural, resource-based, impacts, it is well known, and responses, how policymakers do respond to it and how different stakeholders do respond to it. Now, when we have wetlands categorization, and I would like to give example of Indian context, starting from high altitude glacial wetlands to coral reefs in Lakshadweep Islands or Jamnagar Marine National Park. We have recognized Ministry of Environment and Forest has recognized almost 19 different habitat types, wetland habitats, and all the 19 habitat types are equally unique in terms of their potential to provisioning various goods and services. So there are a couple of critical variables that we need to consider while defining the stresses and drivers in wetland ecosystems. One is the hydrological condition, the physiochemical environment which drives the hydrological condition and in turn gets driven by the hydrological condition, and the biosphere and the biological domain. So in hydrological condition, basically something which is more in scientific fraternity considered as a hydro period, and the time and duration and wetland remains inundated, and the way there is something, a concept of annual hydrograph, how the water level keeps changing in a particular wetland ecosystem, and that also it becomes a deciding factor as how different biological species respond, and biological species prefer to stay in the particular wetland ecosystem, because wetland ecosystem is not just an ecosystem, it is having a specific linkage, food chain linkage in the ecosystem. And then to give a case study, anyway, I could not present it, so I will, it will not be that easy to appreciate the case study what I will be presenting. So we had carried out, a survey of almost 42 wetlands in and around Bharatpur, Koladio National Park, which you considered as a satellite wetland. Satellite wetland, the concept is with the framework of use of resources. It is something like meta population and small island population kind of concept. In that, when we roamed around all the 42 wetlands, we segregated different wetlands into categories which can hold water for 4 months, which can hold water for 7 months, which can hold water for 10 months, and there are certain wetlands which can hold water for round the year. So round the wetlands having capacity to hold water round the year are essentially the reservoirs and dams, which are human-made structures. But then there is a clear-cut distinction between like how the rainfall pattern has been in that area. We compared the rainfall data from 1960 till 2020 and how different species. So the main central wetland is the Bharatpur Bird Sanctuary considered, and how fish, aquatic freshwater fishes are entering the wetland ecosystem, by which, because of this food source, it becomes a favorable place for many of the migratory water birds during winter months. So we checked for their movement pattern for 24/7 to analyze their circadian pattern. So biological clock, biological rhythm, we try to check, and there is a clear-cut distinction between amount of water comes in, timing of water comes, and the timing of congregation of birds and the fish abundance in the canal. And the long-term study, interestingly, the long-term this fish fauna study has been continuing from 1981 till 2018. So somehow we have been managing the resources and carrying out this study. My previous generation researchers have done, and I carried forward their efforts, and we are doing till 2018. There was a clear-cut timing when during late 90s and early 2000 there were drought period, and during drought many of the fish species which used to come to the wetland disappeared. We were not able to report them. But in 2014 to 2018, when there were extensive flood incidents, periodicity of flood increased, we recorded some of the species which were recorded during 1980, 82, 85, and so on. So this actually, it is an evidence that the hydrological regime, if there is a connectivity in the hydrological regime, it supports the ecosystem functioning. It supports the biological components to remain active in the ecosystem, which is a part of the whole food chain. Whole food chain. And there were different daytime activity, nighttime activity, and so on. So anyway, I'm not showing that component here. And then the other component which is quite interesting, which acts as a driver, is your wetland water budgeting. So if it is a recharge wetland, the situation is different. If it is a discharge wetland, the situation is different. And paradoxically, what happens in every city, the wetlands are being killed. So what we otherwise called as in Bangalore presentation, I have been watching since 2 days, they call urban water body. The urban water body, whatever is being killed by municipal corporations in a very strategic manner. First, there has to be a dumping of municipal solid waste. Over the years, when it gets filled up, then it is being converted into a football playground or a bus stand. But then ultimately, its property, either it has to be a recharge wetland or the discharge wetland, that is gradually died. The wetland dies of a natural strategic death. And then we also have certain ecosystems like mangrove ecosystems. Its ecosystem services are well known, especially among the audience we have here now, fraternity. Everybody knows about the ecosystem. kilometer of wetland area in India. And yes, so ultimately the ecosystem services, whether it is provisioning or regulating or cultural services or supportive services, at the end, all the 4 services are aimed at human well-being. But human beings are part of ecosystem.
Can we hear Dr. Putti?
No, I cannot hear. I think there is some network issue.
That there are things for which the ecosystem service component also should be, applicable. And as per the recent assessment by Ramsar
Dr. Ranjan,
Convention,
can you please bind up? Please bind up, please.
Yeah, I have 2 more slides only, 3 more slides. So as per the recent assessment by Ramsar Convention, India has 41 Ramsar sites. 2 Ramsar sites were recognized in 2011, the latest one being the Sur Sarovar wetland in Agra, near Agra, and 41 Ramsar sites have been assessed for different types of threats. And it is very alarming to know that not a single Ramsar site we have which do not have more than 5 different threat categories. Every wetland is suffering from different threat categories. And the last one is invasive species. The invasive species called Prosopis juliflora, जिसको विदेशी बबुल बोलते हैं, northern and western India में. Once it is accidentally exposed to some of the areas, then it just invades the whole ecosystem and it completely drives away the ground vegetation. So that is one challenge. And in aquatic organism, the fish, carnivorous fish like Clarias gariepinus, like African catfish, they also become a challenge for ecosystem management. So when it is climate change perspective, many of the aquaculture farms, they go for short-term return and high biomass species, that is Clarias gariepinus, without realizing its impact on the natural species, compositions. And in the end, because of the uncertain rainfall, farmers keep on applying more and more agrochemicals, so chemical fertilizers and pesticides. And the classic case is the repeated bird mortality, what we have been observed in Bharatpur during late 90s and early 2000. There is mass mortality of birds, and I don't wish to have such kind of mortality across the country. So there is a need, to integrate these all components into water resource management strategy, so that deadly chemicals like aldrin, monoprotophos, DDT, chloropyrifos, when there are a lot of urban wetlands are coming to the picture in the conservation discussion table, the issue comes is municipal solid waste management. We have one of our recent paper which has appeared in Current Science. It clearly describes how urban wetlands are being affected by municipal solid waste, because when we throw our colored rubber bands into the dustbin, it goes and gets started floating in the wetland. Poor birds who comes to feed on the wetland, they think the floating rubber bands as some worm. They think that it mimics like their food material and they eat it. So that there comes the actual problem. And there are a lot of endocrine disrupting chemicals.
Dr. Ranjan, please wind up.
Yes, sir, it's already
This
too
is my
late.
concluding slide.
No,
So
sir.
Please wind up. Please wind up.
Sir, yes, sir, because we were supposed to end the session at 5, but we are too late. So please, sir. Sorry, we will
This is my
discuss
last
some
slide.
other day, maybe.
This is my last slide. Thank you so much. This is my
Thank
last
you.
slide.
Okay, thank you, Dr. Ranjan. I think it was a nice presentation on wetland, especially, I can say on Kevladev, Bharatpur, which is my native, and I know much details. So whatever you have said, I think that's totally correct. Thank you so much for the nice presentation, Dr. Ranjan.
Thank you.
And with this, I think we will end the session. So we have the 7 speakers in the session, and all the 7 speakers were quite distinguished, and it was a quite knowledgeable and ideas exchange program. So thank you so much, everybody, and thank you for Institute for Social and Economic Change and NIDF for giving me the opportunity to chair the session. Thank you so much.
Thank you so much, sir. Thank you for being with us. And I'm really happy. I just saw this your post that you were among the top 2% scientists of the world, and thank you, congratulations, sir, and thank you, Professor Sunil, sir. And I know this session was supposed to end at 5, but it took us so much time, and thank you so much, sir. Thank you from NIDM.
Thank you so very much. I take only 30 minutes.
Yes.
Third is no. Second.
Okay, sir.
So thank you so very much, Professor Manish Goyal, for conducting this session very effectively. 8 presentations were summarized in a very short time, I think, but all the presentations were, despite of time constraints, all the presentations were able to communicate the interesting findings of their case studies, which our scholars have done in various agroecological regions of our country, and credit goes to you for successfully organizing this interesting session. Dr. Goyal, please, we give big hands to you.
Thank you.
Special thank to our collaborator and organizer, one of the organizers of this international workshop, Ms. Dr. Fatima Amin, for moderating this session. Thank you so very much. And we are truly privileged and honored to have Dr. Shalini, Professor Francis Berle, Professor A.G. Kopad, Professor Ruchi Badola, Dr. Bibu Prasad Nayak, Dr. Anjan Prusti, and my friend Dr. Bala Subramaniam. I thank you all for sharing your vast knowledge with us and providing so many thought-provoking ideas to us to conduct the research in this contemporary theme of the workshop which we have organized together along with the NIDM. And thank you so very much. Have a lovely evening. And I request you all to join us tomorrow. We have 2 interesting panel discussions. One is panel number 5 is on climate change and sustainable development goals. Professor Ravindranath and Professor Uma Shankar and many others are contributing there. And the panel number 6 is on human wildlife conflicts. So scholars from Germany, Bangladesh, and India are contributing to this panel. And in addition to these 2 panels, we have 2 technical sessions. So please join us and share your vast knowledge with us. Also, all your presentations and your manuscripts, we may request you to please send to us as early as possible. All questions, we are making documents. All questions will be sent to the respective speakers so that they can communicate to the participants and they can respond to the queries which arise during the course of their presentation. Thank you so very much, and namaskar.
Namaskar.